to our course. So the first lecture is on the data types, and as I would like this course to be very practical and hands-on learning and practicing coding, etc., I right away start diving into the coding environment so we can easily test everything here together. So basically, this is the environment that I'm using here, but it's not important what environment you're using. Whatever you're using, either it's online or it is installed on your desktop, Mac, or whatever. The important thing is that you just keep trying and you just keep making mistakes and try and start doing it. It may in the beginning look like, okay, this is too easy in the beginning. I don't even need to try it, but believe me, you need to try and you need to start coding. So in the beginning, when we have like as you see here, everything is commented, but how things are commented in C++. If we want to comment something, for example, now I would like to make some changes. As you see here, we see the red part here, meaning that we did some modification, but we haven't registered it yet. And the modification that I just made was just pushing the tab button a bit so the line would start from not from the start, but a bit further. So here we want to write something like author is Reza Shahin. So as you see, this is unknown type name for the programming language, and it returns immediately, it returns error. In order to keep some comments, we can just put two slashes here, so it is now commented. I can have this one here, like the author, the date, the I don't know, this code is the first version, for example. All these information can be commented, and then you start your code as of line 20, for example. So when I push Control S, everything is saved, and you see the green light here saying that, okay, this is now registered. So this is the first type of commenting in the code. And the second type is in C++, we can have slash star and then star slash in the end. And whatever that are between slash star and star slash are commented. As you see here, for example, for data types, it is commented, so it doesn't have any problem for the code and the compiler. Let's start from the line 1. This is the default include that we consider for the C++, and we include this one for considering a string in our code. But just by default, consider these two these two including parts. Later on the course, I would discuss different including things that we can consider and why they are important. But this is not the point of our lecture today. So these two includes are now working. The rest are commented as there are two slashes behind them. A typical C++ programming would have like a few lines for including lines and then one int main function. So when we open the int main function, the first lesson is the data types. So data types, we want to start it. As you see here, we put some information in commented, but the things that we would like to discuss in today are also commented. So I remove the slash. You see here, now we defined one integer value named a that is set to have the value 1. But we have one warning. It says that you declared one integer value and you have not used it yet. It's okay, but we are going to use it later. But it is just sending us some warning to consider. So the first data type is the integer. When we want to declare an integer value, one of the ways is to define it as int I, int, and all of them should be lowercase. Equals to 1, and then we have a semicolon there. So we can also have like int. When we used in a, one time we cannot say another time a. For example, I cannot reassign a. It says that redefinition of a, so there is an error. I would say a1. So a1 is 2 now. So we declare two integer variables. The first data type that we need to learn is the integer. And then we have the type float, that is for numbers that are having decimal values. So we define the float b with the value say 3.14, and we need to be careful about the semicolon in the end. Whatever we write in our C++ programming, it must end with a semicolon in a line. So it still gives us some warning saying that it is unused. Again, it's not a problem. We're going to use it. So there are two ways to define numbers that are having decimal values. The first one was float, and the second one was double. So we can also declare double when we are having a number with decimal values. And there are some, small differences between float and double that we will discuss later on in the course. However, if you want to just have a clue of the general differences, is that when we declare a number with the float type, it uses usually 4 bytes of memory, and when we declare it as a double, it uses 8 bytes of memory. So what's the difference? So it consumes the memory more. So if we are going to use a number that is larger than a certain amount, it is recommended to use double, so it gets more memory usage. But if we are going to simply use a number with decimal values that are not so much large, we can simply just declare them as a float. But how large, how small they should be to choose between float or double, this we will discuss in the comparison that we will make in the upcoming lectures. But for the moment, that is enough for you to know that there are two types, float and double, that you can declare either of them, but there are some differences in terms of the memory usage. And also double can represent a wider range of values compared to float, because because of its higher precision and larger memory size. So this is the only thing that we need to know for the moment about it. And then we have characters that we can define, like character. It is with the name char, char, and this is char name. It could be whatever. It could be like my character equals. It should be. You should really be careful about the quotations here. Like whatever you want to put there, you can put, for example, my name, Reza. It's okay, but it should be between these two quotations. If we forget about one quotation, we will have error. If we forget about two quotations, we will have error. So it must be between two quotations, and of course with a semicolon in the end. And the last one that we would like to discuss is a Boolean type. We declared an ABC named Boolean that could be whatever, like my bool, we could declare equals true. So for the Boolean, there are only two values that can be assigned, either true or false, and that's it. It's either 0 or 1. When it's true, it represents the value 1, and when it's false, it represents the value uh, when it's false, it represents the value 0. For the float number, it's the same. We can declare all the numbers with decimal values, and for the integer, it's only integer values. Sorry, for example, we cannot have an integer declaration for a and then consider having it with decimal values. It gives us some warning saying that you need to use double or maybe float for this and not the type integer. So these are the basics data types that we needed to know in the beginning. Then we learned about how to put comments. You see here now our code, we push the Control S and our code is registered, and these parts are comments. So whatever we put there, like whatever we type there, it's considered as nothing, as it is not even existed. So uh, this is the first way of putting comments, and then we have the second way of putting comments like this between slash star slash. And finally, we learned about different data types that we declared here. In the next lecture, we dive into more details about the data types. Hello, everyone. Welcome back to this course. So in previous lecture, we learned how to declare some different data types, like as you see here, integer, float, double, characters, and booleans. In today's lecture, in today's lesson, we would like to print their values. So we declare an integer a1, for example, equals to 2. And we would like to print this integer value and see it in the terminal. Here we prepared something for you. As you remember, everything is commented here in between. Everything is commented. So I uncomment this line. Oh, sorry, I put it more comments. So I commented this line. I uncommented this line. I declare integer a equals 1 semicolon, and it ends. So this is the declaration that we have here. And remember that we had some commented libraries and including things here. So one of them is using namespace std. So let me explain what this std is all about. So here, now I uncomment this line and we will have probably some errors if we want to run it. So if we would like to print something, we would have to write std colon, then cout, means that show us the output. Then we would have these two signs. And then between quotations, we would be able to have the comments that we would like to be printed in the terminal. For example, we write it here, the value of a is, and one space is put here, so, and then we close the quotation. Then we mention a, so the value of the integer that we wrote will be printed, and then we put end l. Before end l, I would write std colon end l. So this is how we can print it. So let's try this one to see how the result would be. I run and wait for the compiler to run my code. Oh, here is the result. The value of a is 1. So what was the message that we typed here? So the value of a is, and then instead of this part that we put a, you see the value 1 is printed. So now that we know the value of putting the value of this integer being printed, we would like to mention that using namespace is very good. So now, if what happens if I remove this std? If I remove this std and run again the problem, we will see that we have an error. It says undeclared identifier, and also this one. If I remove them and compile, it will have 2 errors. So std is very important to be written every time, but because every time we need to write it down, it is not very convenient. Instead, we could use this using namespace std in the beginning of our program and forget about it throughout the program. So now that I uncommented that this using namespace std semicolon, we run the program again. Okay, this time we don't have any errors, and voila, it is printed. So if we are considering putting using namespace std semicolon in the beginning of our program, we can escape using it throughout the program. But if we don't mention it in the above, we need to type it every time that we are writing. So this is the first point. The second point is that the syntax for printing is cout. So when we use cout, we are sending the machine that we want to print. And the end L, let me just remove this end L so you will see how the result would be different. In this case, because we have only one printing, the result would not change, you see? Okay, so you see the press return to close this window came to the line 1. Previously, it was in the line 2. So let me print something else. Let me print it again. Let me just copy paste this line one more time. So now what happens is this. So you see the value of A is 1, the value of A is 1, press return true. So everything is printed in one line only. When we have instead, when we have the end line, we will see that it goes to the next line. So when we have the end L, we have the value of A is 1, then goes to the next line, and the value of A is 1. Again, press return. So if I also put the end L in here, I will see that we have 3 lines now. We should have 3 lines. Okay, you see here. So the value of A is 1, the value of A is 1, and then press return to close this window. So this shows the value of using end L in the end of the line. And so this lesson was all about the cout. So we printed the integer A1. So what about the next one? So the next one is a float type. So again, if we want to print it, we type cout. We can type a message, or we can even type nothing. But because we want our program to be clear, it would be better to type some message. For example, the value of B is, and then we put B here, and L, we Control S register, and we compile. Yes. So we see the value of B is 3.14. So easily we print this one. Again, for the double, the same thing. We can easily practice this, like cout, the value of C is, and C and L. We also have the characters and booleans. So I would write them together like this. So the value of char name is, then I put the char name here, and L. Also, we can write the value of my boolean is, then we put my boolean Just you should be very careful with the uppercase letter and lowercase letter in C++ because it is sensitive. So if I'm writing an uppercase M here, I should have the uppercase M here again. So let's check to see if we have errors or not. So we don't have any errors. Okay, great. So these are the prints. So we printed 2A, 1B. You see that the B is between quotations because here I put the quotations in the printing part. If I remove it, it will be removed. Then the C, then the char name is A because we put the value as the input A. And then the value of my boolean equals 1. Why 1? We set true. So as we mentioned earlier, for the boolean, we either have true or false. So the true equals 1 and the false equals 0. So whenever the print value is 1, just know that it is true. Whenever it is 0, just assume as false. So this is how we print our values. This is for how we print our values. And then in the next lecture, we are going to discuss about the operations using these data types. Stay tuned. Hello, welcome back. In this lecture, we are going to discuss how do we do the operations in C++. Previously, we learned how to declare data types, and we learned how to print them in the terminal. So now in this lesson, we're going to do some mathematical operations with the declared data types. So let's dive into it. We declare two integer variables. The first one is int a equals 31, and the second one is b equals 15. So previously we learned that if we want to declare an integer or any other types of data types, we can simply assign a value to them. However, in this lesson, we're going to learn that we can do some mathematical operations for the assignment of data types. For example, we have integer c assigned to be the a plus b. So instead of putting the value of like 46, we can simply let the machine and the computer do the assignment, do the math part, and then assign it to the integer c. And also, if you see here, while I was commenting this line, the 77 line, we had two warnings for 75 and 76, these two lines. We had a warning saying that, okay, you declare these two variables, integer variables, these two, but you're not using them. So why it is returning some warning? The reason that it returns some warning is that we are using some memory of the computer by declaring a new variable. And if we are not going to use it, the system, the compiler would give us some warning saying that, okay, you declared this one and you're not using it. So you may want to consider removing it to release some memory. In this level of programming, it may not be very, very necessary to keep track of your memory. However, as we proceed through the coding and as we advance in programming, it is very important to manage the memory very well so we can increase the speed of the program or avoid having some memory leak problem, something like this. So for the moment, it's not important. However, now that I uncomment the line 77, we will see the warning for these two lines are disappeared. The reason is that we are using them. We declared something, A and B, and we are using them in the line 77. However, we are not using integer C. That is why we still have a warning for this line. So let's print out this line. We learned that if we are using namespace std in the beginning of our code, we don't need to write std comma comma cout every time. So here, when I have that declared in the beginning of the code, I just write C out, then I write whatever the message I would like the value of A is, and then I put the A here and L, and we run. We will see that it now needs to show us the value of A. Now it's compiling, we didn't have any error, so we see that the value of A is printed. So let's go for the next two lines. The value of B and the value of C is also printed with these commands. Let's try. We have no errors, it's compiling. Okay, so the value of A is printed like 31, the value of B is printed like 15. The value of C is also printed as 46. So the key point to today's lecture was that the math is done by the machine. We don't need to do the calculation. We just assigned the A plus B to C and it did the calculation itself, and now it's printing it. So now that we see that we have this option, we can uncomment these parts as well. Like we declare D, E, F, and G to be A minus B assigned to D, A times B assigned to E, A divided by B assigned to F, and A modulo B, which returns us the value of the remainder of when A is divided by B. So here you see we used integer C, so the warning for this line is disappeared now. So we still have the warning for the rest because we are not using them anymore. We're not using them yet, let's say. So let's print out these values to see how it would work. Now compiling, no errors. Okay, so let me bring it down here so we can compare it with the operations. Okay, now it's good. So A minus B is printed in D and stored in D. So it's 16, which is their difference. So A times B is 465, that is stored in E. We can see it in this line. And then we have the F as to be 2. So when A is divided by B, the value would be 2. And the remainder is 1, because when A is divided by B, which is 15, the remainder would be 1. If we change the value from 31, for example, to 30, we would see that the remainder should change. Compiling, no error. Let's see the result. Yes. So still we see that the A divided by B is stored in F. It is still showing number 2, which is correct. However, when we change 31 to 30, we have no remainder because these are so 30 is 15 times 2, so no remainder is rested will be there when we divide A by B. So in today's lesson, we learned that the operations can be done by the machine, and we tested some beginners operations, mathematical operations, and let the machine do the mathematical formulation. In the next lecture, we are going to do the same mathematical operations, but to the float data variables. Hello again, welcome back. Today we're going to discuss about the operations, the second part about the floats. In the previous lecture, we discussed how we do the operations for the integers. And in today's lecture, we are going to do the same operations with floats. So we declare different floats here as A, B, and then as of C, we have the operations involved in the assignment. So C equals A plus B, D equals A minus B, E equals A times B, and F equals A divided by B. So there is one thing to be very careful about when we are doing these mathematical operations for the float. So all of these operations are possible to be declared and assigned for a float, but for the module, it's not working. So this is some limitation of C++ that it does not allow to use the modulo operation for the float value. So we need to be careful about it. In case you're seeing this error in your compiler, you need to be careful. You need to think, oh, okay, this is not possible for the float. So it says that it invalid to binary expression float and float. So it's not possible to do the uh, module operations for the float. However, the rest of them are easy to do. It's exactly like the integer data types. So here we compile, so we see no errors. So the error is gone when we commented everything about the module. So it does print the value of A indeed, the value of B, and then C as the A plus B, and then D, E, and F. So this lecture is very similar to the previous one. This is only to keep noted that we cannot use module for the float variables. Hello everyone, welcome back. In today's lesson, we're going to talk about library functions. So for the library functions, there are a few things that we need to know before we dive into the lessons. So there are some already defined functions and libraries in C++ that can help us to do some mathematical operations. And there are some reserved strings and let's say strings for performing these mathematical operations. So when we mention that there are some reserved strings for these things, it means that we cannot use these reserved ones to name our integer, to name our own newly defined string, etc. But now I will give you more information so you will get to know that. But before we go for the library functions, we go up to the code in the beginning of our code. Here, because I want to use these libraries and I want to use the already defined library functions of C++, I need to include it in the C++ program in the beginning. So don't forget to include CMath before we dive into these lesson. So in order to proceed here, we wanna show some already defined library functions in C++. So we define, as before, we define two integer values like x and y. The x equals 25 and y equals 4. And as we are not using them, they are like having the warning in the code now. In order to print them, we use the syntax of cout. We know it very well now. And in the end, we put the end L to make sure that it goes to the next line for the following codes. But what are the reserved functions? The first one is sqrt. The sqrt function gives us the a square value of a number, of an integer. So when we define an integer here like x equals 25, and when we want to uh, have the square root of the x, we can simply write sqrt, and within brackets we put the number. So easily it will print us the square bracket of the integer x. So let's compile and see. So now no errors. Exactly. So the square root of 5, a square root of 5. So what we had there was something like a square root of x is 5. So the better typing would be the square root of uh, x, and then we put is the rest of the code. So this can give us a better output and more clear output. So let's check it out again. Let's try this. Yeah. So the square root of 25 is 5. So this is what it is now printing for us. So the first library function is the sqrt. The second one is that when we want to do some mathematical formulation or have some countings in our code, simply we can, for example, instead of doing the math ourselves, like 4 times 4 equals 16, we can define 4 as to be an integer named y, and the power and y to the power of 2 would be like this: po bracket y comma 2. So this code will help us to have the result of the y to the power of 2. Why we are using this? Let's see the print and then I will explain. So it says that power y2 is 16. So here I say power y, so let's say y to the power of 2 equals 16. So why do we need this formula? This formula would be helpful when we have a lot of computation that we need to do. It's easier to automatic everything in the code rather than dive into the details. So it's easier to let the machine do the formula, do the math part for you, and just you use the formulation so you can easily make sure that everything is handled correctly and very well. So the next one is that we define a new integer value, integer variable. We call it val, and the number that is assigned to it is -5. Then in order to have the absolute value of x, we simply can use this formula abs. Within the bracket, we put the name of the integer variable that we defined. So let's compile and see what the result would be. We have no errors, it's compiling. Okay, now the absolute value is 5. You see? Here we assigned -5 and the absolute value is 5. So it is giving us the absolute value. It's a very straightforward library function that we can use in our code while we're doing the formulations. So the next one is we define a double called num, and we assign the number 4.3. And so in order to have the rounding up a number to an integer, the nearest integer to it, like rounding up to the nearest integer, would be using the cell function. So we say cell within the bracket num, it will give us the output of 5. So the output of 5 is expected to be seen here. Let's try and see what would happen. Yes, so here we see that the ceiling value is 5. So the value, the original number was 4.3, but the ceiling value is 5. It is rounding up to the nearest integer. Again, we can do this for like the other way. The other way around would be to round down a number. So to round down a number, we define another double called num2, and we assign the value of 4.7, and instead we use the floor function. So instead we would use the floor function, and this time we are expecting to see the output as to be 4. Now compiling, no errors. Yes, the floor value equals 4. Let's check it out again here. Sorry. Let's check it out again here. Yeah, so the original number was 4.7 and the printed number is 4. So it rounded down the double number. So another function that would be very helpful for us in C++ would be the following. So if we have two numbers and we want to make sure what the result of what the larger number is among these two. So it's sometimes you might say that, okay, so if we know two numbers like 2 and 7, we already know that the larger number is 7. Yes, this is a straightforward. However, in the day-to-day coding, you may define two integer values in the beginning of your code, like let's call them x and y. Then you do a lot of computation on these two values. And since the machine is handling all the computation, you don't know that x would be larger or y would be larger after like 100 lines of code being done for the calculation. And in the end, you just care about the larger number. So instead of, reading all those lines and going through the details, etc., you can simply use this library function. So in the end, you can simply just find fmax, the integer value for the first integer value, and comma the second integer value like here, and then it will just give you the largest value. So here we use fmax, and there are two values, 3.7, 3.5 and 7.2, and obviously the larger is 7.2, so you can easily get the larger number here. So this is the maximum, 7.2. As I mentioned, it may be straightforward, but when you automate everything in the code, like in tens of lines of code, in the end, you don't need to go through the details. You just simply use this function and it will return you the larger number. Hello everyone, welcome back to this course. In today's video, we're going to talk about how to read data from the terminal. So previously, we used to work with like this, like we would say int a equals 10, and then we learned how to uh, print it. So the value of a is a and l. So previously we learned about this, so we compile. So compiling, no error. So here we see that it printed our data. So what if we want to read the data actually from the terminal? So if we want to do that, if we want to read the value a from the terminal, we should change our approach somehow. So we can change our approach like this. We just define our integer data type, like called a, and then we learn here a new syntax that is cin, and then we see in the a that we have here. But in order to read it from the user, we need to first show a cout message to the reader, saying that, for example, whatever you want, you can say that tell me what your number is, and then we close it. Then we store the number that the user tell us. We store it here, and then we show it here. Let's try this program together to see if it works or not. So yeah, it says that tell me what your number is. So I would say 10, and it returns me the value saying that the value a is 10. So here we declared the integer, then we sent a message through the terminal to the user saying that, okay, tell me what your number is. And whatever the user enters here, it will be stored in the A using the cin syntax. And then here again with the cout syntax, we show what the stored and entered integer value was. So let's have some more examples here. So here again, I define another int. So let me comment the above lines so it's clear. So we have an integer value called number. We show the print value to the terminal, enter an integer, and we read the number, and then we show the number. So it's again the same procedure. We first declare the integer, we show the message, and then we store the number that is entered by the user, and then we show the output. So here again we compile. Let's see how it would work. So enter an integer. I would say 14 this time. It says you entered integer 14. So it stores it here. So the application of this is very widely known. For example, if you want to enter your panel through a website or where you have registered already, so you enter your for example, username for the first time and the password for the first time. So these two are stored in the database of the website if they're using C++, for example, one option could be using cin. So they store it in their database, and the next time that you want to visit the website or wherever that registration is, you enter everything and they check your entered data with their already stored database, and if it's there, they say okay, you can come in. There are some if conditions to check before they let you in that we'll discuss later on this course. So this is how integer is done. Then if we want to consider a character, so let me comment the ones that for integers here. So we have a clear code. So let's say I have a character defined that is char and the name is character. So that is char. You can call it whatever you want. Instead of that, I can say my char, for example. I would say this. So whatever you want, it's your call. So then we show the message to the user saying that enter a character, and then using cin function, we store it. And now here we have an error because we changed the name of the declared character. I would say my char. So and then here we should have another error because we need to change the character here. So here what I'm doing is that I am declaring a character. Then I'm showing, again, I'm going through the procedure. I'm showing a message to the user saying that, okay, enter your character. Then we store the character using cin function and we print it out. Okay. So for a character, we know that we need to store only one letter. So let's compile. We're compiling. Let's check it out. I would say R. And it returns me my character. Let's compile again. This time, for example, I would say A. It returns me the character again, A. So, but what if I want to put two letters like RE? It returns only R. What if I want to store more than one? Like I would say Reza. It only returns me R. Why? The reason is that we declare it as a char. So char only is able to store one letter, not more than that. So even if you write many letters there, it does not register it. It only is able to register the first letter. So this is something very important to keep in mind while you are using the characters. So what if we want to consider more than one letter? So then we don't have to use char or char, we are only using string. So in that term, let me comment these lines so everything is clear, so we know which lines are currently working. Let's go down. Yeah. So here we need to declare string. So when we want to use a string, we need to be careful to include this in the beginning of our code. So we did this already in another lesson. Here, string is included, so no worries. So we are calling the libraries of the C++ when we are including this. So, okay, we declare one string, the name is word. The name could be whatever you want. So here I name it as word. Again, the same procedure. We show a message to the user saying that enter a word, and then store the word using cin function, and then we simply print it. So this time I compile. Let's see the result. No error. Okay. Enter a word. I would say Reza. This time, because we declared a string, it returns the full letters. It's not only the first letter like car. So let's try again. I would say whatever you want, like Amir Hossein. It returns Amir Hossein. Whatever you want. Let's try again. We say peer. It returns peer. One important point about the way that we are reading the information from the input is the following. So here I'm defining a string. I'm storing everything using cin function. So cin function cannot go after one space. What that means? That means it means that, for example, when we were having characters being stored, only the first letter could be stored. When we are having a string being stored using cin function can go up to no matter how many number of letters you have in your string, but there should be no space between them. If there are spaces between them, it cannot differentiate it. Let me just give you an example. So here we wrote Reza and Reza was okay. But if I push this space and then I write, for example, my last name, it returns me only the first part. So when we are using the cin function for storing the input, to read and store the input, it goes until the first string, and the second one is missed out because there is a space there. So, but if I compile again and write my first name and last name like this, it's okay. But there is no space here. Usually we put a space there. So what do we do? This is one of the problem using cin function. So let me just comment again. So here I'm commenting everything. So we go to the next lesson. So here I am declaring another string. I am couting, just enter 2 words or 3 words or whatever, and the full string, just whatever. But here I'm not reading the input as before. So before I was only using cin, but here I am using a get line and within bracket cin input. This helps us to read the entire line and not only the first word. Let's try this one. So if we try this one, let's see what happens. So if I write Reza, it will say Reza. Let's compile again. If I write Reza Shahin with a space, it gives me Reza Shahin with a space. And if I say like Reza Shaheen, it gives me the full line. So this is the one of the important things that we need to consider while reading the input. Depending on what we want to get from the user, we need to code based on that. Initially, we showed that an integer value can be declared, then a message sent to the user. We store it using cin, and then we show the message. We can do this with the characters, but only one letter can be stored in characters. So if we are aiming to get an information from the user that is one character, we use char because it uses less memory. But if it's more than one character and one letter, let's say, we need to use string. And if we want to use a string, if the string is only one word and no space there, so we can simply use cin function to read the data and store it. However, if there are multiple words and there are some spaces between them, we need to use getLine instead of cin only. We use the function getLine, and within bracket you just type down cin input. This is some predefined function from the C++. Then you store it. Thank you very much for following this course. In the next lesson, we will dive into the deeper understanding of C++. See you there. Hello everyone, welcome back. Today we are going to do some exercises. So this is the video for the first coding exercise. So write a C++ program that reads two numbers from the user and print its result. So this is the exercise that you need to do on your own, and you should be able to do it on your own since you've been seeing these videos and I have taught all the necessary things that you need to know to solve this program. So please, before seeing the answer and before going through my explanation, pause the video, go and do the exercise yourself and try to debug it, try to find the problem, where the problem is, and try to, practice it on your own first. And if you could do it, great, you learned everything. And if you couldn't do it, it's not a problem. There is always room for improvement. So you come here, you see the problem and how I'm solving it, and you can then navigate where your problem is exactly coming from. So if you have done practicing, now look at this, continue looking at this video, continue watching this video. So we need to declare two numbers. So I'm a user, so and machine needs to, we need to write a program that machine sends me two messages saying that, okay, tell me two numbers. And then I will tell the machine two numbers, whatever I want, and the machine needs to do the computation for me. And what would be the sum of these two numbers? In order to do that, we first declare two integer values or whatever, float, whatever your choice is. So we declare, now I'm declaring two integer variables that are called a and b. Then I show the message to the user saying that enter your first number. Then I'm storing the first number here. Then showing another message saying that enter your second number. Then I'm storing the second number. And then I declare a new data like c that is an integer, and it is assigned the sum of a and b. Then when I store the result in C, I show the C using cout function. So the procedure is always the same. We declare one data type, whatever we want, integer or like float, double, whatever. Then we show the message to the user enters the value. Then we store the value that is entered by the user, and then if there is some operations like mathematical operations that needs to be done, we do it, and then we cout everything. We show the message again to the user. So it's very straightforward. Let's compile. So now it's compiling. So type your first number, I would say 14. Type your second number, I would say 20. And voila, it says the sum of your two numbers is 34. So this is the first coding exercise. We're going to have more and more coding exercises, and it's important to focus and try to learn from your mistakes and first do the exercises on your own and then come back here to correct your errors or to validate your solution. Thank you for watching. Hey everyone, welcome back. So the second exercise. Write a C++ program that reads two float numbers from the user and store their sum and product in two other float numbers. Then show the original results along with the rounded up results of sum and product. So this program involves several steps. In order to make the program easy for you, for yourself in the beginning, you need to break it down into steps. So the first step, get two numbers from the user. Use for the user, get two float number. Yeah. So we break it down for ourselves to make it easier for us to understand it. So then store the float numbers. Then do mathematical operations on the stored numbers that are sum and product, and then show the original sum and product of two stored numbers, and finally show the rounded up sum and product of two stored numbers. So you see here, we had only a very short description of the program. However, now that we break it down into steps, it's easier to understand it. So every time you want to write a program, just don't start right away. First, start breaking down the steps to see what the question is asking you. What is it that it wants. So now we broke down the steps. So please pause this video and go and try and practice to see if you can solve this program yourself or not. If you have any problem, you can just come back to this video or write to me to ask any questions. I will be happy to help you. And then if you have some problems, you can come back here and see the video and see, and then compare it with your own code to see where the problem comes from. So the only way that you can learn how to do programming is to practice it. So please don't skip exercising by your own computer. So if you did think and you have some results, that is correct, great. If there are some bugs, it's okay, we go through it again. We go through them again here together so you can navigate your problem. So for the first one, get two float numbers from the user. Float A and float B needs to be declared. I declared them here. I show a message to the user saying that, okay, enter your first float. I store it using cin syntax. Then for the second float, I show the message and then I store. Then, so the first step is done. The second step is done. So do the mathematical operations. So in order to do some mathematical operations, we declare two other new floats. So here I name one of them sum, that is assigned to a plus b, and another one is product, that is assigned the value of a times b. So now we did the mathematical operations here literally. Then it tells me that we need to show the original sum and product of two stored values. So because the stored values are Float values, there are some decimal along with them, some decimal numbers associated to them. So showing their original means you touch nothing of the sum of the and product. You just show it right away in the terminal. So using this cout, I say the original sum is, and then I put the sum, and the original product is, and then I put the product. I put end L, so it goes to the next line. However, the last step is asking us to show the rounded up sum and the product. If you remember in the library function lesson, we learned how to do the round up. So we use cell function in order to round up our numbers. So here we do the same, cout, the rounded up sum is cell sum within bracket, and then the rounded up product is sale product, and then end L. So let's try this out together to see how it works. Okay, compiling, building, no errors. Great, so the first float would be like whatever, 5.14, and the second one I would say 8.63. 63, yeah, whatever you prefer. Voila. So it says that the original sum is 13.77 and the original product is 44.3582. However, the rounded sum is 14, which is true because it is rounded up of 13 point something. And then the product rounded up is 45, which is true. It's like 44 something. It rounded up to 45. So great. We did the program and implemented it very well. Thank you for watching. Don't forget to practice this and then move to the next video. See you in the other one. Welcome back. So in this lesson, we're going to discuss about the third coding exercise. So the program is asking, write a program that asks the user to enter the radius of a circle, a floating point number, and then calculate and display the area of the circle. Sorry. So here, if we want to break down the program, we need to write it like so. First, to ask a number from the user, then to do the calculation of the area of the circle, and finally to display it. So I think it would be a good practice for you to start breaking down the program that you're asked to code. So it helps you in the beginning, especially it helps you to clearly navigate through the steps to reach the result you're looking for. So now please pause this video and think about this exercise and then come back to this video. Okay, so in order to ask a number from the user, we define a double, we call it radius. Then, as always, we go through the procedure that we have. So we show a message to the user saying that, okay, enter the radius of the cycle of the circle that you're looking for, and then we store it using cin syntax. And then we have the formulation here. So the formulation says that we initialized a double called area that is assigned the value of pi, which is 3.14. This is the formula for calculating the area of a circle. So 3.5 times the radius of the circle to the power of 2. So in order to have the radius of the circle to the power of 2, if you remember, we in the library function lecture, we had this whole library function that gives us that calculates automatically the value of the number that we are having here to the power that we want here. So we need to calculate radius to the power of 2. So we put the radius on the left and the power of 2 to the right. And finally, we see out the result. So the area of the circle is, and then we put the area, and we don't need to write the std because initially we included using namespace std in the beginning of our code. Let me show it again here. So because we have this one here using namespace std, we don't need to repeatedly use it in our program. So let's go down. Okay, here we are. So now let's just compile and see the result. So no error. It is asking enter the radius of the circle. So here I would put like 2.25, and it calculates the area of the circle that we are looking for, which is 15.8963. So this is the third exercise. In the next lecture, we are going to dive deeper into other practices. Stay tuned. Welcome back. Here we have the fourth coding exercise. So write a program that reads the radius and height of a cylinder from the user and calculate the volume. So let's break down. The first thing is to break down the program. So the first thing is that read the radius and height from the user. Secondly, calculate the volume of a cylinder. Third, show the result. So this is a good practice for you. And we know that from before, the formula to calculate the volume of a cylinder is pi, which is a fixed number, 3.14 approximately, radius to the power of 2 times height. So this is the formula. Please pause the video now and go and practice, and then continue watching this exercise being solved. Okay, so the first thing is that read the radius and height from the user. So here we are reading the radius and height from the user. We are showing a message saying that enter the radius of the cylinder, and then we store it using cin or scene, and we see out enter the height of the cylinder, and then using cin syntax we are storing the height. And then here we have the formula saying that we initialize a double called volume. The formula is pi number times radius to the power of 2 times height. And then in the last line, we use cout syntax to show the volume. So let's compile and see how it works. Okay, no error. So let's just think about the radius, like I would say 3.17, and the height would be 10. So it calculates here, it calculates the amount that a volume of a cylinder with a radius of 3.17 and the height of 10 for us, which is 315.535. So this is very good. The something that we need to make sure of is that in our program, so this program is very straightforward, but something to make sure of is we sometimes have a result and we need to validate the result that we have. So for example, it says that the cylinder is volume is around 315. So how to make sure that this result is okay or not? So as I said, this is very straightforward. So we know that it's true, but sometimes when the program is complex, we need to make sure. In order to make sure is that we print step by step of the result. For example, we would be able to here first we have a double called radius to power 2, which equals the power of 2 of the radius. So we store it here. So this is the first thing. And then we can see out the power of 2 is the power of 2 of radius is, then we print it, like we print this uh, this one here, and del. Also, we can print the value of like pi number times the radius to the power of 2. Here we have the, for example, let's initialize something here before doing that. Double AA, I would call it, which is 3.14 times the radius to the power of 2. So here I also print this one. And then we have like double, another double, saying that AA times height. See out the volume should be AAA, and then and L. So here what I am doing, oops, sorry about this. So we need to write it see out. So initially I straightforwardly stored everything, did the calculation here, and then I printed everything. So sometimes, as I said, it's very straightforward, but sometimes we make mistakes. We don't know that we are making mistakes, and we don't know the result that is obtained is the correct result or not. So sometimes it would be nice to validate the results. In order to validate the result, we broke down this formula calculation. So initially we calculated the power of 2 of the radius, then we have its product with the pi number, and then the result is here written in a new double AAA, triple A, which is the double A times height. So let's compile and see how the result would be. Is it okay? Everything is fine or not? So the radius of the cylinder is 2.14, and I would say the height is 10. Here, let me minimize this one so we can compare. Okay, so here we see that the calculated volume of a cylinder is around 143. Okay, it's okay. So it's the final result. But we progressively obtain the result as of here. So as of here, we calculated the power of 2 of the radius, then the power of 2 of the radius times the pi number, which is this number, 14, around 14, and then this number times to the volume, to the height of the volume, to the height of the cylinder, which gives us the volume of the cylinder, which is exactly the same number that we obtained in this formula. So sometimes it would be nice to validate the results. Thank you for watching. Stay tuned for the next exercise. Hi guys. So in this exercise, exercise number 5, we are asked to write a program that reads the principal amount, rate of interest, and the time in years from the user and calculate the simple interest using the formula in the below. So the formula is, we have it like interest equals principal times rate times time. All of them are divided by 100. So please pause this video and go and think about this and how to write this program. It is very easy, so you need to practice yourself. If you have already done the practice, okay, let's dive in. So the first thing is that we need to break down the program. The first one is that read the data from the user, do the calculation, then show the result. So these are the three steps that we are going to take. So firstly, in order to read the data from the user, we need to declare three doubles here: principal, rate, and time. We show a message one by one to the user. We store using cin syntax. Again, we show the message, we store the rate, show the message, and store the time. And then here we have the formula, which is the double interest equals exactly like the same formula as it is given. So principal times rate times time, all of them divided by 100. And finally, we show the result. So let's just compile the code and see how it goes. So I would say the principal is 200,000. The interest rate is like 4.15, and years, I would say 30. So the simple rate is around 249,000. So this is the result. So let's check everything that we did together again. So we read the data, we first declare the double, we read the data, we store the data, we write the formulation, and then we show the results. Thank you for watching. Hi again. Congratulations on your perseverance and continuing to do the exercises. They are indeed very important. They may look very easy practices here, but it is essential to start coding yourself, to get used to the coding and follow the logic of the coding. So, coding exercise number 6. So write a program that reads a temperature in Celsius from the user and converts it to Fahrenheit. And we know from before that even if we don't know, we can just search Google and find this formula. So Fahrenheit, a degree in Fahrenheit equals a degree in Celsius times 9 on 5 plus 32. So this is the already known formula, and we accept it as it is. So we break the program. So we need to read the data from the user, do the calculation, and show the result. So it's very straightforward. So we initialize a double called Celsius, and we show a message to the user saying that enter the temperature you have in mind in Celsius. So and then we store it using cin syntax. Then we do the Fahrenheit double here equals Celsius, exactly like the formula. Celsius times 9 on 5 plus 32. And then we show the result as Fahrenheit. So let's try this. So I would say, let's say 25. So 25 degree in Celsius would be 77 in Fahrenheit. So let's try it again. So here we have like 12.5. So the degree in Fahrenheit would be 54.5. Thanks for watching. In the next video, we will have more exercising. Welcome back to another coding exercise. Coding exercise 7. Write a program that asks the user for a floating point number and rounds it up and down. Previously, if you remember, we had two library functions that could do this for us. So one of them was ceil and the other one was floor. Ceil would have rounded up a number to a nearest integer, and then floor was rounding down the number to the nearest integer. So we break down the program. So we read the data from the user. What's the floating point number that you want to enter? Then we do the calculation using these two library functions. And then we show the results. So here we initialize a double called number. We show the message to the user saying that, okay, enter a floating point number. Then we store this number using cin syntax. After that, we show the result using cout. Here, showing the result and the calculation are both in the same step. So here we can easily say that cout rounded up is sealed number within the bracket, and then rounded down is floor, the number within the bracket. So this number is exactly that number we initialize here, and we store the entered number in this number. So it could be like whatever, my value, for example. Okay, so don't get confused with the name. So it could be my value, whatever. So let's try this one. So I would say 12.15, sorry, 12.15. So the rounded up is 13, the rounded down is 12. So here I show the result using with the calculation all at the same time. You could also, one practice for you could be you initialize another double, like for example, you could do something like this, double my value rounded up, and then this is equal seal my value. Okay, so oops, I had a typo there. So here is seal. Okay, so then you could do the same for the floor, and then instead of doing the calculation directly here, you could easily just print this my value rounded up and my value rounded down. This would be a good practice for you. So like double my value rounded down equals floor my value. So I would write up until here. I will leave the practice to you. So print these two values instead of these two formula here, like the seal and the flow. Thanks for watching. In the next video, we will dive into more exercises. Hi again. Welcome back to the coding exercise number 8. Here, we want to write a program that takes two integers from the user and performs three operations, including addition, subtraction, and multiplication. Here, we first need to read the data from the user. As always, we do the calculation, and finally, we show the result. So please pause the video here and go and practice yourself. If you have already practiced this, okay, let's carry on and dive into it. In order to do that, we need to first initialize two integers like int num1 and num2. The names are not important, as you know. Whatever you want, you can put it there. Then we cout enter the first integer, and then we use the cin syntax to store the num1. Then we have the cout enter the second integer, and then we store it using cin syntax in num2. In order to do the calculation, we can do the calculation separately and then show the results. But here since the calculation is not so complex, I am showing the result as I'm doing the calculation simultaneously. So what I mean is that I cout, I would say addition, then num1 plus num2. So the result of num1 plus num2 would be printed here. And then for the subtraction, I num1 minus num2. And then for the multiplication, we have the num1 and num2. So let's try and practice this to see. Let's compile and see how it works. So I would say the first number is, for example, 5, and the second number is 2. So the first number and the second number's addition are 7, is 7. The subtraction is 3, and the multiplication is 10. So it's very easy. We can do the math ourselves to validate the result. So this is one way to show the results. Another way to show the result would be like we initialize 3 other values like a, int b, and int c. So this is how we used to initialize our integers. Something to mention here is that we can do something like this. Instead of one by one initializing them, we could simply say int b, int c, and that's it. So we initialize 3 integers in one line, and we have the warning because we have not yet used them. It's not a problem with the declaration. So then we would say a equals num1 plus num2. Then we do the calculation for the num1 minus num2, and we assign it to b. And then for the c, we have the num1 times num2. So the second way of showing the result would be like this. So instead of doing the calculation here, we can just print a here, we can print b here, and we can print c here. So let's try again. So I would say again 5 and 3. So the result, the addition is 8, which is correct. Subtraction is 2, which is correct. Multiplication is 15, which is also correct. So there are 2 ways. It depends which way is easier for you to do. How it really depends on how you approach the problem and how it is convenient for you to do the coding. The steps could be different, but the result is important. As long as we are writing everything in a clean way. And one reminder that I would like to mention is that here when we used to say slash slash, we could add comments that had no impact on the program that is being executed. So here I could say I am declaring 3 integers in one line. Here I am calculating the addition. So usually programmers, they add comments like this in their program because now the code is simple. But when you're becoming an advanced user of C++ or whatever the programming language that you want to program with in the future, there are syntaxes that are very advanced and there are computations that are very complex. So, and usually when you are in a team of developers, you share your codes with each other. So in order to save time for your colleague, it would be nice to leave some comments like this here so your colleague don't have to, go through the details of your code to, to understand what you did easily. He or she can read the comments and understand what you wanted to mention and what you were trying to do in your coding. Thanks for watching. Don't forget to practice. Hi again, welcome back. Today we're going to discuss if conditions. In the if conditions, there are certain things that we need to learn. But before that, let's review what we have learned so far. So we learned how to declare an integer number. Here we're declaring an integer called number. And then we print a cout syntax saying that we use cout syntax to print enter an integer. Then we learned how to store this entered integer by the user using cin syntax or cin function. So far, we learned how to do this. But now we're going to discuss the if conditions. So if conditions are like this. So imagine the user enters one number. And here we are saying that if the number is greater than 0, then print the number is positive. Else if, where we are having another condition. Else if, when we add another condition, we use else if. So else if in the bracket, number is lower than 0, so smaller than 0 in parentheses, cout the number is negative. And another else that we have is that if the number is neither than but greater than 0 nor smaller than 0, we have the else, the final else that says that, okay, the number is 0. So generally it's like if the number is greater than 0, it prints it's positive. If the number is lower than 0, it prints negative. And if neither of the conditions are met, it prints whatever that we want. We can say the number is 0, or we can say neither of the conditions met. So whatever. Else, it says that the above mentioned condition did not meet. So this is the else if. So let's run and try with a few more examples to see what happens. So no error, it's compiling now. Okay, enter an integer. I would say 10. So it prints the number is positive because 10 is greater than 0. Let's try it once more. So I would say minus 12. So the number is negative, so it works correctly. So if I mention something like 0, like here, it says neither of the conditions are met. So here the simple version of the if conditions. What we need to be careful about is how these if. So what is important is to know how these if conditions are written. So how basically they are written is that we have the if, then parentheses within which we write the condition. Like here I say that if the number is greater or equal 90, then I put the brackets to have the conditions. One bracket is here and another one is here. If I am going to check another if condition, this time we say else if. Then within the parentheses, we mention number is lower than 90, for example. And then we have the brackets. And then we cout the result. So in this situation, it is not efficient to have else. Why? The reason is that then a number is either greater or equal to 90 or lower than 90. So there is nothing that these two void conditions cannot meet. So this is why the else condition is not considered in this example. So if we want to run this code, it would be something like this. So we get the input from the user and we compile. Okay. Now that it is compiling, okay, it asks to enter one integer. I would say 94. So the result is your score is A. Let's run again. If I run again, this time I would type 75 and it says your score is not A. So if we test this code multiple times, either of these two statements will be printed. Like if I say 115, your score is A. So there is no condition that checks if the number is at the same time larger and smaller than certain value, so it pushes the number within a range. And also because, as I mentioned earlier, these two conditions are vastly considering everything that integer number can has there, so no else condition is required for this example. In other videos, in the continuing of this section, we are going to discuss some more coding exercises that help you to understand these concepts easily and grasp the meaning behind it. So you can you can put your hands on the keyboard and start coding to, little by little, by trial and error and following some instructions, you can get the meaning behind these if conditions. Stay tuned. Hello everyone, welcome back to another coding exercise session of this section. So in this coding exercise, we would like to write a program that shows if a number is odd or even. Before we start the coding, we need to think about the statement of the program itself first. So if we want to, so we can break it down. So if we want to see if a number is odd or even, so we need to declare firstly one integer or float. So preferably integer. Otherwise, if it's float, we need to first round up or round down the number to be an integer, then do the mathematical formulation on it, like the mathematical operations on it. So firstly, we declare it, we read it from the user, and then using cin function, we can store it in the declared integer. Then, so far, these are the things that we learned from the previous section. And then we need to start writing our if conditions statements that we learned in the current section. So let's dive in. Firstly, we declare an integer called number. We show the cout message to the user saying that enter an integer. Then we store the integer using cin function in the integer named number. So this is straightforward. This is the steps that we have been using. And as of here, we need to define the if condition. So the if condition, as you remember, it's if, and within parentheses, we write the condition, and then within brackets, we write the statement that what do you want to do with the program if the condition is true, if the condition is okay, and if we enter the condition. And then we have the else, that the else does not need to have parentheses. However, if it's else if, we need to have the parentheses as we define the condition for the else if. But for the else, no definition is needed, because we are saying if this case is true, do this, and otherwise, in any other case, whatever the case is, just print another message. So this is why else does not have the parentheses for any predefined condition. So here we say that, okay, we read a number from the user. If the number divided by 2 and its remainder equals 0. So in order to make sure that if it's equal 0, we need to use 2 equals sign. When we use a 1 equal sign, it returns error, saying that because we want in the C++ programming language, when we use 1 equal sign, it means that we want to assign a number to one variable, to one data type, for example. Previously, if you remember, we used to define int a equals 2. It means that at that time we were using only one equal sign. It means that the number 2 is assigned to integer a. However, here we are not saying that we want to assign 0 to something. We're just making sure if the number that we have here, that is divided by 2, and when we are using modula, it gives us the remainder of the division of number by 2. If this equals 0. So if it equals 0, we see the condition in the bracket. So in the bracket, we say that see out the number is even, because if a number is even, its remainder when it's divided by 2 must be 0. Otherwise, here we define else. Otherwise, the number is odd. So let's try it and see how it works. So I put a number like 20. It says the number is even because if 20 is divided by 2, its remainder equals 0. So this is why the number is even is printed. So if 20 is divided by 2, its remainder that we are looking for using modulo sign here equals 0. It enters this condition and prints the number is even. However, let's compile again. So what if I write 13? So the number is odd. So let's see how the program gets there. So we enter the number. It is stored in this data type called number. Then it goes for the first condition first. So it goes there. It says that, okay, number divided by 2, the remainder is what? Is it equal to 0? If it's equal to 0, it enters. However, in this case that we put a 13, 13 when it's divided by 2, its remainder is for sure not 0. So it does not enter this condition. And in escape, it escapes this condition and goes for the else, because we said if this condition does not pass, whatever the condition is, enter into the else function. There, it prints the number is odd. So let's try it once more. Like whatever the number is, like 101, the number is odd because again, it goes through the same procedure. Please make sure you practice these exercises before I start solving them. And also when you see this video, when you watch this video and you understand the procedure, go use your own machine, use your own laptop and try to implement this program several times. It helps you to get used to the syntaxes and how to write an if condition, for example. It looks easy and it is indeed easy, but after several times of trying, it becomes easy for you. Hi again, welcome back. So in this video, we're moving to the next coding exercise. It is asked that to write a program that reads two numbers from the user and we do a math operations. Like we also asks two numbers and also asks one math operations. Then perform the taken operations on the given numbers. So to do this, firstly, we know that we need to have at least two numbers to do the operations, and then one mathematical operations like we can consider addition, subtraction, multiplication, or division. Then, based on these information that the user is giving, it computes the result. So let's dive in. First of all, we define two numbers called num1 and num2 as double. And then in order to store the math operations, we need a character because it's like the signs are like this. So these signs are able to be stored in one character, not like in data types like integer or float or double. So firstly, we start by showing the information, reading the input and storing it in the first number in num1 using scene function. Then we ask the user to enter one operator like plus, minus, times, division, and we store the operator in the OP that is initialized as a char. And then we ask the user to give us the second number. When the user says the second number, it is stored in num2 using cin function. So these are the things that we learned from the previous section. So if conditions here. In order to see what operations the user, what operation the user is asking and is looking for, we need to have if conditions. So here, if you remember from before, we have the if condition, and within the parentheses, we put the condition. We say that if OP, which was the math operator that the user gave us, equals, using two equal sign, equals plus, and this is plus is within two commas, let's say, because it's important to have it, because it is a character. So then if this condition is true, it enters this bracket, and in this bracket we mentioned that the result is num1 plus num2, and we print the result for the user. However, if this condition is not true, the else if condition here is used. We mentioned that if OP equals subtraction, like in quotation mark or in quotation signs, if this condition is true, then enters the bracket. So when it enters the bracket using cout function, here, it prints the result saying that the result column, then we say num1 minus num2 and endl in the end. The same thing goes for the multiplication. We check else if the OP equals the star sign, and then if it's true, it enters here and do the mathematical formulation and write down the result to the output. And another thing that is here, the last but not the least, is the else if OP equals the division sign. But there is something that we need to make sure in the division sign. What is that? So if this condition is passed, it enters the statement part of this else if condition. So this part is all for this last else if. So here within this else if, we have another if. So it is nested if, let's say. So we check if num2 does not equal 0. If we want to check something that equals something, we use two equal sign, and if we want to make sure that it is not equal something, we have this exclamation mark and equal sign. So we make sure number 2 that the user gave us does not equal 0, because it's a problem. If we are going to divide a number by 0, it should returns an error. So here it says make sure this condition passes and number 2 does not equal 0, then enter this condition. Here, when that condition passed, we print the num1 divided by num2, and else, so else, what would be the condition for else? Whatever but not this condition, whatever but not this condition in this if statement. So in the if statement, we were saying num2 does not equal 0. So else would be whatever but not this, saying that, okay, if num2 equals 0, it is saying something like this, but it is like behind the scene. We need to understand it when we read the code. So it says if it equals 0, we return an error saying that division by 0. So the user knows that they made a mistake in the input file. And that's it. This is the end of this if and else nested conditions. And the last one that we saw here for the else if was here, and else, that this else come back to this level. You see, to this level, and like discussing these things, and this else is for this level. So it is, as you see, it starts a bit later in the line, so it's a nested if. So else, so if the user does not mention addition, subtraction, multiplication, or division, else we need to say invalid operator. So they made a mistake when they were entering the data. So let's try and see how it works. It would be easier to understand it after that. So enter the first number. I would say 20. Then it says enter one operator. I would say addition, and enter the second number. I would say 12. So it says the result is 32. So let's see the code and understand how it started doing it. So here, as you see, we had the first message, first number stored, the operator message, the operator stored in a character, and the third message, the second number stored in num2. Then it starts with the first if. It says op equals addition. So is it true? Yes, this is what I mentioned there. So it goes to this statement and says that the result, and then do the math part here. So let's do it again with other parts, like if I say this time 12 and we use the multiplication, and then I would say 2, it gives us the result 24. Let's see it from the code here. So it starts with this if condition. Does OP equals addition? No. Then it escapes simply. Else if. Does OP equals minus or subtraction? No. It then escapes again. It does not enter the statement. So here, does OP equals star sign? Yes. Then when it's true, it enters here and it does the calculation for us. So, and finally, let's do something with the division. So if I say the first number is 10, and we want to divide it by 2, for example, it gives us the result 5 as like the others. So let's see. So it starts from the here again. Does it equal addition? No. Does it equal subtraction? No. Does it equal the OP? Does it equal multiplication? No. Does it equal division? Yes. It enters then the condition. Okay, when it enters this condition, the following if condition must be met also. So here it checks again. If number 2, it says that the second number that we had here, like 2, does it equal 0 or not? If it does not equal 0, then enter here. So it doesn't. So number 2 was the number that I chose for this. So it says, okay, it does not equal to, then okay, it does the math formulation for us. But if, let me choose the second number to be 0, like I would say 10 division and then 0. What? Okay, you see what the error is. So here it checks here, does OP equal division? Yes, it enters. It says, does num2, the second number, equals 0 or not? It says, does it equal 0 or not? So if it does not equal 0, it enters here. But since it is equal 0, it escapes this condition and goes exactly to this else part. It says that error, division by 0. So we need to make sure that we are not making error in the input file so it can compute something for us also. And let's try once more for the last time. I would say the first number is 10. Like, what is the operator that I would like to do? I would just write something like this. So for example, I made a typo or something, and the second number is 20. So here it says that invalid operator. So let's check. Here in this part, it checks, does it equal addition? subtraction, multiplication, division, no. Then it escapes all of these, and then it gets to this else part, saying that invalid operators, because it does not equal to neither of the above mentioned conditions. So this is how, in fact, this was a very good example of how if conditions work. I would suggest practicing these coding exercise many times so you can understand the logic behind it and also logic in the nested if conditions. Thanks for watching. Hello and welcome back. Today we are going through another coding exercise that we can practice a little bit more the if conditions. So we need to write a program that reads a number from the user, preferably a non-negative number, and calculate its square root. In order to break down this program is that firstly we need to read one number, then we store the number, and then we check if this number is a non-negative number, and if it's not a non-negative number, we calculate its square root. And if you remember from previous section, we had the square root library function in C++. So we can easily let C++ to do that part. We just need to call it. So let's dive in. Here we initialize a double called number. We show a message to the user saying that enter a non-negative number, and then we store it using cin function. Then we go through the if condition. So if number is smaller than 0, we need to return an error to the user saying that, okay, you're using one invalid input. So please not do that. So here it goes to this statement and says that invalid input. Else means that any number above 0. Which is the case, which is what we are looking for. Else, then here we compute the square root of the number and we assign it to a new double initialized here that is named result. Then in the next line, we print out the result. So let's try and compile and see how it works. So enter a non-negative number, I would say like 16. The square root is 4. So let's go through the procedure through the code. Show a message. We enter a number. It is stored using cin function. Then it goes to the first if condition, like if number smaller than 0. Does this pass? No, because it's not the case. So it escapes this part and goes for the else. Then in the else part, because it makes sense, it goes through the condition and calculate the square root, assign it to result, and then show the result here to us. So let's try it another time. Enter a non-negative number, I would say 25. So this time gives us 5. In order to check the other if condition, like what if we choose an invalid input, I would say like -5. Okay, it says invalid input. So that if condition is working correctly. One important thing to note is that when we are considering if conditions, it's nice when we want to test the efficiency, and when we want to test the efficiency of the code or verification of the code, it would be nice to test it with different input values and make sure all the if conditions are working greatly and working correctly. This is very important thing, because later when we have like a lot of lines of code, if something goes wrong, it's very hard to find it. We need to go through the debugging steps that we learn in another probably topic, like for the intermediate or advanced level. But this is something to note, that now that we are learning from 0, it's important to know that we need to validate our code as we are proceeding through the coding. Welcome to another coding exercise session. Here we want to write a program that reads a number between 0 and 1 from the user and check if the number is equal or greater than 0.5. It rounds up the number to the nearest integer, and otherwise it rounds down the number. In order to do that, we first declare a double number. We ask the user to give us their input value, input number. We store it using cin function, and then we go through the if condition. So the condition here that we put, if the number that we read from the user, is greater or equal than 0.5. If this is true, round up the number using a ceil library function that we know from before. So we learned it in the previous section. If you don't remember it, it would be nice to review those lectures. Then using this ceil library function, we can easily round up the number. And else means that if it's lower than this 0.5, it will round down the number using the floor library function. So let's try and see. So the machine would ask us to enter a floating number. I would say like 0.8. It rounds up. It goes for the first condition. Let's verify it here. Yeah. So it goes to the first if condition. It sees that it's correct. It's true. It makes sense. Then it enters the if condition and do the statement that we have written here using ceil function. It rounds up the number. Let's try it once more. So if I say, for example, 0.5, it still rounds up to 1. Why? Because we say equal, greater equal than 0.5. If it was only greater than 0.5, it would have rounded down this number. But because it is greater equal, it rounds up the number. So let's try it once more with another, to go through the else condition. Let's put another number, for example, like this one. It rounded down the number. So it checks the if condition here, saying that, okay, it doesn't pass this condition, so it does not enter this statement. Then it escapes to the else, and else is here. So the floor, using the floor library function, we round down the number. But there is something here, so something that you can practice. This is the practice test for you. So here it says that we enter something between 0 and 1, but in this coded program, we don't check if the number that the user has entered is actually between 0 and 1. So it needs another if condition. So firstly, we read the number, we store it from the user, and then we first check to see if the number is between 0 and 1 or not. If this is not between 0 and 1, then we show a message to the user saying that, yeah, this is the invalid input, this is not valid, this is the number that you entered is not between 0 and 1. And then we go, if it passes through that condition saying that, okay, it is between 0 and 1, then it enters this if condition. It would be a nice practice for you to do that. Thanks for watching. Welcome back. Today we are going to discuss the assignment that I mentioned in previous video about coding exercise number 14. So here I mentioned we solved the problem like it was like if the number greater equal than 0.5, it rounds up the number, the output, and otherwise it rounds down the number to 0. However, we didn't check if the input number is actually between 0 and 1. In order to do that, we need to use nested if conditions. So here I added the code. So this part is like the previous video. It's like we just initialize the number, then we read the number from the user and store it using cin function. But before going through the round up and round down procedure, we first check if number is greater than 0. If this is true, enter this if condition. So, and then if number is lower than 1, then if this is true, then it enters this condition to round up or round down like before. However, the else condition here is that, okay, maybe the number is greater than 0, but it is not lower than 1. So then here it shows the message saying that invalid input. So this is the important thing that we need to consider. So let's try. So the program is working like before, like I would say 0.7, it rounds up. And if I say 0.2, it rounds down. So let's go through the procedure here once more. So it starts with this if condition. The number is greater than 0, yes, it enters. The number is lower than 1, yes, it enters. Then it says the number is greater or equal 0.5. It's not true. Then it escapes this part and then goes to this else section, which we round down the number. So let's see. We need to write something between 0 and 1, but we write something like 20. It says invalid input. But why? So it checks if the number is greater than 0. It's true, then it enters. Then it checks here if the number is lower than 1. It does not pass this condition. So it escapes everything that is in this if condition, like until here. You see the bracket closes here. Then goes to the else condition saying that, okay, let's just print out the invalid input so the user would understand that they made a mistake. Welcome back. Here we are discussing another coding exercise. So it asks us to write a program that takes the amount of the purchase. Like imagine you're working in a mall that you want to sell your product, and as a salesperson you want to sell the product, or you're coding the sale system. So when you're coding the sales system, you need to keep this in mind. This is the new rule that the manager mentioned. For example, anyone that goes beyond $500 when they're purchasing our products like t-shirts, we can give them 20% of discount. However, if the amount of the purchase of our customer is lower than $500, no discount is available. So now we want to design a program that computes this amount of discount. I mean, they consider this amount of discount and give us the final price that we need to ask the customer to pay. So here we firstly initialize a double called amount. We ask the user to enter the amount that they want to purchase, for example, and we store it using cin function. Then we enter the if condition saying that if that amount is higher than 500, which is our case, enter this condition. So then we initialize a new double called discount. The discount is calculated as amount times 20% of it. And when we calculate the discount, here we are again assigning a new number to the amount that we initially got from the customer. This is the important part. So we calculate this discount number using this formula. So the 20% of amount, okay? So far we calculated the discount, and here the amount is the value that we read from the user, and here we stored it. So we are saying that the amount that from now we are assigning a new value to the amount. We are saying that amount equals the previous amount that was read from the user minus the discount we calculated here. So we are reassigning the value of the amount after the discount. Then saying that 20% discount applied, final amount, and then we print it. And else means that if the purchase was lower than $500, for example, we print no discount applied and we show the final amount. So the final amount would be this amount. The difference is that when we go through this if condition, we reassign the value of amount. But if we don't go through this if condition, the amount stays the same amount that the customer entered initially. Let's compile the program, we will understand it better. So enter the amount. I would say 290. It says no discount applied. Final amount 290. So it first starts with this if condition. Does it pass? No, because 290 is lower than 500. Then it skips this part and goes for the else. And for the else, it says no discount applied. Final amount is amount. So it prints us the amount, which is 290. However, if we have like a number larger than 500, let's say 700, it says that 20% discount applied and the final amount is 560. Let's go through the steps. It goes to this party if condition pass. When it enters here, it starts calculating the amount of discount. So the amount of discount is based on 20% of the total amount. So the total amount here was 700. 700 times 20%. So it calculates the amount of discount, and we assign it to we assign this formula to the discount. So now we know what the discount number is. And we know the amount that the customer entered initially, which is 700. So 700 minus the discount will be the new value for the amount. So the new value, or let's say the final amount that they need to pay. So we are reassigning again in this if condition the value of amount. Then we simply just print the amount to the terminal for the customer. This is a very straightforward way of calculating discount. It has a wide range of application. As you know, in many malls or shopping centers, when there is a sale season, they just apply simply this coding to their system. So it computes the amount of discount automatically. Welcome back. In this video, we are going through another coding exercises regarding the if conditions. So here we would like to write a program that takes an integer from the user and checks if it's within the range of 10 to 50. So if the number is less than 10, it prints too low. And if the number is more than 50, it prints too high. And if it is within the range of 10 and 50, it prints in range. To do that, we initialize a number. We mention to the user saying that enter a number, and we store the number, and then we go through the if conditions. So firstly, we need to check if the number is greater equal than 10 or not. So if this condition is true, it enters this part. So between these two brackets. Else, so if the number is lower than 10, it goes to this else directly and says too low. So the too low part, it's very straightforward. So if the number is greater or equal 10, it enters this statement of the if condition. Otherwise, this else will be activated and it says too low. So what if the number is greater or equal than 10? Then we need to check it again. So we check again saying that, okay, now the number is greater or equal than 10. However, we need to check to see if the number is also smaller or equal than 50. So if this condition passes, it says in range, and else it says too high. So let's imagine I enter one number called, like, say 2. So it starts here. If the number is greater or equal than 10, so no, because my number is 2, it escapes everything that is here and go to this, else part and print too low. If my number is 20, it goes for the first if condition saying that, okay, 20 is greater than 10, then it enters. Then it enters here. Then it checks again. So my number was 20. It says the number is lower equal 50. Is it true? Yes. If it's true, it prints the in range and that's it. However, if my number, for example, was 100, although it passes the first condition, which is greater or equal than 10, it does not pass the second condition that must be lower than equal to 50. So if it does not pass through this condition, it goes to this else part saying that it's too high. Let's try. So we mentioned here, like if the number is 2, it says too low, which is true. And then if the number is like 110, it says it's too high. Let's say why. So it's too high, and the reason is it says, okay, the number is greater or equal than 10, it enters, then it checks to see whether the number is lower or equal 50 or not. It's not. Then it goes for this else condition, which is too high. And if I choose a number within the range of 10 and 50, like say 25, it says it is in range. So here it checks, okay, it's greater than 10, it's lower than 50, then so it prints us the in range message in the terminal. Try to practice this exercise on your own and try to do it several times so you get convenient with the syntaxes of if condition. Thanks for watching. Welcome back. Today we want to write a program that asks a user for a test score, something between 0 and 100, and then classify it as failing if the score is lower than 50, passing if the score is between 50 and 69, and good if the score is between 70 and 84, and excellent if the score is 85 or above. To do that, we need to use several if conditions. So please pause the video and think about it. Try to see how you can solve it and how many if conditions are necessary to write such a program. If you have already thought about this and tried to see if you can code it or not, now you may continue. So here we initialize a score, an integer called score, and we mentioned to the user saying that enter your test score, something between 0 and 100, and then store the input of the user. Then we start with an if condition saying that if the score is below 50, as it was suggesting here, so if the score is below 50, sorry, here, yeah, just print out failing, and that's it. This part is very straightforward. And then we write down else if. So else if would be the score is greater equal 50. And in this situation, when the score is greater equal 50, there are several conditions to check because we are having different grading system here. Like we want to show the message saying passing or good or excellent. So we need to distinguish. Being above 50 is not enough. So being in a range is enough to know which score lies in which category. For example, between 50 and 69, we need to say passing. However, between 70 and 84, we need to print good. To do that, we check, okay, else if the score is above 50. Then it's a nested if inside the else if that is here. So with the first one we start. So if the score is greater equal than 50 and if the score at the same time is lower equal 69, let's say passing. This is exactly the condition that we had here for the passing. And If this is not the case, so if the score is still greater equal 50, but it is not lower than 69, what do we do here is we check another situation, that is this part. So we escape this part if it's not below 69. We check this part saying that, okay, if the score is above 50 and above 70, this is the else if function that we check. Then it passes through these two conditions to check. So the first one is lower than 84, good, and else, if it's not lower than 84, it means that it is above 84, which is the 85 and above. So it's excellent. Let me run the program and try different numbers and start analyzing the code. I think it would be easier for you to grasp the idea behind it. So if the score is like 40, it says failing. It's very straightforward. So if the score is below 50, it simply prints the failing message. So let's go for the next category. For example, I would say if the score is 65, it would say passing. So let's analyze the code. Analyzing the code is very important. For you also, when you are trying to understand if your program is not working correctly, it would be nice to start analyzing the code and see what the problem is and where the problem is, in fact. So here it starts from this if condition. It says that, is it below 50? No. Then it escapes this part and directly goes to this else if condition here. It says, okay, is it above 50? Yes. And it enters this condition, this part now. You see the bracket, these two red brackets. So if it's above 50, our number was 65. It starts checking again. So here it checks, okay, now the number is above 50, but is it at the same time lower than 69? Yes. So it enters and prints us this passing condition here. So let's try another number, like 75 instead of that. So it says good. How come? Let's analyze it. Here it starts from here. It says that is it below 50? No. So it escapes. It goes to this else if condition. And when it goes to this else if condition, it says, is it above 50? Yes. Is it lower than 69? No. Then it escapes this part. Is it above 70? Yes. So it enters this condition between these two brackets. At the same time that it is above 70. Is it lower than 84? Yes. If it's true, then it prints the good printout. And if the number is not passing this condition that says that it is below 84, it prints the else part here. Excellent. Let's write another number here. Like my number is 95. It prints excellent. So here starts the condition. Is it below 50? No, it escapes and goes to this part. Is it above 50? Yes, it enters. Is it below 69? No. And then, is it above 70? Yes, it enters these between these two. It enters this statement and we need to choose between these two. The machine needs to choose between these two. Okay, is it above 70? Yes. Is it below 84? No. Then it's above 85 because it says lower equal to 84. Then when it's not passing this condition, it's above 85 equal large. Welcome back to another lesson. In today's lesson, we're going to talk about ternary operator. The ternary operator is a shortened way to write an if-else statement in a single line. So it's a compact and efficient way to make simple decisions in code. The ternary operator is often used to simplify and shorten the conditional expressions. For example, here we see the condition we want to check. So we put it like here. The syntax looks something like this. So the condition that we want to check is this place. And then if this condition is true, the expression returns value if true. And otherwise, it returns value if false. And the question mark there separates the condition from the possible outcomes. So this is the condition. We separate it from the possible outcomes, and then we have the value if true and value if false. And colon here separates the value if true and the value if false. But how it works, we will see in a few seconds. Here, let's uncomment some code that we have. So, for example, previously we learned that if we want to understand if a number is even or odd, we need to write an if condition. Here I am initializing one integer value named number with number 5, and we are initializing one string named result. So we say that if the number is divided by 2 and its remainder equals to 0, so using the modulo sign we can find the remainder, and the remainder is 0, the result will return the even. However, if this condition is not correct, then the result it is assigned with the odd. So let's try and check it out. Compiling here, no error. Yes, so we have nothing in the output because we forgot to see out. Here is the output, and then we write result. So this is important to show the output result also. Okay, let's run again. So here is the output odd. So this is odd. Why? Because the number 5, when it is divided to 2, the remainder does not equal 0. So this is how we used to do it while we were writing the if conditions. However, if we are going to use ternary operators to write the same code, it will look something like this. So we ask the user to, for example, give us one number, and we store the result. Then here, instead of these lines about the if and else conditions checking, we simply write down the result equals, so we initialize the result as a string here directly. The result equals number, and here we write down the conditions. If you remember, I mentioned this conditions, question mark, and two possibilities separated by a colon here. So number, if it's divided by 2, its remainder equals to 0. So it is now separated with a question mark with the possible outcomes that are even and odd. So if this condition is true, it's going to print the first true value here. If this is not true, it will print us the odd value. So the odd value will be assigned to result if this condition is not correct. And if this condition is correct, even is going to be assigned to the result. So let's run the code and see. So if I say 10, it returns the value is even, the number is even. So let's go through the analyzing the code once more. So here the number is stored. We initialize a string called result, and its value equals to the condition of if the number, if this number is divided by 2, its remainder equals 0. If this is correct, the first condition is even, so even will be assigned to result. And if this condition is not correct, then this value, this result will be assigned to this result. Okay, so and they are separated by semicolon. And if you see, we simply could check the condition in one line here. However, we used to check it in like a few lines here, like 4 or 5 lines. So when we have a straightforward checking condition, it would be more efficient to use ternary operators. In the next lectures, we are going to practice some examples and coding exercises, so it will be more clear for you how it works. Hi, welcome back to another coding exercise. In the previous lesson, we discussed how we differentiate ternary operator with normal if-else condition statements. In this lesson, we are giving you another example. So here, the program, we want to write a program that says to check if a score is taken from the user and the number is something between 0 and 100. So if the number is larger, equal 50, return the pass. And if the number is not larger, equal 50, return fail. So previously, when we wanted to do that, we had to write if statement condition saying that if the score is larger, equal 50, go through the cout function and print pass, and else print fail. However, so it would take like 2-3 lines at least. So here we can write it down in one line. We initialize one integer. We show this to the user, and they enter their score, and we store their score. And we initialize this one string that is called result, and in the parentheses we mention the condition that we want to check, and this condition is separated from the possible outcomes using one question mark. So we write down the condition we want to check. If the score greater equal 50, then one option is pass, one option is fail. So these two possible outcomes are also separated with a colon. So if this condition is true, the first option will be assigned to result. And if this function, if this statement is false, then the fail is going to be assigned to result. And finally, we print the result here like this. So we will print like cout u, and then the score, and then the exam. So we would say you pass the exam or you fail the exam. So let's try this one to see how it works. So it says that enter one number. I would say 88. You pass the exam because 88 is greater than 50, and it returns, because this condition is true, it returns the first possible outcome. And if we try it more with another example, it will be like 30, and you failed the exam. Why? Because the first condition, the condition is not true. It's going to skip the first option and return the second option, and the second option is going to be assigned to result. Welcome back. In this lesson, we are going to have another coding exercise for a ternary operator. So the question is asking us that to write a program that checks if someone is eligible to vote or not. If the person is 18 years old or above, the person can vote and the person is eligible for voting. Otherwise, the person is not eligible to vote. So we want to do this with ternary operator. So previously, when we wanted to do this with if else statement, we could define one if condition. So, and we would say if age is greater or equal to 18, we print eligible to vote. Otherwise, we print not eligible to vote. However, here in only one line, we can use ternary operator to do that. So the first we initialize an integer called age, then we ask the user, we store the input, and then we initialize one string called result here. We put the condition within the parentheses saying that if we don't write if, but the statement says that age equal greater 18. So if this condition is correct, the first output will be assigned to the result. And if this condition is not correct, the second output is going to be assigned to the result. And please note that the condition is separated from the potential outcome using a question mark. And also the potential outcomes are separated from each other using a colon here. And then we are going to print the result. So let's try and see how it works. Let's try. So now it's compiling and I would say 20. It says you're eligible to vote. Why? The reason is that the condition is true, so the first outcome is assigned to result. Let's try it once more. So when we try it again, we put for example, the number 15, and it says that you're not eligible to vote. Sorry. So this is how easy this ternary operator is. Keep practicing it, and where possible, you just use this condition instead of using if-else condition. Welcome back. So let's try another coding exercise using ternary operator. So here we would like to check if a number that is read from the user is positive, negative, or zero. To do that, we initialize it, we read the data from the user, we store it, and then we initialize a string named result. So the condition here that we want to check is that to see if the number is greater than zero. So if this condition is true, it's going to give us the output of positive. So the positive is going to be assigned to result, and then the result is going to be printed in the terminal. So the condition is separated from the potential outcome with a question mark. And if this condition is not correct, the second outcome should be checked. But the second outcome here is another condition. So if a number is positive, so positive is assigned to result. However, if the number is not positive, the machine will go and check the second condition. And the second condition here is that if the number is lower than zero, so, and it is separated with a question mark from the possible outcome. So if this condition is true, negative is going to be assigned to result. And if this condition is not true, then 0 is going to be assigned to result. And finally, the result is going to be shown here. Let's try and see how it works. So now I'm compiling. So enter an integer, I would say 12. So it says the number is positive. So when it says the number is positive, what I see here is that, so it checks the first condition. Is the number greater than 0? Yes. Then the positive is going to be assigned to the result, and then the result is going to be printed in the output. Let's try another number to see how it works. With other numbers, like I would say minus 15. It says that the number is negative, but how it gets there? So it checks the first condition. The number, is it greater than 0? No. So this option is not going to be assigned to result. So positive is not going to be assigned. Then it goes for the second option, but the second option itself is another condition. So then it checks the condition here. Is it is the number below 0? Yes, in our case, yes. So the negative is going to be assigned to the result, and the result is going to be shown in the terminal. Let's try with another number. So this time I'm going to set 0, and it says the number is 0. So let's analyze the code. So the first condition is not passed, so the positive is not assigned to result. And when the condition is not true, it's going to the second part. So the second part is another condition. It checks whether the number is lower than 0 or not. Is it true? No. Then, because it's not true, then negative is not going to be assigned to the result. But the second option, which is 0, is going to be assigned to the result. And then result is shown using this code in the terminal. Hello again. In today's lesson, we are going to discuss logical operators. So logical operators are used to combine or modify conditions in if and else if and other decision-making structure. So there are two main logical operators. There are other logical operators, but there are two main logical operators that we are going to discuss in today's lesson. So for the first one is the AND condition, and the second one is the OR condition. So the AND condition is when we want to modify two things. If you remember in previous exercises, when we were having else conditions and when we wanted if and else if conditions, when we wanted to check, for example, to see if a number is within a range, for example, to see if a number is between 10 and 20, we had to define one if condition saying that if the number is larger than 10, and in the statement of this if condition, as a nested if, we were adding another if, saying that okay, the first if is passed, the second if is to see if the number is smaller than 20. So something like this. Let me write it down. Something like this. We were like int a equals 22, for example. And we were checking to see if a is greater than 10. Then we were checking again if a is lower than 20, and then we were saying correct number in the output, something like this. You see, so there is one if condition here and another if condition here. However, using the AND condition, we can write these examples easier. So let's dive in. Let's see how it works. So for example, here, I would uncomment these lines to see how it works. So basically, we ask the user to enter their age, and if their age is above 18, and then we enter these conditions of the if, and the statement consists of if and else itself, saying that okay, now it's above 18, but if it's below 65, you are eligible to work. But if it's above 18 and it's not below 65, it's probably something like 66 and above, it says you're not in the working age range. And if this age is not above 18 initially, it says that you're not in the working age range. So let's compile this and see how it works. So this is if statement that we learned already. So I would say like 50, 60, sorry, and it says you're eligible to work. However, there are some ways to write this code in an easier way using logical operators. So it makes it more efficient and concise. So as you see, everything is about efficiency in the code to help having a better code. So here we are reading the age from the user and storing it. Instead of having two conditions, like one if here and another nested if here, we are only having one if here, saying that if age equals greater 18 and at the same time it is lower equal 65, then you write in the output that you're eligible to work. And the second logical operator is this. So we say else if, then we say if age is below 18 or using these signs, age is above 65, you're not eligible to work. So what are the differences between and or? So this is and this is or. So and if we are writing a condition statement using and, it must meet the condition before and the condition after and at the same time. So if both of these two conditions are passed, then we print these to the terminal. However, regarding the or condition here, or logical operator, if either of the conditions are met, we print this one. So this is the difference. Both conditions should be met here in the AND operator, but here either of these should be met. Let's try this program and see how it works. So, okay, let's say 18. It says you're not in the working range because so it checks here 80 is not in this range, and then it checks here, okay, 80 is passing one of the conditions, then directly goes to this place. So let's try another one. So I would say like 10, it says you're not in the working range again, because when it sees that the 10 is lower than 18, it directly prints that you're not in the working condition. So using logical operator will help us to have a more efficient and concise and shorter lines of code. It's nice to think of how you can make your code more efficient and not just to write a code that works, but an efficient code that works perfectly in a shorter amount of time, in a lower number of lines to write the code and implement it. In the next lectures, we are going to practice some logical operators. Welcome back. Let's try some more coding exercises for logical operator. So we would like to write one program that checks to see if the number that is read from the user is divisible by both 3 and 5. So here we read the number from the user, we store it. Using logical operator, we check to see the number if it is divided by 3, and using modulo sign we can see its remainder. So the remainder of the number divided by 3, is it equal to 0 or not? So if it equals 0, and at the same time when the number is divided by 5, its remainder equals 0, and both of these two conditions are true, then we print this to the terminal for the user. Otherwise, we say that, okay, this number is not the number that we are looking for. So let's compile to see how it works. So for the AND logical operator, both of the conditions must be true. So if I mention 3, it says no, your number is not divisible by both 3 and 5. Why? When 3 is divided by 3, okay, the remainder equals 0. However, for this case, for the second condition, it doesn't work. Let's try another number. So if I put 5 here, again, we have the same message here. It says that, okay, this is not divisible because the second condition is correct because the number is 5. So 5 divided by 5, the remainder would be 0. However, for the first condition, it's not true, it's not correct. Therefore, it escapes this if condition and directly goes to the else and print the outcome that the number is not divisible by both 3 and 5. So let's try another number. I would say 15 this time, and this time it says that, okay, the number is the number that we are looking for. Because 15 divided by 3, its remainder would be 0, and the same goes with this statement, this if condition, saying that if 15 is divided by 5, its remainder equals 0. Therefore, this statement is printed in the output. As you see, working with logical logical operator helps us to write a more efficient code. It would be nice a priori to writing a program, think about it deeply to see how we can integrate these features that are there for us to make our code more efficient and more advanced and concise. Hello and welcome to another coding exercise. So let's try some more coding exercises using logical operator. So we would like to see if someone can watch a movie or not. And the rules for watching a movie here is that either the person should be above 13 years old or the person is accompanied with an adult if the age is not above 13. So to do that, we initialize an integer called age and we initialize a boolean with adult. So the boolean can only take two values if you remember, 0 or 1. So we ask the user to enter their age and also mention that if they are being accompanied by an adult, 1 for yes and 0 for no. And the result is stored in with adult boolean using scene function. Then simply we here check the condition using OR logical operator. So in the OR logical operator, if you remember correctly, either of the conditions should be correct, not both of them necessarily. If both of them are correct, it's okay. But if one of them is correct, it's still okay and it enters the condition and reads the statement in the condition. So here it says that are you are you 13 or above, or are you being accompanied by an adult? If either of these two conditions are correct, then you can watch the movie. Otherwise, you cannot watch the movie. So what would be the option that is otherwise? The otherwise would be the option like you are below 13 and you're not accompanied by an adult. So let's try and see how it works. I would say the age is 20. Are you being accompanied by an adult? No, I'm not. So you can watch the movie. So here is it. Here it is. So the age is 20. So 20 is larger than 30. The first condition is met. And are you being accompanied by another adult? No, I said 0. And the second condition is not met. But because this is the or logical operator, one of the conditions only is okay to be met. So it enters and says that, okay, you can watch the movie. But here, if it was and logical operator, it was not allowing me to go and watch movie if not both of the conditions are met. So let's try another one. So I would say I am 10. Are you accompanied by an adult? I would say yes. It says you can watch the movie. So I am not older than 13. However, I am being accompanied by an adult. So the first condition is not met, but the second condition is met. Therefore, we enter here. So let's try another one. I would say, how old are you? I would say 8. Are you accompanied by an adult? I would say no. You cannot watch the movie. Why? Because neither the first condition nor the second conditions are met. So this is why it skips this part and then goes to the else part and says that you cannot watch the movie. Hi, welcome back to another coding exercise for logical operator. So here we would like to write a program that checks to see if a number is between 5 and 15. In order to do that, we need to use a logical operator for efficiency. We initialize one integer, we get the data from the user, we store the data, and we write down the if condition using OR logical operator. So we check if the number is lower than 5 or the number is above 15, the number is outside of the range. Otherwise, the number is within the range. So let's compile and see how it works. So if I say 19, it says the number is outside of the range because so the number is above 15, it says it's outside. And if we write something like 2, it says the number is again outside of the range because 2 is lower than 5. So if I write another number like 10, it says, okay, the number is within the range. But this is written like OR operator. Instead of having this OR operator, we could have AND operator. So we could write something like if the number is greater than 5 and number is lower than 15, number is in the range outside the range. So by changing some by doing some minor changes in the condition, we can see that we can use AND operator instead of OR operator. Let's try and see. So I would say, now I would say 19. It says the number is out because 19 is not in this range. Therefore, it says the number is outside. If I, for example, like 3, it says again the number is outside the range because it's not in this range. It's the number is not above 5 and at the same time below 15. However, if I put like 11, it will say, okay, the number is in the range 5 to 15. So you see, with small changes, we can use either of the logical operator. To do that, you need to practice. Please practice all of these coding exercises yourself several times so you can get used to it, and also you can get yourself familiarized with the syntaxes of C++. Hello everyone, welcome back to another lesson. Today we are going to discuss about Boolean flags and how they can be integrated in our if statement conditions and if else conditions. So previously we learned about logical operators. For example, here we initialize one integer, we read the score from the user and then store it. And then using AND logical operators, we check if the number is above 50 and lower than 100, then we print out the you passed the quiz and otherwise you failed. So this we learned previously. Let's try and see this one. So for example, I would say if my score is 76, it says you passed the quiz. It's very straightforward. We discussed this already. However, if we integrate Boolean flags into this if-else condition, it gives a descriptive name to the condition, making the purpose of the if statement clear and easier to understand when the code is shared with others. And also, they can help keep track of whether something has happened or a specific state has been reached in your program or not. So therefore, they can help us to reduce the error as well because we don't have to repeat certain complex, logic repeatedly. So let me give you an example. I will comment this part and then I will do the same. Um, I will rewrite the same code, however, using the Boolean flags. So instead of only initializing the integer, I am also here initializing a Boolean data type that is called passed quiz. So here initially I put it to false. It's your call, but usually when we want to use the Boolean flags, we initialize them to a false value, and then when the condition is met, we set it to true. So initially, by default, they usually are false. So here we show the message to the user saying that enter your score and then we store it. Here we mention that if the score is above 50 and less than 100 using AND logical operator just like before, if this is the case, don't right away print, okay, you passed the exam. Set the Boolean flag to true instead of false. That was by default initialized. So set it to true. And if this is the case, set it to true. So we don't have to write the else condition. So we are avoiding writing this else condition. We are just writing one if condition. So if this happens, the condition is passed, therefore the passed quiz boolean is set to true. Then in the end, we can check this condition saying that if passed quiz equals true, then you pass the exam, and else or otherwise you failed. Let's try this one. So it's compiling. Now I would say 75 and it returns pass. Why? Let's analyze the code. Here it checks the number with these conditions. It passes and then set true to passed quiz, and then because the passed quiz equals true, it prints that you passed the exam. Also, this part is redundant. We can also remove this. So by default, when we use a Boolean flag, so when we write no conditions for them, it means that if they are true, it's like that. So let's compile again. So we can eliminate that part as I mentioned. So now I would say 87 and it prints you passed the quiz. So easily you don't even have to mention that it equals if it equals true. The fact that you put the Boolean flag there without anything, it means that okay, if this is true, this is something by default known by the C++ compiler. So this way you can avoid the second else and let the decision be made only with this one. And of course, you need to add another if conditions to print out your result, but this way you are making your code to be more readable. So its readability is increased, and it is very common among programmers to use Boolean flag because it gives a description to your if condition. So this if condition is defined because we want to make sure if the person is passed or not. However, here, okay, after reading the code, we understand that yes, this if condition is defined because we want to check if the guy is passing the test or not. However, it is only showing a message saying that, but in this place, we are assigning true to past quiz. So you see the difference. Difference is that this code is more readable. It reduces the error and helps to increase the readability of your code. Thank you for watching. In next lectures, we are going to practice a little bit if statements with Boolean flags. Welcome back. Today we are going to do some coding exercises regarding the Boolean flag. So the program is asking that write a program that checks using Boolean flag if a user wants to continue or not. So for example, I don't know, you're playing a game or something like that, and the program will ask you, do you want to continue playing or not? So if you want to continue playing, you should push the button yes, otherwise no. And depending on your choice, the reaction of the system would be different. Here, we are going to do that using Boolean flag. So we initialize a character called choice and a Boolean flag named wants to continue. And we initialize it to false. As I mentioned, it's by default. We use it to false. If it's true, we then set the true to it. So we show the message to the user, do you want to continue? Yes or no? So the choice is stored using cin function, and it's a character, so it only can get y or n. Then we write an if condition saying that if the choice equals y, then set true for the wants to continue boolean that was by default set to false. So when the user says yes and says y, the true is assigned to wants to continue. We don't print anything up to here, okay? We don't print any results, let's say, because previously we were printing the message to the user through the terminal. Then we check if wants to continue, you chose to continue, else you chose not to continue. And as we discussed in the previous video, we don't need to write down equal true, for example, for wants to continue. By default, when we write down the boolean in the if condition, it is considered by default by the compiler that you're saying like if this is true. So even if you don't write equals true, it understands like you were writing if this is true, if this equals true, for example, something like this. So let's try it out and see how it works. So I would say y, it says you chose to continue. Let's analyze the code once more. So I said y, it then set true to wants to continue, and it says, okay, if wants to continue equals true, then you print you chose to continue. Otherwise, you chose not to continue. Let's try again. I would say n, it says you chose not to continue. You chose not to continue. So as we mentioned here, it helps to have a better code and a meaningful code saying that giving a meaning to the if statement of your code by using Boolean flag, and little by little, when you get to more advanced level and start reading other people's code, usually programmers that are in higher levels, they use Boolean because it gives some meaning to the if else conditions. Because when you read this code, the programmer, the reader who knows C++ would understand that, okay, the aim behind writing this if condition was to see if the user mentioned yes or no, rather than just printing a message and showing the result. Okay, because this is something we show here to we showed to you to see it, so you can have understanding and to see how the output would change depending on the input. But usually when, for example, we have a program like the game that I mentioned earlier, if you say you want to continue, you probably get back to the game and continue playing. And if you say no, you probably get out of the game and exit the game. So these messages usually do not show in the terminal, and actions are being done behind the scene. But we are just printing these things to show how the input can make the difference on the output, how they can have impact on the output rather than just showing the messages. So the reason behind showing the messages is this, so you can understand the procedure and how changing in the input can impact the output. So as I explained, Boolean flags are very important to be used. So think about them and start using them little by little in your practices and exercises. Thank you for watching. Welcome back to another coding exercise session. Today we are going to do some further exercises for the Boolean flags. So we want to write a program that checks if a number is even or odd using Boolean flags. So we initialize a number here, and then we initialize a Boolean called isEven equals false by default. Then we get the input from the user, we store it, and we say if the number modulo 2 means that if the number is divided by 2 and its remainder using modulo sign equals 0, then set true for isEven Boolean that was initially set to false. And then if isEven is true, then print the number is even, else the number is odd. Let's try it. It's 20. Yeah, the number is even. Let's try once more. 21. The number is odd. So here, I think after having a few coding exercises and seeing a few examples, you realize the importance of using if flag, Boolean flag, and in the if statements, showing that how useful it can be, and you will understand the logic behind it after doing a little bit of exercises, and you will see that, okay, it is making my program looks better, more advanced, and more less encounter to any errors and repetition. Thank you for watching. Hello everyone, welcome to another lesson. Today we are going to talk about switch function. So the switch statement is a control structure used in C++ to simplify decision making when dealing with multiple conditions. So it is an efficient and readable alternative to using multiple if-else statements, especially when we have several potential outcomes. So it helps us to have a more organized code and more clearly handling outputs when we have like several of them. So let's start with an example. Here we used if-else conditions. We say, okay, we initialize the integer called day with the value of 3. Then we say if day equals 1, print Monday. If it equals 2, print Tuesday, etc. until the end, until if day equals 7, print Sunday. And else invalid input. So all of them, the first one is if, the other ones are else if until the end. If neither of the above conditions are correct, just print invalid day. So let's try this code and see how it works. So it is printing Wednesday because we mentioned the day equals 3, then 3 here, and we are printing the Wednesday. But as you can see here, we're checking many conditions, and it's really hard to go through all these lines because there are many conditions to be checked. Instead of doing this, we can use switch condition. But let's first discuss how switch condition structure would be. So instead of saying if, we write switch, and then we write down the variable in the parentheses. Then we open the bracket, and when we open the bracket, we check the case with the first condition, again case, second condition, case with the third condition, and then as a default, it is exactly working like else. So if neither of the above mentioned cases were there, we use the default. When we write down the case, we write down the conditions, we put semicolon, and we go to the next line, and we execute the code whatever we want, and then we must write down break. So the program exit when enters this statement after executing whatever it needs to execute, it breaks. Otherwise, it also goes for the next case, and it also goes for the next case. So it is important for us to manually break it. So let's do the example. It would be more clear how it works. So let me uncomment these lines, and then we run the code that we have here. So already when looking at this code and comparing it with this code, you see that even it looks nicer. There are some spaces between them, and you can read it much easier. So we say the input is day, and it is set to 3, and instead of if, we write down switch and we put the day. So the day is our variable that we are trying to check some conditions over this variable. Then instead of having multiple if else if conditions, we are just mentioning case, 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 case until the end. So if case, instead of saying if day equals 1, we say case 1. It means if day equals 1. But instead of writing all of those things, we say case 1, case 2, case 3. It means that when our case, which is day here, equals 1, equals 2, equals 3. But we don't write those things. This is why it makes the program much easier. And then we have the semicolon, we go to next line, and we say, okay, if you enter this condition, print Monday. If you enter this condition, print Tuesday, etc. until the end. And we need to remember, we don't have to forget this break. We need to write down the break at the end of each case. And there is, instead of having the else after having all of these cases, we have a default here saying that if neither of the above things happened, if none of them were true, so you just simply print out invalid day number. So let's try and see how it works. It is printing again Wednesday, so it's much straightforward, and it is more readable as compared to using if conditions. So when we have a lot of conditions to be checked, it's easier to use a switch statement. So as you see here in this course, I'm giving you different tools and I'm teaching you different tools that are used in C++. And based on what you want to do, based on the application of your code, you need to wisely choose these tools. So you can use if conditions until forever and you can use it always, but is it efficient? No. Probably there are some cases that you need to write it with Boolean flags, you need to write it with switch statement, etc. So these are only toolboxes that I'm offering, and depending on your application, you need to first clearly think about all of these tools and see use how using these tools and when using these tools would be beneficial for you to write a more concise and efficient code. Welcome back. In this lesson, we are going to use a switch statement once more to see its application and to see how it would be easier to work with switch statements in some cases when we have a lot of conditions to check. So here we need to write a code that asks for three things, two numbers and one character. So based on the characters that we're going to choose between addition, subtraction, multiplication, and division, the program is going to execute one of these operations on the two numbers that we are going to give it as an input. So we initialize the character and two numbers, then we read and store the character, we read and store the numbers. One thing to mention here is that previously we were reading and storing the numbers one by one, but here we are doing another method. So we mentioned that enter two numbers and we stored them simultaneously. So when I enter the first number, it will be stored in the num1, and then when I enter the second number, it will be automatically stored in num2. Then we have the switch statement here. Our variable is operation. So depending on what operation the user is going to choose in the terminal, we need to do different things. So the if condition, previously, if we wanted to write the if condition, we would have checked if operation equals addition, equals subtraction, multiplication, etc. However, here we are not using that method, so we are writing switch and the variable is operation. So in case that it is addition, we just print out the result saying that result, and then we have the addition here, and then we break. So in case we have the subtraction, we have the colon, next line, result, subtraction, and then the break. So don't forget that the operation is defined as a character, so we need to have these quotations before and after our math operations. And if it's a star, it's multiplication. And if it's division, this is the nice place here to discuss some reviews for the if condition. So if it's division, enter here, and then we have one if condition that is nested in our last case. So, and then we mention if num2 does not equal 0, then num1 divided by num2 just show the result. However, if num2 equals 0, we need to write down an error because no number can be divided by 0 based on math. And then when these two if and else conditions are checked, we simply break, and the default is like the else condition in the if statement. So if neither of these above mentioned operations are entered, we just mention invalid operation. So let's try it out to see how it works. So I would say addition, first number 2, I enter, and then second number, I put it and I enter again. So it is storing both numbers and returns us the addition of these two numbers. Let's go through the code once more. So it stores two numbers simultaneously. It enters this switch part. In case that if in case that the user chooses to have the addition, it enters this place and then it gives us the result as shown here. Thank you for watching. Don't forget to practice this switch statement more and more so you get used to it and know when to use it efficiently. Hello everyone, welcome to another coding exercise lesson here. So today we want to write a program that depends on the input, it gives us different messages in the output. So we would like to write a program that prints stop if the input is R, prints get ready to stop if the input is Y, and go if the input is G, and also returns invalid color if neither of the above mentioned cases were given as the input. So to do that, we can simply use if else condition. However, because we have many cases, like 4 cases to discuss, it would be easier and more efficient to write switch condition. So we define a light color character here. We get it from the input. We show the message to the user, enter traffic light color, R for red, Y for yellow, and G for green. And then we store it. Then we have our switch statement and we are going to check the conditions on light color. Therefore, our variable is light color. And in different cases, we discuss the different cases here. So we say if it equals R, we don't write them down, but when we write case, quotation mark R means if light color equals quotation mark R. Colon, we enter this statement and we say cout stop. And then we need to remember that don't forget to write the break there. And the case it's Y, get ready to stop, it need to be printed. And in the last case, which is G, you can print go. In the default case, when neither of the above mentioned cases were true, we mention invalid color. So let's try it and see how it works. I would say G. It says go. I would say this time, I would say Y. It says get ready to stop. So let's analyze the code once together. So here it starts here, checks the R, saying that light color, does it equal R? No. Does it equal Y? Yes. So when it's not equal R, it escapes. Then it goes for the case Y. And then it is correct. It's true. Then it enters here. And then when it breaks, everything is exited. So the program stopped right there when you put the break. And in case we write something different, like if I say like D, it says invalid color. So because it checked 3 colors, input colors like R, Y, and G, and neither of them were there. So it went to the default statement saying that invalid color. So you see how it is easy to use switch statement instead of if else statement when we have many conditions to check. Hello everyone, welcome back. Today we are going to talk about for loops. So there are different types of loops that we can go over, a certain data type, and for example lists, strings, etc. Iterate over them. However, today we are focusing on for loops specifically. But in this section, we are going to discuss different for loops as well. So, for example, imagine that we would like to print a few numbers, and it would be very hard to do it easily. Like, for example, I could say cout number one and del. So I wanna write, like, imagine that I would like to print number 1 to 5. So I need to do it 5 times. So I modify this. I put 5 here, I put 4 here. So now I need to print this one. So let's compile and see. So yeah, here you see when I want to print 5 numbers, I need to write it down 5 times. Okay, but for 5 times it may be still okay. But what if it's 500 times? It would be very hard to, track the changes, to modify everything, and at least copy paste it. Even copy pasting it for 500 times, it's not easy job. So there are other ways to do it. And in programming, you something that can give us the best and most efficient way of coding. So in order to do that, we need to use loops generally. And today I'm going to tell you how to use for loops to do that. So imagine from number 0 to number 4. To do that, we come up with a for function. We have parentheses within which there are 3 main components in this parenthesis. So in the first component, we initialize integer as to be whatever the initial number of loop would like to be. So here in our case, we integer named I that starts from 0. Then we have semicolon separating the first part from the second. We have this I until it reads like this I until it is smaller than 5, not smaller equal than 5, only smaller than 5. Then semicolon saying I plus plus, and I plus plus means that the increment value of I. I'm going to discuss this in a few seconds. So for these are the 3 components of a for loop in parentheses, and then we start the loop actually as of here. So as of here, we start going through the loop saying that cout I, we print I, so we understand the value of I. It's a printing in the terminal, so it makes more, it increases the readability of the code, and then we print the actual value of the I. But how does it work? Let's see. So first we start from I equals 0. When we start from I equals 0, we enter this loop, we mention I semicolon, then we print the value 0. Then after that, we increase 1 time the value I. So initially we entered the loop with the I equals 0. We printed the value 0 using this line. And when everything is finished here, it goes back again into this. But because we have incremental value of I is now equal 1. And then with the value 1, it again enters this loop and prints 1 for us here. It iterates until it reaches to this condition. So until it is smaller than 5. So it iterates until it is 4. When it's 4, it breaks and we exit the loop. So let's try and see how it works. So now we're compiling. Okay. So here, as you see, it starts with the value 0. It prints I semicolon 1 space 0. Then it goes up again and enters the loop with value 1. It prints I semicolon, I colon space 1. And then it is incremented again, and it does this iteratively until I reaches 4. When I reaches 4, it enters one more time to the loop saying that cout I colon space print 4, and then when it incremented to the value of 5, it does not satisfy the second part of our for loop, so it does not enter again and it finishes the loop. So this is how we can print something like 5 times. Even if we want, we can say like instead of 5 we can put like 20. So whatever the number that we would like, we just put it here and it will just go for it. Let's see. Yeah. So here it starts from 0 to 19. And if we want to print number 20 as well, we can say smaller equal 20. And instead we could say, for example, let's start from 1 this time. So let's see. Okay, great. So we started from 1 and we're printing until 20. So generally, this is one of the most efficient way of printing iteratively instead of just printing everything manually. And in next lectures, we're going to solve some exercises and do some coding exercises to understand it better. So generally, the important thing is that we write the for, we have parentheses within which 3 parts needs to be filled, and then we enter the loop. Hello everyone, welcome to another session. Today we are going to do some coding exercises using for loops. We are going to write a program that prints even numbers from 1 to 10. To do that, we start right away with the for loop. So we start right away with the for loop and we open the parentheses. And here there are 3 parts to respect. The first one, we initialize one. For example, here integer value equals 1, and we set the upper bound for our integer value here because we want to start from 1 and go up to 10. We say smaller equal 10, and we have the incremental value saying that okay, first 1, then increase it 1 time, then increase it another time. So we use incremental values for that. When we finish 3 parts of the for loop condition, in the parentheses, we enter the for loop actually. Here, because we only would like to print the even numbers, we write one if condition here. So we say if this I is divided by 2 and its remainder equals 0, then cout I. Otherwise, we don't want it. So else we don't write it because we don't want to print anything in the loop because it is going to be printed for those that don't have the remainder equal to 0. So let's print this one and see how it works. Yeah. So it starts from 1. 1 comes here and 1 is divided by 2. Its remainder equals 0. No, so it does not do anything. And then it goes and comes back with 2. 2 divided by 2, its remainder equals 0. Then 2 is printed, and then 3 comes here. And when 3 comes here, 3 divided by 2, its remainder is not 0. And then it is doing nothing and it's printing nothing. And it goes until it reaches the last number. So iteratively it goes up. And here we could, like, for example, we could write something like else, and then here cout I, like this part. here. So here, if I do this, it is going to print 1, 3, 5 because 1, 3, 5, 7, 9, basically all the odd numbers, because odd numbers are not going to pass this loop. They're not going to pass this condition, the first condition. They're going to be in the second condition. So let's compile this one, see how it works. Yeah, so it is printing everything now, and it's hard to distinguish the result. This is why here we avoid using else condition. We just want the ones that are having the remainder equals to 0 to be printed. And if we wanted to, for example, print the numbers that are odd, we could write like this. So if I divided by 2, its remainder does not equal 0. This is going to print us all the odd numbers. So let's try. So it's compiling. Okay, great. So here, for example, I is divided by 2, its remainder does not equal 0, then it is printed. Then for second, for number 2, I gets the value equals 2. It enters 2 is divided by 2, its remainder equals 0 actually, and it does not enter this loop now. And then it prints nothing. Then I is incremented one more time. Now its value is 3. 3 divided by 2, its remainder does not equal 0. Then it enters the if condition and it prints the value. So this is how it works, and generally we can play with it like if we want to print all the odd numbers between 1 and 100. So it's easy to do it, but manually doing that, it takes a lot of time. So here we see that, yeah, it is printing almost, not almost, but all the odd numbers that are between 1 and 100. So this is one example, very small example, very easy example of how important the for loops are. However, we will see in other levels like intermediate and advanced level that we use these loops very frequently to do very advanced tasks. For example, if you want to find a maximum, the maximum number in a list of numbers. So we do iteratively, we go through all the elements of that list, for example, and then we write some coding there to find the maximum number in a list, for example, or the minimum number, and then we want to do some mathematical operations for that maximum number, etc. So these are very useful, especially if we are going through a lot of data, a list with a lot of inputs, for example, a lot of elements. So imagine that there are like 1000 elements in one list, and you would like to find the maximum number. Manually doing that, it would be very hard, and it takes a lot of time, it increases the error, etc. But doing programming, this is why we are programming. In fact, it can give us the result very fast. Hello everyone, welcome back. In this session, we are going to do another coding exercises. Here we are writing a program that calculates the sum of numbers from 1 to 5. So to do that, we can do it manually, which is the hard way. The easy way is to use for loops. So we initialize sum as to be 0. Then we start a for loop right away. And it has three parts, as you know. So because we are calculating the sum of numbers from 1 to 5, it starts with 1 and its upper bound is 5, and it is incrementing one step at a time. So and since sum equals 0, it is initialized to be 0. Here we have 0 equal 0 plus 1 in the first iteration. So I equals 1. So 1 is assigned to sum. Then it goes up again, I equals 2, and it enters the loop again. So I equals 2 here, and plus sum was 1 from the previous iteration. And the sum of these two will be 3, and 3 is assigned to sum now. So it goes until I equals 5. When it equals 5, it enters for the last time. It does some calculation here, and then the loop is finished. And the final value of sum is printed here. So also I put one line here so we can iteratively see the increase in the value of sum. So let's see how it works. Okay. So as I mentioned here, the first one is sum is 0 and I is 1. So 1 is assigned to sum. Then I is 2, sum is 1. They are 3 and 3 is assigned to sum for the second round. For the third round, it will be 6. For the fourth round, it is 10. And for the last round, it is 15. The last round is stored in the sum for the final number because we are not going to enter the loop anymore. And then we print the value of sum here. So one of the ways to do some of these calculation is using for loops to make it easier. It is always possible to do everything manually, but we're coding to, increase the speed and have more efficiency, etc. So one point here is that now we are saying sum equals sum plus I. So even for this, we could write our code even more simpler and more efficient. So writing it like this, sum plus equal I is exactly like writing sum equals sum plus I. So we could use either way. So let's try this one and see if there is any difference or not. So there shouldn't be. Yes. So as you see, the results are the same. So the results are the same, and it's only the matter of how you would like to code. Usually in advanced programmers are using this method because it's more concise. So if you see something like this, it means that sum equals sum plus I, but it is a more concise way of writing it. Hello everyone, welcome back. We are going to do another coding exercise using for loops. Here we would like to calculate the factorial of number 5. So in order to do that, we can use for loops to calculate the factorial of number 5. So to do that, we initialize the factorial equals 1, and then we right away start with the for loop. So in order to start with the for loop here, we start using the int I equals 1 until 5 because we are considering the factorial of number 5. So if we are considering factorial of number 10, we can put 10, the upper bound, and then it increases one step at a time. Then we enter the loop. When we enter the loop, we calculate the factorial equals factorial times I, or more concisely, we can say factorial times equal I. We could write either this or factorial times I. So either way, there it is going to give us the same result. It depends on you, but it would be nice for you to start making your code more concise as you proceed. So let's see how it works. So it is compiling now. Okay, so here it is. We start with the value 1. So the factorial initially is 1. So 1 times 1, when I enters the loop, its value is also 1. So 1 times 1 equals 1. Then uh, we have the I equals 2 times the previously iterated factorial is 1. So 2 times 1 equals 2. Then factorial is 2. So let me just write it down. I think it would be easier for you to grasp. So I equals 1, it will be like 1 equals 1 times 1. So here you see when the I equals 1, it enters the loop. So the factorial is 1 equals factorial again is 1 times 1. So when I equals 2, it's like factorial again is 1, then factorial again is 1, and then it's 2. So the final result would be 2. So when I equals 3, it's like 2 equals 2 times 3. So 2 times 3 would be the new value, which is 6. So I would say here factorial, yeah, factorial. So let's write the results in this part. It would be, I think, easier to grasp it, so we avoid any mistakes. So in the next round, when I equals 4, we have factorial equals 6 times 4, which is 24. So far we see, yeah. And then the next round, which is the final round, is done, which is 120. And it gets the final result. But if you still think that it is hard to understand this concept, we can keep using it until we get used to it. So the formula would be like factorial equals the current factorial times current I. So because the first factorial is 1, we have 1 here, and the first I is 1, we have the 1 here, and the final value for the factorial in the first iteration equals 1. Then we have the second round. The second round, I equals 2, because I is incremented in the second iteration. So the value of factorial equals 1 because it comes from the previous iteration, and its final result would be 2. In another iteration, I equals 3, then its multiplication with 2 would be 6. So 3, because it's the third iteration, 2 comes from the previous value of the factorial from the previous iteration, and it equals 6. And then I equals 4 in the fourth iteration times 6, which is the value of factorial from previous iteration, and the final factorial would be 24. Let's write the last one as well. So I equals 5, we have factorial equals 24 times 5 equals 120. And when I equals 5 times 24, which is the value of factorial from previous iteration, and the final factorial would be 120. And we don't have I equals 6 because the upper bound for the I is to have I smaller equal 5. And then the loop is finished, and here we are saying the factorial of 5 is, and then we print the actual value of the factorial that we did the operation over here. So this is actually how the logic is behind the for loop. Hello everyone, welcome back. In today's lesson, we are doing another coding exercises using for loops. So another possibility for for loops is to print two things simultaneously. So So far, we were increasing the value of I from one number to another, but it is possible to decrease its value from one number to a lower number, and we can do things simultaneously. So look at this example. We start with one for loop, and it's a bit longer for loop as you see here because two integers are defined, but it still has its three parts. So in the first part, we mentioned that int I equals 0 and j equals 5. So if you remember previously, I could tell you that we could initialize I equals 1 and we could initialize b equals 2, or we could say int I equals 1, b equals 2, simply like this. So it would be more concise. So here the warning is that because we are not using them, but it is possible, we had this in previous sections, that we could define two integers in one line. So here we are doing the same thing. We are defining the int I equals 0 and j equals 5, but the only important thing is that you don't have to forget this comma to differentiate them. Then a semicolon, meaning that the first part is finished. So upper bound and lower bound here, if we want to put, saying that, okay, we would like to I to be lower than 5, and it's a logical operator, and at the same time, j to be greater than 0. So when both conditions, because it's an AND logical operator, when both conditions are met, this part is satisfied. And in the last part, so we then have another semicolon here to differentiate the second part and the third part, and then we have the incremental value of I and decremental value of j. So we are saying that, okay, I has to increase one by one, but j has to decrease one by one. So if everything goes well, we enter the loop finally. We see out I, colon, space, and print value of I, and then we put a comma here in the printing because we want to differentiate the I and j. And then we put j and we print the j. So it's as simple as that. So let's run. Okay, it's compiling. Okay, so let's analyze the code. So the first time that we enter the loop, I equals 0 and j equals 5, as it is printed correctly, because I starts from 0 and j starts from 5. So the first time it enters, it prints the value I and j. Then in the second iteration, I is increased and j is decreased. So I equals 1 now, it is still lower than 5, so it enters, and j is now number 4, and 4 is still greater than 0. Therefore, both conditions are met, and it is important to have both conditions being met as it is an AND logical operator. So we enter the loop again once more, and we have the I equal 1, j equal 4. So this time, this iteration is finished. Then we increase the value of I, we decrease the value of j. So now I is 2 and j is 3. Everything is passed. I is still lower than 5, j is still higher than 0. It enters this for loop again, and it prints like I equals 2, j equals 3. It finishes until it continues until I equals 4, and then j equals 1. So it prints these two values, and then when it increases the value of I and decreases the value of j, we have I equal 5 and j equals 0. And having these numbers for I and j, it will not pass for the second part of the loop because I has to be smaller than 5 and j has to be greater than 0, and they are not allowed to be even like I is not allowed to be smaller equal 5 and j is not allowed to be greater equal 0. Therefore, uh, we finish just right there when I is 4 and j is 1. Hello everyone, welcome back. So today we are discussing the same coding exercise, however, with a minor change. So here we learned that if we want to increase and decrease the value of two integers simultaneously, we can use this for loop. However, so far we were increasing the value of I one step at a time, and previously we were decreasing the value of j one step at a time. Here we know that we learned that we can do it like in each iteration it increases the value of 2 times. So this I plus equals 2 is exactly like the one that we learned before, something like I equals I plus 2. So this is simply this statement, but written in a more concise way here. So here it means that whatever the value of I is, increase it by 2. So if we print it, if we compile it, we will see how it works. Okay, so let's analyze the code. Here we see that the initial value of I equals 0, initial value of j equals 5, and then again the same rules for the second part. I should be lower than 5, j should be higher than 0. However, here I increases 2 times in each iteration and j decreases 1 time in each iteration. So firstly we enter with I equals 0 and j equals 5. Then I is increased 2 times and j is decreased 1 time. So I is 2 now, j is 4 now. So I is still lower than 5, j is still higher than 0. Then we enter again and we print these two values, I equals 2 and j equals 4. And finally, we increase the value one more time. We iterate one more time, and the value increases for I equals 4 and j equals 3. We print this, and then in the next iteration, I increases by 2 values, so the I would be 6, and j decreases by 1 value, so j would be 2. So let me write it down here. I equals 6, j equals 2. So in this case, this part does not pass. Why? J is greater than 0, no doubt about that. But I does not, in fact, I is not lower than 5 because its value is 6 now. And because we have an AND operation here, and operator here, and both of these two conditions must be met. So either of them, if either of them is not met, then we cannot enter this loop. So since I equals 6 is not lower than 5, this condition will not pass and it does not go through. Therefore, the loop is finished when I is 4 and j is 3. So this is how AND operator would work. If it was like OR condition, it would have worked because either of them, if either of them work, it will work. So let's try to see how it works with OR. You see the difference here? Okay. So you see, so first I0, J5, then I2, J4, then I4, J3, and in the next round I6 and J2. Yes, I is not lower than 5 in this case because it is 6 now. But since we are using OR operator, and when we are using OR operator, either this condition should be true or this condition. Since this condition is still true and J equals 2 and 2 is greater than 0, it enters again. And for the next round again, I equals 8, which will not pass the first condition, obviously, but for the second condition, j equals 1, and 1 is still higher than 0, so it still enters, but it does not continue. Why? Because in the next round, I would have been 10 and j would have been 0. In this case, I, when it's 10, 10 is not lower than 5, and 0 is not greater than 0. Therefore, neither of the conditions would have been met. So this is why the next round is not done and the for loop is finished when j equals 1. So the important thing here is that to make sure when we are using AND operator, both sides of AND must be met. However, when we are using the OR operator, either of the side, if it's met, it's okay, we enter the condition. Hello everyone, welcome back. Today we are going to talk about another way to write loops. And here in this lesson, after finishing the for loops in a previous lesson, we're going to focus on while loops or while conditions. So there are different types of loops that we can employ to write certain number of blocks to print certain number of blocks and execute certain number of codes, and one of them was for loops and the other one is while loop. So here the structure of a while loop would be like we say while and then the condition, and then we enter the executive part, and this is the place where we write down our code. So let's start with an example. I think it would be easier to grasp the idea when we make an example. So here previously we used to go through the for loop. So if we want to write a number to write a program that prints us number 1 to 5, we had to write like for loops, something like this. Let me just type it down. Int I equals 1, I equal smaller equal 5, I plus plus, and then we could say okay, print I and L. So this is how we used to print number 1 to 5 previously. However, if we want to do the same thing but using while loop, we can break down these three parts of the for loop into different parts. So first we initialize the integer number named num as to be 1, and then we start the while loop. So we start the while loop, and in the parentheses we only write down one part of the condition, which is as long as num smaller equal 5. So the condition would be something like this. So we repeat the while as long as num is smaller, less than or equal 5. Then we enter the loop. So we print out the num, and here we are incrementing the value of num ourselves. So previously we used to put this part in the parentheses, but we are putting the uh, increment part inside the loop. And previously we used to initialize the integer in the parentheses, and we are initializing it before the loop. And then we are printing the num using this cout function, and also the second part of the parenthesis for the for loops is exactly printed here. So the reason why we may need to use, for example, while loops to execute our code is because a while loop in C++ is it can help us to repeatedly execute a block of code, like similar to the for loop. However, the while loop is more straightforward and often is used when the number of iteration is not known beforehand. So when we don't know how many iteration do we need, we simply use a while loop and we say as long as the num less than or equal 5, just do this for us, and then change the value of num so we can increase it or decrease it as we want to see in this line. However, if we forget to write this part, it will become like an infinite loop because it is printing, for example, num equals 1, it enters the loop, it prints 1, and then it prints 1, and then it prints 1 forever until we stop the program because 1 is not being increased. So when we increase the value by 1 here, then the next time that it enters the loop, it's 2, then it's 3, etc. So let me just run the program and see how it works. Okay. So yeah. So here num equals 1, and when we want to go through the condition of the while loop, we say, okay, num equals 1. Num is less than or equal 5. Yeah, it passed the conditions. It enters the loop. It prints 1. Then it increased the value of num by 1. So num would be 2. Then it comes here again and checks the condition. 2 less than or equal 5. Yes, enter, print, and then increased. So now it's 3. 3 smaller or equal 5, yes, enter, increase, it will be 4. And then again until it's 5. When it's 5, it enters for the last time. And when we increase the value, it will become 6. And 6 is not less than or equal 5. So therefore, it does not enter this loop again and the program is finished. So this is how while loop would work. And in the next sessions, we are going to do some coding exercises using while loops. So it would be easier for you to see it in different examples and start making it understood for yourself and start coding it yourself. Thanks for watching. Hello everyone, welcome back. Now we're going to do some coding exercises using while loop. We would like to write a program that works like a calculator to adds up whatever we give it as an input, and it's going to work as long as we are adding a new numbers, except if we put 0, it will stop. So for example, I would like to add a few numbers and know the sum of all of these numbers. So I keep entering new numbers, and if I mention if I put 0 as one of the numbers, the program knows that I would like to finish the input numbers, and it returns me the result. So for this program, we need to write a while loop. We cannot write it using a for loop because we don't know how many numbers the user would like to give us so that we can do the calculation for him. So as long as the user is giving us any number, we're going to store the number. And when he or she gives us the number 0, we consider it as a sign to that he is done with entering the numbers. So we do the final mathematical addition for him or her and return the person the result. So let's see how it works. I think when we run the code, we can understand it a bit easier. It's easier to understand. So we initialize one number called number, we initialize another integer called sum. We set sum to be 0, and then we tell the user enter numbers to add and 0 to stop. So if the person enters 0, the program is going to be stopped. However, any other number to be entered by the user means that the user would like to add these numbers. So the number is read from the user using cin function. So we write a while loop here. So the while loop would be like this. The condition is like as long as the number is not equal 0. So continue until user enters 0. As long as the user is not entering 0, enter this loop. We enter the loop. We assign the number to sum, store it in the sum, and then we ask again from the user to give us the new number that the person would like to add up to the previous number. So let's try it once. It's easier to grasp the idea. So I mention, okay, enter numbers to add. I say 1, I enter, nothing happens. I say 2, I enter, nothing happens. I say another 2, nothing happens. Now I put 0. So now it's done. When I put 0, it gives me the final sum. So 1 plus 2 plus 2 would be 5. And when I put 0, the program is finished, because here we are mentioning that enter this while as long as number does not equal 0. So when I put 0, it cannot pass this condition, and it simply prints out the sum. And how is it printing the sum? So let me remind you of this. So we learned that this line would be, so what we have in line 181 here equals this line. So instead of writing this, they wrote this. So let me just show you how the program worked in my example. So initially I mentioned the number to be 1, 2, 2. Okay. So initially I said number equals 1. Then I mentioned number equals 2. Then I mentioned number equals 2 again. So it starts with this. So the sum is 0. It says sum equals 0 plus 1. Then sum equals 1 plus 2. Why? Because, so initially the sum equals 0 because we initialize it to be 0. And we enter the number to be 1 in the first round, and 1 plus 0 is 1. So 1 is assigned to sum. So then it goes for the next round. So as for this equation, sum equals 1 from the previous iteration. So the value of sum is 1 here, plus number. So as the second input, I put 2. Then the value would be 3. And then the equation would be 3 because 3 was the final value of sum from previous iteration. And in the new iteration, so the sum is 3 plus I mentioned the another 2, so the sum would be 5. It's exactly how it is computing this sum here. So 1, 2, 2, and then when I put 0, it exits the program. Let's try it once more. So so it's basically working like a calculator. If I say 1, 15, 18, 20, and then 0, it computes everything for us. So 20 plus 15 will be 35, plus 18 and 1 will be 54. So this is how Our calculator is working here. When we smash the 0 button, it exit the program. And this is actually one of the usefulness of while loop. So we don't know how many input the user can give us. So it is customized. So one user can use it for 2 times, one user can put it for 10 times, whatever they want. And when they are done, they can put 0. Of course, we could do it using for loops as well. Using for loops, there were some ideas to say that, okay, we are going to ask you a bunch of numbers that you would like to add. Please first tell us how many numbers you want to add initially, be a priori. So that we could do in a for loop as well, but it's much easier to do it using while loop. So this is actually why while loop is there. Thanks for watching. Don't forget to exercise these coding exercises yourself. Hello everyone, welcome back. Welcome to another coding exercise. Today we are going to write a program that counts down a number from 10 until 0 and prints the value one by one as it is decreasing. To do that, we use while loop here in this example. So we initialize countdown integer as to be 10, and then we mention while the countdown is greater than 0, enter this condition, and first print the countdown for us and then reduce its value by 1. So then next round the countdown number will be 9. It prints 9, it reduces the value to 8, then another time 8 is still bigger than 0, it enters the loop and it prints the 8 and then it reduces the value. So let me run and then we analyze the code once together. So here, as you see, it says 10, 9, 8 until 1 and then lift off. So this is how the program works, as you see here. So 10 is the initial value. Is 10 greater than 0? Yes, it enters. It prints 10 here. Then it reduces the value of 10 by 1. So now the countdown equals 9. It comes back here. 9 greater than 0. Yes, enter. Print 9. Reduce the countdown value by another 1 value. Will be 8. So 8 greater than 0. It prints 8. It reduces the value again by 1. It will be 7 now. 7 greater than 0, prints 7 and reduce it by another 1 value. So we continue until it's 1. So 1 greater than 0, see out 1, we print the 1 and we reduce the value of countdown by 1, which will be 0. So 0 greater than 0, no. So it does not pass this condition. It will not go through the while loop anymore. And it says lift off. So this is how while loop would work. So we can increase and decrease the value in the loop. So previously, if you remember, we had 3 conditions for loops. We used to have like for int equals I int I equals 1, I smaller than 10, for example, I plus plus, and in this situation, do something, for example. It is notable to consider this. So this int I part is written here, for example. This second part condition is written in parentheses for the while loop, and this last part, the incremental part or decremental part, is written within and inside the while loop. So this is the only thing that we need to be careful about. Otherwise, it's very straightforward and it's good for you to start practicing and coding hands-on programming so you can get to know these little things and these little steps to make errors and learn from your errors. Thanks for watching. Hello. So today we are going to discuss another way to write loops. It is do while. So it is very similar to while loops, but there are certain differences. So a do while loop in C++ is similar to a while loop, but with one crucial difference. A do while loop will execute the block of code at least once, even if the condition is false, on the first check. So this is because the condition is checked after the code has run and not before. So the main advantage of a do while loop is that it ensures the code block runs at least once, no matter what. So this can be useful when we want to ensure the user interacts with your program, or when you need a certain action to take place at least once before checking a condition. So it's often used in programs that require user input because you typically want to prompt the user at least once before deciding if you need to loop again or not. So this is basically how it works, and generally we start the structure would be, we say do, and in the brackets we execute the code, and we say while, and then we put the condition. So let's see an example here. So we initialize one integer called number, and then we say do, we open the bracket, we say enter a positive number. We store the positive number that the user enters, and we check. So if the number is lower or equal 0, we say that's not a positive number. Please try again. And then it comes here. So the condition is that if the number is lower or equal than 0, lower than or equal 0. So it repeats until the time the user gives a positive number. So to say it in an easy way, it would be like this. It asks me to give a positive number. So if I enter a positive number, the loop will finish, and then it prints out this line saying that thank you, you entered, and enter and print whatever we entered. Or if I give it a negative number, it enters this if condition. For example, I would say -2. So if I say -2, it is for sure lower than 0. It says, okay, that's not a positive number, try again. And while the number is -2, go back to this part again, enter a positive number, and then we store the number, and then it sees if it's positive or negative. If it is negative, it repeats everything again. So let's try and see how it works. So enter a positive number. I would say -20. That's not a positive number. Please try again. So -25. Enter again. It says that's not a positive number. Please try again and enter a positive number. -30. It will not finish as long as I'm giving a negative number. And when I say like 20, it says thank you, you entered 20. So this is how generally a do while situation, a do while loop would work. So I entered 20, it stored, I firstly entered -20, it stored -20. -20 is lower than 0, yes, so it prints this value and it says, okay, while -20 is lower than 0, go back to the do. So it starts from here again, enter a positive number. And we entered -25 here. It says -25 lower than 0. Okay, it showed this message and saying that okay, 25 is lower than 0, go back to the top. So it goes back and to the top again and again and again until I enter a positive number, which is the case here. And then it says thank you, you entered 20. So this is basically how a do while loop would work. It is being executed first, as we mentioned, then the condition will check, will be checked to see if another execution of code is required or not. So if I was going to, oops, sorry, what did I do? Yeah, so if I was going to, enter like a positive number in the initial iteration, like if I say enter a positive number and if I say 11, it says thank you, you entered 11. So I say enter a positive number, it says okay, the number is 11. Number is 11 is not lower than 0, then it escapes. It's not lower than 0 again, it escapes. So the loop is not going to be executed anymore, and it says thank you, you entered like 11. So it is one time executed and then the condition is checked here. So this is the main difference. Hello and welcome back. Today we are going to give you a coding exercise using do-while loop, so you see how practical this do-while loop is. So we are going to write a program that checks to see if you're entering your password correctly or not. As long as you're not entering your password correctly, it is going to ask you enter the password again and again and until it is correct. So when you enter the correct password, it finishes the program. So initially we initialize two strings, one password and one corrected password. So imagine that the correct password is ABC, something very easy. And we start our loop here, do, so it enters the loop without checking any conditions. It says enter the password and you enter your password. It says if the password is correct, it does not enter this condition because this condition says that password does not equal the correct password. So if the entered password, the one that you enter, is not equal to the correct password, that is ABC, it says enter incorrect password, try again. And it says as long as the entered password does not equal the correct password, ask this again from the user. And if by chance you mention that, okay, enter the password and you enter the password and the password equals correct password, it does not enter this if, it escapes, and here the condition does not pass because the password equals the correct password, so it does not have to go another time in the loop, and it says access granted. So let's try and see. So if I say ABC, it says access granted. So here is my password. Here is the correct password, ABC. Enter the password. I say ABC. So ABC, it says that password does not equal correct password, but this is not our case because the entered password and the correct password are the same. So it escapes this loop. Then it checks to see as long as password does not equal the correct password. So this is not also our case because they are equal. Therefore, it finishes the loop and it gives us the access. However, let's try once more, and it says like enter the password. I would say something like this. It says incorrect password, try again. I would say anything, try again, try again. And whatever you enter, it says try again. And in the end, I mentioned the correct password and it says, okay, access granted. So you see, this is very useful example, and this is a very practical example. In the real world, we have some access like that in the world when we want to check something like emails, etc. Of course, there is a limit until like you can repeat it for 2 times, 3 times. After that, your account will be blocked for security reasons. However, we can use the do while to do that. So here it says enter the password. I say QWE. It says they are not equal. Therefore, it enters this if and prints incorrect password. And because they are not equal, like the entered password and the correct password are not equal, it goes to the loop once more. It says enter the password and it stores. And I said TRTY, they're not equal, it says incorrect password, try again. So it is what it is printed here. And then because they're not equal, it goes again to the loop. So this continues until I give the correct password in the end, and it says access granted. Hello everyone, welcome back. Now we're going to do another coding exercises using do while loops. So here we would like to write a program that asks a user saying that, would you like to play the game or not? So if you want to play the game, it will go through the loop again and again. Just imagine when it goes through the loop, it means that the user is simply playing the game one more time. And if the user says no, it finishes the loop and it gets out of the loop and the program is exited and everything is finished. To do that, we define a character called play again here, initialize as a char, and then we have a do while situation. So do, and we open the bracket, we say you played the game. So already, for example, just imagine already the user is in the game and the game is finished now, and this message is shown to the user. So you played the game. Do you want to play again? Y or N has to be yes or no. And whatever the user says, it is stored in the play again character using cin function. So if the user says lowercase y, case y or uppercase y, means that the user would like to play the game one more time. So imagine when the user says yes, the program will do another round of playing and then it shows you played the game. So do you want to play again? The user says yes. So the user says yes, play one more time, and then it says you played the game. And if the user says no, it breaks the loop and everything is done, everything is finished, and it see out saying that thank you for playing, goodbye. So, and then imagine that it exits the game, exit the game. So, why we are having but this condition here? So, in order to consider this condition here, we have a play again character, and we have an or operator, logical operator. So, because C++ is sensitive to get the result as y or y, they are perceived to be two different things. We mention if the written answer from the user is either of lowercase or the uppercase. So because in the or logical operator, we know that either of the side of the condition must be true. So if this is true or this is true, then it repeats the loop again. So if the user says y in lowercase or uppercase, it knows that the user wants to play one more time. But however, if we didn't have this part, okay, let's imagine that we didn't have this part and we only have this part of the condition, this play again with lowercase y, and if the user answers with an uppercase y, it does not know it does not recognize y because only lowercase y was initially defined to in this condition. So it is important to consider both cases so we make sure we're not missing anything. So let's run the code and then we analyze the code again. So it says, do you want to play again? I would say yes. Do you want to play again? This time uppercase yes. And yes, lowercase y yes. And do you want to play again? I would say no. So thanks for playing, goodbye. So it, as we explained, do you want to play again? I would say y. I would say yes, showing y. And then it says, okay, the guy said y, let's do the loop again. And it asks me again, do you want to play again? I would say yes, another round. And then if I say yes, another round and another round, etc. And if I say no, because this condition is not passed, this while condition is not passed, then it gets out of the loop and it says, thanks for playing, goodbye. So you see that there are some practical examples for do while, and they are pretty common everywhere. When I make these examples, you can see that everywhere you're in every day, on a daily basis, you face these situations that are using these do whiles or for loops to fix some problem and provide some services to their customers. So please practice all of these things one by one and try to do the coding yourself, try to make the error and try to understand where the problem comes from. So from errors is where you can learn how to do the coding. Just stay tuned, and in the next lessons we're going to go through another type of loops. Hello everyone, welcome back. In today's lesson, we are going to talk about nested loop. So a nested loop is simply a loop inside another loop. This means that you have one loop running within the body of another loop. So the outer loop runs a specific number of times, and for each iteration of the outer loop, the inner loop runs completely. So imagine a clock. So the hour hand is like the outer loop and the minute hand is like the inner loop. So for every movement of the hour hands, which is the outer loop, the minute hand inner loop completes a full cycle. So another way to visualize this is to think about a grid of rows and columns. So the outer loop iterates through the rows and the inner loop iterates through the columns. So in order to make it more clear, let's come up with an example. So here, just imagine that we would like to write a program that generates a 5 to 5 multiplication table. So we have rows and columns here, and we want to see this in the output. How to see this in the output? Previously, we learned about how to do for loop, but when we were doing for loop, it was like 1, 2, 3, 4, 5. So, and that's it, or 1, 2, 3, 4, 5. So it was not like a full table. So I would like to write a program that generates a 5 to 5 multiplication table and shows something like this. To do that, the outer loop is defined like int I equals 1, I smaller than or equal 5, and I plus plus, and then we enter the loop here. And then we have the the inner loop, we have the int j equals 1, j lower than or equal 5, and j plus plus. And then we see out I times j. So let's run first the program. So exactly as we want it. So exactly as we want it, we have like 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. But how does it work? So let's analyze the code a bit so we can understand how it works. So here we enter the loop with I equals 1, then j equals 1. So when I equals 1 and j equals 1, I times j would be 1. Then still here we had the I equals 1, j equals 1. So and it's finished now. We did the calculation and we printed 1 here like this, and we also put it here. Then j is increased by 1 value while the I stays the same, because we didn't finish this loop first to go back and increment the value of I. So I stays the same and then j increases. So the first result was I times j equals 1. Okay, so now I still equals 1 while j equals 2. Now I times j equals 2. Another round. I still equals 1 and j increases until it reaches, 5. I equals 1, j equals 3. Then we have I times j equals 3. And this continues until we have I equals 1 and j equals 5. Therefore, I times j equals 5. So when we reach this stage, it's the first line being printed. Yeah. So it means that this j started from 1 and reached to 5. Okay, so it reached to 5. Now it has to get out of this inner loop. When it gets out of this inner loop, we print out cout and l. So it is here now when the j loop finishes, and it goes to the next line here. And when it goes to the next line here, please note that it is in the first loop still. It goes up. So now the value of I increased from 1 to 2. So now we have I equals 2, j equals 1 again, and I times j equals 2 as to have here, as we have it like here. So, and then I stays 2 until j is 1, 2, 3, 4, 5, and when j reaches 5, it again finishes the inner loop and it goes to the next line using this end L function. It is here, it goes to the next line, which will be here. So now I is incremented from 2 to 3. So then it does the calculation again. So this is basically how inner loops would work, and it's a very nice way to make when we have two-dimensional arrays, lists, numbers, etc. We can use nested loops, and they are very convenient to work with, and they are very practical. So I would suggest you to practice this nested loop example as much as you can. So, and you start, if you forget what I told you about the analyzing this part, it would be nice to go back and review these analyzes and then start doing the coding yourself. And then when you forgot, you either can come back to this video or you can start doing the analyzes yourself to understand the logic behind it. It would be very important, I guess. And then move on to the next coding exercises. Thank you for watching. Hello everyone, welcome back. Today we're going to do another coding exercise here. So we would like to write a program that prints a pattern of numbers in the form below. So this is the form that we would like to print. So in order to print something like this, we usually don't know it by heart. We need to think about it. So this is where the programs get a bit more complex than before, and we need to start thinking about how to get to the result that we want a priori to start just right away coding the program. So in order to print that, we can use a nested loop. To do that, we have one outer loop and one inner loop. So in order to have these two loops, we first start with the outer loop, that is I. We say, so let me first run the program so we see that we have the result and then we analyze it. Okay. So here we have the result as we wanted. So, but how did we get there? And with only 3 lines of code. So how did we get there? Let's analyze the code. So first we have the outer loop, which says integer I equals 1, I lower than or equal 5, I plus plus. Then So this is not something very strange. This we have. This we already had in many examples. So here we also have this for int j equals 1. However, the upper bound of j is I. So j must be lower than or equal I, and then we increment its value one step at a time. And then we print the value j. When the first loop, the inner loop is finished, we go to next line, and then we go to the outer loop again. So how does it work? Let's see. Let's start writing the output here step by step. It would be easier to understand the logic. So first I equals 1, we enter the loop. J equals 1, and at the same time, j must be lower than equal I. So an I is 1, so j must be lower equal 1. So only one iteration for j is allowed because it already starts from 1 and it must be lower than or equal to 1. So when it enters I equal 1, j equal 1, and the result would be 1. So it prints the value of 1 like this because we are having C out j. Then it goes here, so the inner loop is finished. It goes here, it goes to the next line. This is where the first one is printed, and then it's go to the next line. Now I equals 2. I equals 2, j again equals 1 because it starts from 1 every time. And j must be lower than or equal to I, which will be something like this. So j will be lower than or equal to because the value of I is 2 this time. So given this, we will first start with j1. So with j1, the inner loop is executed, so it prints 1. So the first result will be 1. And then it goes to the inner loop again. It increments the value of j, and j will become 2. 2 is still lower than or equal to as the condition here, so it enters the loop again and prints the value 2. So it prints 2. When it prints 2, it reached its maximum level, so it reached its upper bound, which is equal to I. So I is 2 and it reached 2, so it's finished. So the inner loop is finished. It prints it does one handle, so it goes to the next line here and starts from here. So now it goes to the first outer loop. So now I equals 3 and j starts from 1 again, and as j has to be lower than or equal to I, it means that j must be lower than or equal to 3. So j starts from 1, 1 enters the inner loop, and we print 1. Then we increment the value of j. J is 2 now. 2 is lower than or equal to 3. So yes, it comes here again and prints the value 2. And another time j is increased, and then now the value of j is 3. 3 is passing this condition, so 3 lower than or equal to 3, yes, so it comes here again and prints the value of j. So now that j is 3, it reached like this, like it's like writing 3 lower than equal to 3. So it does not it's not able to go another round, because if it goes for j equals 4, it does not pass this condition here. So because of that, the inner loop is finished. it goes to the next line using this part of the code. So, and it goes to this part. So as you see here, this one here, we reached here. Then we have this one, which is here. Then we have 1, 2, 3, which is here. And then next time when the inner loop is done, it comes here, it goes to the next line. We were here, it goes to the next line. So now we are here with this line, and then it has the outer loop. So it goes back up again. So I was 3, we increase the value of 3, it will be 4 now. 4 is lower than or equal than 5. Yes, pass the condition, enters here. So enters the inner loop. So I equals 4, j equals 1. So j must be lower than or equal to I, because in the second part of the for loop this condition applies. And then it means that because I equals 4, it means that j must be lower than or equal to 4. To do that, j equals 1 starts the loop while I is 4. So it's like writing 4 here for this time, for this round of iteration only. So j equals 1, it prints 1, and then it comes back to this line. Okay, it increased the value of j and then prints 2, then comes back to this line, increase the value of j, print 3, and then 4. When it reaches 4, it means that j is equal to its upper bound, then it cannot continue. So that it cannot continue, it finishes the inner loop, and by having this line, we are now here. After this line, it goes to the next line, and then we have the outer loop. So the outer loop is still I, which is 4. Now we increase the value of I from 4 to 5, which is the last time, because I also must be lower than or equal to 5. So this is the last round that we enter. So we enter with I value 5, I equals 5, while j equals 1. And it starts from the j equals 1 again. So j has to be lower than or equal to I, means that j has to be lower than or equal to 5. So it enters with j equals 1. So it prints 1 one time, and then increase the value of j, come back here, it prints the value 2, 3, 4, and finally 5, and it cannot go beyond 5, because when j is 5, it is reaching its maximum level, which is 5, and then it goes to the next line. So from there we go to the next line, but we do not go back to the outer loop anymore, because also when the value of I is 5, we increase it to 6. It does not pass this condition, so it cannot enter the loop again. So this is how this nested loop would work. So let's run one more time. Yes, so you see how this nested loop has worked, and how we got to the printed form and pattern of the numbers that we were looking for here. It is very important to start practicing these things yourself, because it's little by little it is getting a bit more complex. So in order to make sure that you are improving your coding skills as you're proceeding through the course, please try these practices yourself several times. This is very important. Thank you for watching. Hello everyone, welcome back to another lesson. In today's lesson, we are going to do another coding exercises using nested loops. However, before we dive in, if you haven't had the chance to rate this course yet, I kindly encourage you to take a moment to do so. So your feedback is incredibly valuable in helping us improve and ensure the future learners have the best possible experience. So thank you for sharing your thoughts and rating this course. So now let's move on to our next coding exercise. Here we would like to write a program that prints a 4 times 6 rectangular of asterisks. So what we would like to be printed would be something like this. So we have 4 rows and we have 6 columns here. We would like to print that, and we need to use a nested loop to do so. So the outer loop would have four range, like I starts from 1 and we'll go up until 4 because we would like to have 4 rows here, and as the statement mentions. And then as we would like to have 6 columns, we are having the inner loop to range from 1 to 6. So we start from here. Let's run the code first and see how it works, and then we will start analyzing the code. Okay, so now we see that we have 4 rows and 6 columns. So let's analyze the code. So initially here I equals 1, enter the loop. So it checks to see if I equals 1 and it's lower than 4, I plus plus. So I equals 1, enter the outer loop. And when we enter the inner loop, so j is equal to 1. So I would say I equal 1, j equal 1. Then when j equals 1 in the first round, it says print 1 asterisk. So it prints 1 asterisk. Then the inner loop is finished one time and it goes back again. So it increased the value of j from 1 to 2, and it comes back here and it prints 1 asterisk for us. Then j was 2. Now we increase the value of j by another value, and j becomes a 3. Then 1 asterisk is also printed here. It continues until j equals 6, and we print another asterisk here. So it would be like 6 asterisks would be printed, because when j equals 1, it prints 1, then it's 2, another asterisk, then j is 3, another asterisk, then j is 4, 5, and 6, another asterisk. So the range of the j will, depending on the range of the j, we are going to print asterisks here. So we have the value of from 1, j equals to 1, and j lower than or equals to 6. So 1, 2, 3, 4, 5, 6, we are going to have 6 asterisks being printed, because this is how the range tells us. So when j reaches its upper bound, the inner loop is finished. When the inner loop is finished, we finish this column. We have the endl syntax here. So like it's like here, we printed 6 asterisks. Now we are here, we have one endl, which will force the program to go to the next line here. So when we go to the next line, we go back to the outer loop where I was 1 initially. Now we increase the value of I by 1, and I becomes 2. I equals 2, and j starts from 1 to 6. And because of that, we will have another 6 asterisks being printed, because when j equals 1, it enters the loop, print 1 asterisk. Then j is increased to the value of 2. Then another asterisk is printed here until j reaches its maximum level. So then when j reaches 6 again, we finish the inner loop, and we go to the next line. We are here. When the second inner loop is finished, we go until here because of end L, and we have the outer loop. So in the outer loop, I now equals to 3, and the same logic goes for I equals 4. So basically, if you would like to have like 4 rows, we have the upper bound, we have the range of I from 1 to 4. And if we would like to have 6 columns, we need to have the J or the inner loop has to be from 1 to 6. If we would like to have 8 columns, we can simply say J starts from 1 and it's going to be lower than or equal 8, for example. So this way we are going to have 8 columns here. So let's try and see how it works. Let's see. Yeah. So here, as you see, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 columns here now because we mentioned we would like it to go up until 8. And if we would like to have, for example, only 2 rows, we can change the range of I and say it starts from 1 and it's going to go up until 2. So let's compile again. So yeah, here we see that now we are having only 2 columns. So depending on what we would like to have as columns and as number of columns and rows, we can change these numbers. And also now we are printing asterisks. So we can print whatever we want. For example, we can print addition. So let's try this one. We can print additions, or we can simply print we can simply print I times j, or whatever that we want. So it depends on what we would like to print. So now it's going to give us the value of I times j every time. So there is a, oh, sorry, I need to put this sign here. I forgot. Okay. So when we compile now, okay. So here we see that it is printing the values of I times j. Like for example, I equals 1 and j equals 1, so it prints 1. Then I is still 1, but j is now 2 because the value of j is increasing from 1 to 8 now. So then 2 times 1, here we have it, then 3 times 1 we have it, then 4 times 1, etc. Then we finish the inner loop, the first inner loop, and we go for the second loop. So we go for the incremented value of the I, which is the second iteration of the outer loop. So I equals 2, now we have I equals 2, and when I equals 2, j equals 1, we have 2. When I equals 2, j equals 2, we have 4. When I equals 2, j equals 3, we have 6, etc. until we reach the I equals 2, j equals 8, which the result will be 16. So if we would like to have like now 4 columns, we can also try this like that. So here, if you would like to have like 4 columns, we see that the 4 columns is shown like, sorry, 4 rows. So 4 rows are added. So I equals 4 here, j equals 1, so the result would be 4 until it gets here to the last number where it is you see the last row means that the last iteration of the outer loop, so I would be equal to 4. and it is the last column. So columns are not very organized, but this is the last column. So it means that the j also equals its largest value, which is 8. So 8 times 4 would be 32. So in order to have a matrix, for example, of numbers, we know that we can use nested loops, and also the number of rows depend on the outer loop, and the number of columns depends on the inner loop. Hello everyone, welcome back to another coding exercise session. Today we are going to write a program that prints a grid of numbers where each row contains the numbers from 1 to 4. So we are going to have 3 rows, and each row needs to have numbers from 1 to 4. From the previous lesson, we learned that if we are going to print a matrix, we need to use nested loops. And the outer loop can show us the number of rows, can bring us, depends on the number of rows, and the inner loop depends on the number of columns. So with that in mind, if we would like to print something like this, we have 3 rows, so the outer loop should start from 1 to 3, and the inner loop should start from 1 to 4, because we would like to have four uh, only 4 columns. So let's run the program first. Okay, we see that what is printed here, it's exactly what we wanted. So let's analyze the code and see how it works. So in order to see how it works, we see that I is equal in the first round, I equals 1, while j varies between 1, 2, 3, and 4. So when I equals 1, it enters the outer loop and it reaches to the inner loop. So j equals 1, it enters the loop, so it prints 1. Then it goes up, we increase the value of j, and j is 2 now, so it prints 2, and also we are printing one space here. So j goes back up again, it is increased by another value, so j is 3 now, so j is printed here, now 3 is printed, and then one space here. So we see that the result would be something like this. Exactly, the first row is created. When j reaches its maximum level, which is 4, the inner loop is finished, and we are going to the next line using end L. So we are here. When we have the end L, it goes here. So now I equals 2. So now I equals 2, while still j varies between 1 to 4. And again, the same procedure will continue. So j equals 1 enters, it prints j and 1 space. Then j is increased here by 1 value, it enters, it prints j with 1 space. Then we increase the value of j another time. Now j is 3, so we print j here, which is 3 with 1 space. And another time j is 4 now. This is its maximum level upper bound. And we increase the value of j from 3 to 4 by 1 value, and we print j, and the inner loop is again finished, and we have endl. So we're here. After endl, we go to the next line, and then we increase the value of I to 3. Again, the same thing will happen. So if we would like to have 3 rows, we are ranging I from 1 to 3, and if we would like to have 4 columns, we are ranging j from 1 to 4. However, if we would like to have like more columns with more numbers, like if we would like to have something like this, we can simply increase the range from 4 to 5 and see its impact. Let's see. Okay, so we see that now we are having 3 rows and 5 columns. So depending on the number of rows and columns that we would like to have in the output, we are going to modify the outer loop range and the inner loop range. Thanks for watching. Don't forget to practice all of these exercises several times so you get used to coding nested loops. Hello everyone, welcome back. Today we are going to talk about functions. So in this lesson, we're going to talk about functions. So a function is like a mini program within your main program. So it is a reusable block of code that performs a specific task. Instead of writing the same code repeatedly, we can put that code in a function and just call it whenever we need it. So we write the function once, and we can use it multiple times. So it saves the time and effort. So if you have a program that calculates, for example, the sum of two numbers in multiple places of your code, using a function avoids writing the same code again and again. So the program will become easier to understand and to maintain, of course. And functions break down, the complexity tasks, the complex tasks into smaller, manageable pieces. So, for example, here, if you remember previously, we were talking about like printing one thing here, like saying uh, the sum is, and then the number and L. So let me just initialize two numbers saying that int a equals 10 and int b equals 12, for example. And we are saying that the sum is a plus b, okay? So using these three lines, we can have the sum of a and b. However, just imagine that we have like 1000 lines and this code continues like for many times, and we have different blocks of codes here. Just imagine here we have a lot of codes and different tasks to be performed, and at some point again we would like to add two other numbers, like we would like to write down int c equals, for example, 15, and int d equals 20, for example. And then we see out the sum of c and d is c plus d and l. So you see, we are repeating this calculation again, and we had it one time here, and then we are repeating it here, and we may need to repeat it several times. So instead of writing these many codes repeatedly, we can simply just define a function to do the job for us. In order to define a function, we need to first declare it a priori to our main function. So this is our main function. So any C++ program will have a main function. Everything is within that main function. So before this main function, we can declare our additional functions that we would like to have. For example, here we declare a function called add, and it has two values as input values, int a and int b. So within the parentheses, it shows how many input it can take and what are the types of the input that it can take. So the first type is int a, so the first type is int and the second type is int. So the input of the function called add are two integers, and here this int shows the output of this function. So basically we learned 3 points here. So this is the name of the function, and within the parentheses, we learn how many inputs the function has and what are the types of the inputs. In this case, they are both integers. It could be one integer, one float, it could be anything. And the third point that we learned here is that the output of this function, the resulting of this function would be also an integer. So we declare the function right here. So we are just saying the name, the output, and the inputs, and a semicolon, okay? Then when we come here in the main function, we call the function like this. So if we call the function, now within this int main function, we can call add. Why? Because initially, a priori to this main function, we have defined the function, okay? So we must define it before the int main. So when we call it within the int main, so it recognizes it and it does not return an error. However, this function is just declared here. In order to know what this function do, now I close the int main function. We go through the details of the function here. So basically, it would be something like this. We declare the function, we use the function. However, after the int main function is finished, we write down the details of the functionality of that function. So in order to do that, to see what this function is doing, we come to the end of the code. We exactly write what we wrote already for its declaration. Instead, we don't have a semicolon in the end, and we have two brackets within which we define the function. So every function has inputs and outputs. Here, in our case, we have two inputs that are integers. And the output would be the value of a plus b. So this could be a plus b, or it could be like c plus d, whatever the input of the function is, it can add it. So basically we are saying if the input is a and b, so you return those gathered inputs. So this will return the value of this function. So we write down return and we do the addition here. So this is how this function would work, and we go up to the main function. So I summarize it one more time before I go into more details. We declare the function before the int main function. We define the function after the int main function and say what it is going to do. And it must have one return value. So it usually has either a return value or it's a void function. So void function, we will talk about it in a few seconds or in a few minutes. But in this case, because it's not a void, if it was void here, instead of int, we had void. So it's not a void function. It's a normal function that returns an integer value. To return this integer value, we write down return and we do whatever we want to do here. So and then we want to use this function in the main function, in the main block of code. So we define one int result and its value is this. So this is how we call the function. If you remember, the function name was add. So it's going to call the function named add with two values, 5 and 3. And when it is going to call this function with 5 and 3, it's like saying that, okay, one input is 5, the other input is 3. So it's going to add 5 to 3 and it is returning its result, which is 8. So 8 is returned and assigned to the result. And now we are printing the value of result. Let me just compile it once. Okay, so now we see that the sum is 8. As we discussed, here we call the function with two inputs. So if we are saying the inputs are integer, they must be integer here as well. It's not like that we can declare them as integer and we can put like 5.2 and 3. It returns error. So they must be integer. So then 5 and 2 are called using add function, and 5 plus 2 plus 3, sorry, it will be 8, and 8 will be returned here as the number assigned to the result. So instead of, for example, adding the different integers and different parameters throughout the code again and again and again, so we don't need to write it anymore. We just, whenever we want to use it, we just call the function. So let me just do another thing. I would say int result 2 equals add, like we can say 10 and 2, for example. It's not possible to write 10 and 2.2. There will be a problem if we run the program. So, and then I see out the second sum is, and I print the value result 2 and del. So let me just compile this. Yeah. So here we see we didn't have to do the calculation anymore. We just call the function once more with new values. So you can call the function millions of times, and with new values you can do the calculation. However, the function is written only one time. So it is more efficient to have functions that do the job for you, so you don't have to call them one by one. So this is very important to keep in mind to use the functions. And another thing that we could do here is like the following. So as you see here, we are printing the sum is in the main block. In order to be super efficient, we can also mention that in this function we define a new integer called c that is equal to a plus b, and then we see out the sum is, and we print c every time. So here what we can do is like this. So let me just clear this part, and this and this. Let me see if I have errors or not. Okay, great. So you see, even now the code is even more clear. So here we are only saying add 5 and 3, add 10 and 2. So this is going to add any two numbers that are called using the add name, because the name of our function is like this. And this function now, it is actually not returning anything. So we can change the function to void. So what is void? Void, we change the function output, we put it void, and we forget about this. Let me just first run to see. Okay, great. So here, previously, we were doing the calculation directly. We were saying return a plus b. However, then we decided, and then the return value was being assigned to the result here. However, then we decided to not to assign these function values to any integer, and we do all the calculation in the function, so the code, the main block will be more clear. Therefore, we do the calculation here and we print everything here. So we are not printing anything here. So a void function is a function that is going to return no value. It's only doing some calculation. So now I change the integer output to a void value, to a void function, because it's not returning any value. It is simply just doing some calculation and printing something. If it is going to return something, it has to have some output data type like integer, float, double, etc. However, if it's not specifically returning something like this, like a plus b, for example, if it does not have something like this, it's a void function that is doing some calculation for us. So this was a brief introduction of the functions. In next lectures, we are going to do some coding exercises. Thanks for watching. Hello everyone, welcome back. Today we are going to do some coding exercises. So we would like to write a program that writes a function that greets everyone who is running the program. To do that, we could simply write down cout and write the message that we would like to have, like welcome here, and del. However, in the main function that we have in C++, we don't want to write anything like that, and we would like to only have codes that are calling the functions and tasks are done in the functions. Therefore, the code is more clean, more readable, and more understanding. So to do that, we define one void function here. So the name of the function is greet. It has no input. So let's see how it works. Before starting the int main, we learned that before that we need to declare the function, and we have the option of defining the function either after the int main or even before the int main. So in this case, I am declaring and defining a function, both of them, both tasks before the int main. So I will learn three things about functions. So this will be, the name is just something that is behind the parenthesis, just before the parenthesis. So the name is greet. Whatever that is in the parentheses is the input of the function, and whatever is just before the name is the output. So as the input, it has no input, so we don't need to put any input when we want to call it. So it's not like add function like addition, so we give two numbers, so it will do some mathematical operations with those inputs. It's just a simple greeting function, so it needs no input. Whenever we call it like this, it's going to be performed, and the output is void. Why? Because it is returning no value. So as you can see here, we are not writing return something here. Okay, as we are not writing that, this function is a void function. Whenever a function is returning a certain output, it is not a void function. But here we are doing nothing. So let's compile. Okay, now we see that the function is working very well. So instead of writing cout welcome to C++ and do some additions, do other things in the main part, we're just calling the function greet. So the code is very clean, very clean.
and everything is done behind the scene. So this makes you to have a very good understanding of how the code works chronologically. So when you have, for example, 10 functions, from the beginning, you start, for example, greet, you go and read the function greet, and you come back here. Okay, the first step was greet. And then the second function is here, third, fourth, etc. So whenever you want to see the details of each function, you go and read that function. And in the main menu, in the main function, everything is clear and only the functions are there. And all the details, all the works, all of the coding details, and all of the works are within each function, uh, making the code to be more understanding and clear for the reader to see, okay, there are 10 functions here. If I want to read about the greet function, I click on the greet. So I can simply and easily navigate the greet function. Otherwise, I have to, look for every line to see where we are greeting when we are greeting the customers, for example, etc. So this is another example for greeting. In the next session, we are going to do some more coding exercises. Hello everyone, welcome back. In today's video, we are going to do another coding exercises. So we would like to write a function that does the multiplication of two double numbers. Previously, we learned how to multiply two numbers. However, using a function can help us to have a more efficient code. So we don't have to repeat a certain block of code repeatedly throughout our main function in order to perform a specific task for us. Using a function, we can define the function once and use it several times in the code, so it is more efficient. To do that, we learned before the int main function, if we want to have another function, there are two tasks that we need to take care of. So the first one is that we must declare the function before the int main function. So here we are declaring it. And also we need to define the function. But for definition of the function, we have the choice. Either we can define the function before the int main function, or we can do it afterwards. It's up to you. So in other exercises, I showed how we can only declare it above and define it in the after the int main function and use it in the main function. However, here I'm declaring and defining before the main function. And there are three things, if you remember, about a function that we understand from this line. So the first thing is its name, that is multiply. The second thing is within the parentheses, we learn how many input parameters it has and what are their data types. So here we learn there are two parameters as the input that this function requires to run, and the data types are double, and both of the inputs are double. Finally, the third thing about the function, we learn the output of the function. So the output of this function would be a double as well. So this is its declaration, and within the bracket, we will have the definition of the function. So this function is going to return x times y. So these two inputs are being multiplied using this function. And we have the return. Why? Because the output is double. So if anything but void is the type of the output of the function, there should be a return here. But if the function is a void function, there must not be a return here. So having said that, let's come back here in the int main function. So we would like to call the function in our main function. So I declare a double called result, and I assign the value of it by calling the function. I call the multiply function, and within the parentheses, we learned that this function requires two inputs that are doubled. So these two double number are also considered as the input of this function, and the output of this function is going to be assigned to result. Finally, we are going to print the result to see the output. Let's run the program once. So we see the product is 9. So this function, the analyze of code, would be something like this. Here we are calling the function with these two values. When we call them, the program goes up here and it says, okay, multiply 4.5 and 2. And let's return the value of 4.5 times 2. So it returns the value, and the returned value is assigned to result. So this is how a function would work. So one exercise for you could be how to change this double function, the output of this function is double, to a void function. I would suggest pause the video now and think about it. And if you have already thought about it, now you may continue. In order to do that, we just replace double with void, and we forget about the return. We say int z equals, for example, y. And we simply just see out the value z here. Okay? Doing that, we don't even need this, and we don't even need this. So the code is even more efficient here. So it depends on what you want to do. But you see the code is very clear now. And let's see. Okay, so now everything works and the function uh, has changed to a void function. So more blocks are here. So we added one line and we changed the code in this line. However, our int main function is very clean. So if we want to do multiplication several times, like here, sorry, like here, and then here, we change the value, for example, 7, 9, 10, something like this. And we say the output of multiply function is. Okay. So instead of doing the calculation 4 times, I'm only calling the function 4 times. Let's see. Okay. So here we see that it is printing the output for us. So now every time that we call the multiply, it gets these two values in the parentheses, and then do the multiplication here and print it. So the first time when it's 4.5 and 2, it says, okay, 4.5 times 2, it will be assigned to z, which is 9, and then we print the 9. So this code is done. This line is executed. Then we have 7.5 and 5. It goes back up again. It says, okay, 7.5 times 5 will be assigned to z, which will be 37, and we're printing the 37. And it continues until the end. So you see how efficient it would be to write only a function that does the job for us instead of just repeating all of these blocks of codes again and again. So please don't forget to do the exercises yourself to get used to the syntaxes of how a function should be written and how a function would work. Hello everyone, welcome back. After discussing the definition and the declaration and the details of a function that we need to keep that in mind, the next topic that we're going to talk in today's session is about local and global variables. So a local variable is a variable defined inside a function or a block and is only accessible within that function or block. So once the function or block is done executing, the variable is destroyed and its value is no longer available. This is a definition of a local variable. And when we are talking about a global variable, we define it like it is defined like outside of all functions, usually at the top of the program, and can be assessed and modified by any function in the program. So it's important to differentiate these two concepts. In order to explain this, we brought you an example here. Let's recall how a function works and then we dive into this example. So we need to define a function, we need to declare a function before the main function that we know from before. In parentheses are the input of the function. In this case, it's empty, so there is no input. And before the name of the function, we have the output of the function. So the output of this function is void, so it's not going to return anything. These we already know from previous lessons. So then after declaration, we need to define the function. We have two options for this. Either it can be defined where it is declared like before the int main function, or it can be defined after the int main function. So we had the examples of both situations in previous lessons. So here I'm going to declare it before the int main function, and I'm going to define it also there before the int main function. So what it's going to do is that in the int main, so the program, when we run the program, only the int main function is going to be executed. And if I'm calling a function within the int main function, that function that is called is going to be executed. For example, if I simply remove this line, nothing is going to be executed because we didn't call the function so it can be executed. So it's an important thing to know. Because the function is declared and defined here, it doesn't mean that it's going to be executed. If you want it to be executed, you need to call it in the main function. Otherwise, it wouldn't just work. Let's try. We will see. You see, nothing is being executed because we are not calling anything. So it's important to call whatever function you're just trying to use, call it after declaration and definition. So we are just calling here the display function. And when we execute the code, it's going to come here. And then within that function, in that parenthesis, in that bracket, we have the definition of the function. So in the definition of the function, we are initializing one integer value called local num, and it is equal to 10. And then we are printing this value local num. Okay, so this local num is a local variable. Let me just change the name, maybe it would be confusing. I would say int x, for example. Okay, it's going to, so the number is, okay, so this x variable that is an integer is a local variable to this function. Okay, why? Because it is declared and initialized in this function. So it makes sense that it's not accessible from here. Why? Because it is not initialized and declared here. So what the program would see if we want to use something in the int main function, what it would see is the only thing that are here. And since it is not here, this integer value is not defined in here, it is a local variable for this function. We can have another, let me just add another function here. So I would say num2, and I define y and it is equal to 20, and it is okay. Now we have one main function, and then we have one void function and another void function. So we can have like tens of hundreds of functions, so it doesn't matter. So this integer that is called y and it is initialized and set to 20 is a local variable to this function, and this y is not accessible neither in this function nor in the main function, so it's a local variable. So it makes sense. And also for this x is neither accessible in here nor here. So let me just run. Here in the int main, we are calling the display number. So display number is this function. We are assigning 10 to integer x, and then we are printing it. So it is printing x. However, if we are trying to like print x directly here, it is expected to have some errors. You see, even we cannot even run it. We have error here. So why? Because it says use of undeclared identifier. It makes sense because x is defined here, so it's a local variable for this function and not for the main function. So this is the concept of local variable. In the next video, I'm going to talk about the global variables. Hello everyone, welcome back. In this session, we're going to talk about global variables. Previously, we talked about local variables and we mentioned that local variables are defined within each function and only are accessible in that specific function. So if we have function number 1 and we define integer x, it is only accessible in function number 1 and not in function number 2 or int main function. So here we are going to discuss global variables. I have one int main variable here and one function here and a global variable here. So the global variable here, as you see, it is in none of the functions. So this is why it is variable. So this is the first function. This is the second function. So, and this variable is defined globally because it is not inside any specific function. Therefore, it can be used in any function. So, because it can be used in any function, in int main function, I'm going to print its value, its initial value. Okay. So let me just run this code. So as you know, whatever that is inside the int main function is going to be executed, nothing else. So if we are not going to call this function right now because we commented it, it's not going to call this function. This function is this function is only going to be working if I call it in the int main function. So let's compile and see how the program would work only with this one line. Okay, so here we see that it says global number initially 100. So it says global number initially, this is the message we type, and then we print the value of global num. So the global num equals 100. It is printing it easily and it is accessible because it's a global number. So then we have the option of modifying that global number. So in order to do some modification and mathematical operations in this global number, we define a void function here. So a void function is defined before the int main. The input is empty and it is void, so it returns nothing. So basically in this function, when we call this function, we are going to add 50 value to its original value. So if you remember, when we have global num plus equal a number, it means that we are having like global num plus 50. Okay, so whatever the value of global num is, it is added with 50, and then its summation is going to be assigned to the global num. So in this case it is 100 and it is 50, so the new value is 50. But for the sake of efficiency, we simply write it like that. So it's the same thing. So get used to also using equations like this. So we call this function here. This function is going to add 50 value to the original value of global num, and then it's going to print global num inside function, saying that global num, and then it is going to print this value. And here we have like global number after modification, and it is going to call this number again. So we are going to have three prints. Why? Firstly, in the int main function, I'm going to call global number initially, and this number is this number which is global, so it is accessible here. And then I'm going to call this function. This function is going to add 50 values to the original value of global num, which was originally 100. So therefore it is now 150. And it's going to also print the global number inside function message and also print the new value of global number. So previously it was 100. Now we modified this number and it is 150. So because it's a global number and it is now 150, we are printing it again, global number after modification. So we expect to see 150 here as well. So this is a global number done once in the int main, done once in this function, and also called again and used again in the int main. It is a very good example showing that how one global number is accessible from anywhere in the code. So let's compile and see how it works, and then we analyze the code. Okay, so let's analyze. So we have the global num here 100. When we call it initially in the main function, it says global num 100. So it is printing its value here. Then we are calling this function using this call. It is going to add 50 values to the global num, and it is going to print its new value as to be 150. Then when the work with this function is finished, the code is going to come back here and goes to the new line. So now it's going to print cout global number after modification, and it's going to print global num. And it's going to give us the 150. So we see that we can access the global number from anywhere. So let me just add something here. If we have another void function, modify to, for example, I would say, and then we are saying global num minus equal 100, and then we are going to cout the global num inside the second modified function is then we have the global num handle. Okay. So, and then I'm going to also call this new function tool. Sorry, the name is not correct. So whenever we are calling the function, even if even if it doesn't have any input, it's important to have the brackets, to have the parentheses. Sorry. So with this new defined function, uh, we are going to subtract 100 values from the global number. So we had like 100 here, then we called this, and then it adds 50 values. So here it is 150. Then this function is done, where the program goes back to the main function and it is going to print 150. And then we are calling this second function. So the second function is going to reduce 100 value from the global num. So let's execute the code. Okay. So on top of what happened so far, we said that 100, 150, and 150 again. But here I modified the global number once more. So once more, I call a new function that is going to subtract 100 value from the last modified value for the global number. So it is going to simply do the modification like 150 minus 100, it will be 50, and it's going to show the result for us. So this is one thing. So this is what we need to know about the local and global variables. But another point to show the efficiency of functions is that here you see we are having two functions being called, and these are the things that I added simply because I wanted to have a better explanation of the code. These two lines can be also removed, but here and here we are just calling the functions and all the work is being done here. So if someone wants to read our code, it would be very easy for the reader to understand what we're doing here. So this is why we say we need to use functions to make the int main function as clear as possible. Thank you for watching. If you haven't had the chance to rate the course so far, please go ahead and do so. And also don't forget to give us your feedback. It would be valuable for us to improve the courses for future students. Thank you. Hello everyone, welcome back. Today we are going to talk about global and local variables. So now I'm giving you another example to distinguish these two variables, global and local, and also I'm going to talk about a scope resolution in this video. So before we dive into local and global variable, I'm going to give you another overview of what we have learned so far, and then I'm going to talk about global and local variable. I think we need to have a wrap up before we jump into more details of global and local variable. So far we learned that a function is like a mini program within our main program. So it is a usable block of code that performs a specific task. Instead of writing the same code repeatedly, we can put that code in a function and just call the function whenever we want. So this is what we learned about a function. And there are two things when we have the functions. There are two things that we need to consider. And those two things are the local variables and the global variables. However, before we jump into that, we have the declaration of the functions. So here, for example, we have the declaration of this function, and it has empty in the parentheses, meaning that it has no input, and the output, there is no output because it's a void function. So it is going to perform some tasks, some probably mathematical operations, etc., but it's not going to return anything for us. So given these introductions, we are going to now talk about how a global and a local variable are they're going to work for us, and how they're going to help us to get what we want to do done. So let's walk through this code together. So here I have the int main function, and I have certain block of code here, and I have one function declared and defined here, and we have the global variable defined here as global num, that is 20. So here it's a global variable, and since it is outside of any function, it can be used and modified by any function in the program. So this is why we are calling it global, and its initial value is 20. So it is initially defined to be 20. Then we have the void function that is going to do some tasks for us. So let's see what this function is going to do for us. So here we are declaring another integer variable with the same name as the name of our global variable. However, this is because it is redefined in this function, it is considered to be a local variable, although it has the same name. So it is a local variable, and its value is set to be 10. Here, in order to distinguish these two, this function is going to print two values for us. Firstly, it's going to print the local value, the local variable that is a global num. So we are going to see the local value of this variable, and then we are going to see the global value of this global num. And to do that, we are distinguishing using these two lines, and then we are writing global num using scope resolution. So scope resolution means that if I only say global num, just like here, what the program will access is that, okay, you are using this local one. So you're calling this local one. However, so this is why we are just simply using printing global num, which means that this local variable will be printed. However, because the local variable has the same name as the global variable, if we want to access and print this one, we need to use scope resolution. And scope resolution simply means that we have colon and then global num. Then it means that the program will realize that you are planning to use this number and not this number. To say it concisely, if you just write down global num, it's going to print this local variable. If you're using scope resolution, meaning that colon global num, the program will realize you would like to print the global num and not this local one. Okay? So let's now run the program and see how it works. So firstly, we are couting global num. So here we are simply printing this value, and we don't need a scope resolution. Why? Because we don't have any variable or any integer that is defined with the same name as the global num. Let me just run the code first, and then we are going to analyze the code once more. Okay, so here I'm saying that we have one function, one main function, and one function here, and one global variable. So initial value of the global variable is 20. Now in the int main, I'm going to print the value of our global variable here. So it is printing 20 because its initial value is 20 here. Okay. Then I'm calling the demo scope function. When I'm calling the demo scope function, the program is going to come here. It starts reading from here. Okay, the program will realize we are defining a new integer locally with the name, with the exact name of our global variable. It says, okay, it's a local variable, there is no problem. So it is equal to 10. Then we are printing the global num. So when we write down global num, it is going to print this value because it thinks that you're talking about the local global num. So it is going to print number 10. Then I would like to also print this global num, which is the global variable. To do that, I need to use a scope resolution. Scope resolution means that we have colon global num. This way, the program will realize I'm talking about this variable and not this one. Okay? To summarize, if we are having a function and within that function, we are declaring a new variable that has the same name as a global variable. When we are going to print that number, that variable, the local variable, we simply print it in that function. But if we want to access the global variable with the same name, we need to use the scope resolution. However, you may say, okay, why don't we use the scope resolution here in the int main function? The reason is that in the int main function, we didn't declare any variable with the same name of this global variable. Okay, so this is how the local and global variables are working, but I understand that in the beginning it may not be really easy to follow, but after a bit of exercise you're going to get the point. So it's very simple and very straightforward. Just think of it like this: we have a global variable here, it is accessible from anywhere. So if let me just write another function like void demo2, and I'm just here saying that hi from demo2, and we are printing the global variable, and then I'm saying global num. Okay, then I'm saying endl, and here I am just calling demo2. So let me just run this code. Okay, great. So this is what we wanted. Here, let's summarize. I'm having a main function. It is printing my variable here. Let me just rename it for the sake of easiness. I would say, for example, I would say like HE. Okay, this HE is going to change here and here and here and here and also here. Okay, let me just run the code to make sure that it works. Okay, it's the same thing now. Okay, so it would be easier to have this thing. So I have one main function. To summarize, I have one main function, two other functions, and one global variable. So this global variable is accessible everywhere in this code because it's global. So here I'm going to print the value of our global variable, which is HE. So HE is 20. Here we simply print it, okay? Uh, then I'm calling the demo scope function. When I'm calling the demo scope function, I'm initializing another variable which is local, and it is this variable, this he is not accessible here or here because it's a local variable for this function only. Okay, but it happens to have the same name as our global variable. Because it has the same name, we need to distinguish them in that function for the compiler when we are using the variables. So in order to distinguish for the compiler, exceptionally in this function that has the same as a variable with the same name of the global variable, when we are just calling the name of that variable, it is going to print and execute whatever that is assigned to this local variable, because its local variable is prioritized. However, in this function, because we are having a local variable with the same name of a global variable, if we want to call and print this global variable, we must use scope resolution. So this way we are telling the compiler, okay, I know that I have a local variable with the same name, but I'm using a scope resolution for you to know that I mean, for this line, I mean the global variable and not this local variable. If you want to access the local variable, you simply just use he. Okay? Then this program is executed. So it is printing the local variable, which is 10, using this line number 8. Yeah, line number 8 is going to execute this, and then it is going to execute this line number 9, which is going to print this line for us, which is the value of the global variable. Then it's finished. So we come back to the int main function and we have the demo2. So it is going to call demo2 now. The demo2 is couting, it's printing the global variable. So it says hi from demo2 and we are printing the global variable. So the value is 20. Okay, it is printing he. Okay, so how straightforward is that? Is this. So to summarize, it is very straightforward. When we are having a local variable with the same name as the global variable, when you want to access the global variable, you must use scope resolution, means colon. However, if you don't have a local variable with the same name as the global variable, you can simply call the global variable by its name, like here and here. Okay? Thank you for watching. Don't forget to do the coding and do the exercises yourself so you can be more efficient and you can, get used to these syntaxes and these little details. Thank you. Hello everyone, welcome back. Today we're going to do some coding exercises regarding the local and global variables. We would like to write a program that declares a global variable to store a counter. So the program should have two functions. One increment counter, and this function should increment the counter by 1. And we have the main function, of course, which calls the increment counter function twice and displays the updated counter value each time. So now we know that we need to have a global variable. We need to declare a global variable. Then we need to have one function here and one function here. And so the main function is going to call the other function twice, and the other function needs to increment the counter or the global function by one value. So to do that, we start by declaring the global function. We know that from before, the global function, the global variable should be declared above the code and outside of any function. So this is the global function xy, we name it and we initialize it to be 0. Then here we have the main function, and here is the increment counter function. In order to have a review, we know that a function has three associated data with it. So when we are declaring it, so now here it's the name of the function. Before the name is either void or the output of the function. So here, if it was instead of void, we had integer. We knew that the function should give us an integer value in the end, and so it returns one integer value. But because this function is returning nothing, we have the void function. And also within the parentheses, we will have the input variables of the function. So in this case, we have no input function, so we can just call the function without giving any input to it. So, and this is how we declare and define a function. And we know that we must declare the function a priori to the main function. However, for definition of a function in this part, we can do it either before the main function or after the main function. So it's up to you. Here, I'm declaring and defining at the same place before the main function. And here, what it's going to do is that it's going to get this xy and increment its current value by 1. So, and we learned that plus equal something means something like this. So instead of plus equal, we could write xy plus 1. So this equation here is exactly like this equation. So it says that whatever the value of x is, or xy is already, add 1 to it and assign it to xy again. So here xy is initially 0, and when we increment it by one value, we add one value to it, its final value will be 1. And then if we do it another time, its value will be 2, etc. And here we are having the main function. In the main function, we firstly learned whatever that is in the main function is going to be executed. So if we have a function here and it is declared and defined, but it is not called in the main function, it is not going to be executed. So here we are firstly printing the initial counter xy. So we expect to see value 0 in the output because initially the global variable number is 0. Then we call the increment counter as it was asked here 2 times. So we mention increment counter and increment counter. So in the first round, let me just type it like this. In the first round, it will be something like this. Xy equals xy plus 1. So for the first call, it will be like xy equals 0 plus 1 because its initial value will be 0 and we are incrementing it by one value. So the final value would be 1. For the second call, xy equals 1 plus 1, which will be 2. Why? Because initially it was 0. Then in the first call, we increase its value by 1, so it's 1 now. So when we are calling it one more time, its value is now 1 based on this equation, plus another 1 that we are adding here. So the final value will be 2. So we expect that now when this function is called for the first time, it is going to print the xy value, new xy value to be equal to 1. And when we call it for the second time, it's going to call this function again and add another one value to the already existing value of the xy, which will be 2. So let me compile. Okay, great. So here we see that the initial counter is 0. Here we're printing the initial counter to be 0 because xy is a global variable and it is initially set to be 0. Then we are calling the function one time. We are calling the function. So we are adding one value to already existing value of xy, which is 0. So it will be 1. And we say counter after increment xy. So it will print 1. And then this block of code is executed and the program will go back here to execute the next line, which is increment counter for the second time. It comes back here. It is going to add another one value to the already existing value of xy, which is 1. So 1 plus 1 will be 2. So it is going to print 2. So this is how using global function will help us to access it through any function in the program. Thank you for watching and don't forget to practice it by yourself. Hello everyone and welcome back. In today's video, we are going to do another coding exercises with respect to the local and global variable in the function setting. So we would like to write a program that uses a local variable for us to store the values entered by the user. So the program should ask the user to input two numbers inside a function called add numbers. So far we know that we need to define a local variable. We need to have a function called add numbers, and that add numbers is going to read two input variables from the user, and then calculate the sum of the two numbers in the add number function and display the result. Ensure the variables used in add number function are not accessible outside the function. So this is exactly highlighting the definition of the local variable. So to do that, we have two functions: a main function, which is going to call our function here, our other function, and a void function that is called add number. So previously we learned how to ask a user to enter a number, how to store the number that is entered by the user, and how to do the mathematical operations. However, we are using a function to do that for us, to make the code cleaner. So here the int main function is very clean. We're just calling the function and nothing more. So these dirty parts are done before the main function. So now here we are applying the same concept that we learned before, like doing the mathematical operations and reading and storing the data from the user in a function. So using a local variables. So here, in order to do that, we have add number function, which is void. So it's not going to return any value and there is no input for it because everything is going to be stored here. Instead, we could add some lines in the int main function and ask the user to give us the input value, like two numbers, and those two numbers could be input value for the add number function. For example, let me make it more clear. So we could have int a equals 10, int b equals 14, and then have a function like add numbers or whatever that was going to have a and b as the input variables. But here we are seeing error because this function is defined in a way that it has no argument as the input. Therefore, adding a and b here will cause some errors here for us. So that would have been another option, to read and store the numbers in the int main function. But this could increase the complexity of coding in the input main function, in the int main function, and also make it a little bit, unclear. Instead of that, we are doing everything in add number. So here we are declaring two variables like x and y, and because they are defined in add numbers, they are inaccessible in any other function, so they are local variables. And we are asking the user enter the first number, we are storing it, then we are saying that okay, enter the second number, and then we are storing it here. Then we are having another integer here that is called sum, and we are assigning the x plus y into that sum integer value, and then we are counting, we are printing the output saying that the sum of x and y is the sum here, which will be the value of the x and y. So let's see how it works first. So it says that enter the first number, I would say 10. Enter the second number, I would say 25. So it says that the sum of 10 and 25 is 35. So here it is asking the first number, storing it, second number, storing it, do the calculation and printing the output. However, in order to show that this was a local variable, if I uncomment this line saying that directly please print the x value for us, it says use of undeclared identifier. Why? Because x was already defined here as a local variable, and in this function it is not accessible. If we are talking about one x here, we need to define that x here, okay? And if this x is defined here and we are printing something here, like let me just put 50 here, and let's comment this part. So this printing syntax is going to print this x and not this x, okay? So because they are local. So this is how we need to be. As you see, when I commented this part, exactly the error came back because it says that use of undeclared identifier. There is no x declared in the int main function. If we are meaning this x, it is not accessible from this main function because it is a local variable for the add number function. So we learned about how to do the mathematical operations, how to do our calculation using different functions to keep the int main function more clean, and we learned about the concept of local and global variable. Thank you for watching. Hello everyone, welcome back. Today we are going to talk about function declaration with default parameters or default values. So these functions in C++, we have a function with default value is a function where one or more of its parameters are given default values during the function declaration. This means if we call the function and do not provide the argument for those parameters, the default values are used. And if they are called with argument, those arguments are going to overwrite the default values. So let's illustrate this with an example. Here we have the main function, here is another function. Here we have the greet, it's the name of the function and it's a void function. And previously we had like int x in the parentheses, so the argument of the function was like an integer, but or input argument and input are the same, so I can use them interchangeably. So but here the argument of the function is a string which is called name here, okay? And the default value for this name is guest. So if we see this part like equals something in the parentheses in a function declaration, we realize that it's a function with default value. What does it mean? So first we go to the main function and we call the function. So when we are calling the function, you see here the argument is not given in this call. So when the argument is not given, this line, this part that is highlighted, would simply put the value guessed, would set the value guessed to the string name. So it would say, hello guest, welcome to the program. However, if we provide the argument and we call it here again, if we provide the argument, Alice would replace guest and it would say, hello
Alice, welcome to the program. Let's run the code once. Okay, great. So here we are seeing that the first time we are calling the function with no argument, and it is just simply saying, hello guest, welcome to the program. And the second time we are giving the argument to call the function, and it says, hello Alice, welcome to the program. So for the second time, Alice is replacing the word guest. So this function is very important to be used because otherwise we had to write two functions. Now we are only using one function. So if we call it with no argument, it's going to put the default guest to name, and guest is going to be printed here. But if we are calling it with certain argument, it's going to replace guest with the called argument and then print the output. Thank you for watching. Hello everyone, welcome back. Now we are going to do one coding exercises with respect to the functions with default parameters or default values. So we would like to write a program with a function that calculates the total price after a discount. So the function should take the original price, as a required parameter, and take the discount percentage as an optional parameter. So the default is 10%. So what I understand from this statement is that we need to write a function that calculates the discount. However, the discount amount by default is 10%, and there are some optional parameters that we can give, like 20, 30%, that they can calculate, the function can calculate it. So in this case, we need to have a function with a default value. Instead of having two functions, we can only write one function. So let's start from here. We start with the main function. So we print price after 10% of discount. Let's call the function calculate price. So let's go up in here to see the calculate price function. We see the name is calculate, the output is double, so it's going to return something, and it is indeed returning something. And in the parentheses, it is there are two arguments, there are two inputs. There are two arguments, one of which is price, the other one is discount. So both of them are double. However, price is a normal argument, but here the discount is a default parameter, because we are seeing that there is the equation sign here. So what it's going to do, here we are calling the function with the first argument only. So we are only sending the first argument, which is the price. We are saying that, okay, call the function for the price of 100. So 100 is set to the price here argument. Then we are going to declare a double that is called discounted price, and the discounted price equals price minus price times discount divided by 100. So it is going to give us the final price after the reduction of the discount. So it's a very straightforward formula. So what it's going to do is that, because we are calling the function only with the first argument, and since the second argument is a default parameter, so if we do not call the function with the second argument and only call it using the first argument, it's going to take 10% as the default value for the discount. So 10% is also assigned to this discount, and then the price minus, within parentheses we have price times discount divided by 100, and the final price is stored in the discounted price, and we return the discounted price here. Okay, and then we are saying that, again, see out price after 20% of discount. So let's call the same function, however with two arguments in this time.
So in this time, the price is still 100. However, because the second argument of the function is a default function, we are calling the function using two arguments, and the second argument is going to overwrite this default value of 10. So now that we are calling it with 120, it's going to replace 10 with 20. So let's run the code and see how it works, and then we are going to analyze the code once more. Okay, so here we are seeing that price after 10% discount will be $90. So if you do the math, you will realize that 10% of 100% would be $10, and the reduction would be $10, and the final price would be $90. However, in the second case, because we are calling the function with the second argument as well, this 20% is going to be set to the discount instead of 10. Now, discounted price equals 100 minus 100 times 20 divided by 100. And therefore, the output would be 80. So the overall lesson, the key lesson of this lecture was to be aware if you are working with a default function. For example, in this case, there are two arguments for this function. The first one is a normal argument, and the second one is the optional argument, a default argument, or let's say optional. So if we call the function, we must at least have one argument, because the first one is not optional. The first one is mandatory. So you cannot write something like this. So cout the price and then calculate price. So it returns error. You see, because the first argument is a must, because it's not an optional. How do we know that it's not optional? Because it does not have an equal sign. So at least if we are calling this function, we must have one argument, okay? So if we have one argument like this, let me just comment these two lines. If we are having one argument like this, it is going to put 50 as the price and 10 as the discount by default. So let's run. Okay, we see that the price is 45. Let me just print the cout so it goes to the next line. It would be nicer. So see. Okay. So here we see that the calculated price is 50. The calculated price is called by the number 50, and then 50 is for the price, and then the discount by default is 10. So the output would be 45. And if we call it with no argument, for sure there is an error. You see, it's not working because it says that this function has one must argument. So if you're calling this function, you must have at least one argument. If you want, you can have the second argument, but this is not mandatory. For in this case, I'm going to put 20. So 20 is going to be set to the discount instead of 10. Why? Because the second argument is an optional argument. How do I know that it's an optional argument? There is an equal sign here. So let's compile again. Okay, you see, with the 10%, we had the output of 45. Now with 20%, we have the output of 40. So this is an efficient way to write only one function instead of two. So by default, it's going to take the value 10, and we can change it to 5, to 2, to whatever that we want. For example, here now it's 5. And then if we are investigating one specific case, the optional argument can be changed as we are going to call it in the int main function. So please don't forget to practice these practices, these coding exercises. In the next lecture, I'm going to do further coding exercises regarding this function with default values. Hello everyone, welcome back. Today we're going to
practice some coding with respect to the functions with default values or default parameters or optional parameters. There are different names for them in the market, but whatever you are okay with, it's okay. So here now, the program wants us to write a program with a function that prints a rectangle of stars. So the function should take the width and height as parameters and also default the width to 5 and the height to 3 if not specified. So specifically, this program is hinting us saying that, okay, you can take the width and height, and also the default width and height are 5 and 3. To do that, as always, we have one int function and we have another function here to do the calculation for us. Previously, we learned if we want to do print some like stars or matrix or something like that, we can use nested loops. So here we are going to use that knowledge to apply in this function. So this function's name is draw rectangle. It's a void function. It's not returning anything. It's just doing some calculation or maybe printing something. And there are two arguments for this function. The first one is int, and the second one is also int. And since it says that the width and the height, if they're not specified, there should be set to 5 and 3. So both of these two arguments are optional arguments. So if we call this function with no value, it's going to set the default value to 5 and 3. And if we specify, it's going to use the specified number to do the tasks. So what we're going to do here is that the default rectangle, here we are going to call the function with no argument. When we call the function with no argument, since these two arguments are optional, there is no problem. So it's going to set int row to 5 and int column to 3. So we are going to use a simple nested loop. So the first loop is starting from 0 to the number of row, in this case 5. And then in the inner loop is going to start from 0 and is going to until column, in this case is 3. And for each time, it's going to print the star for us. So let's run the code and see how it works. Okay, the default rectangle here. This is the first part that we ran. So let's first discuss this part. So here we are having 5 rows and we are having 3 columns because of the range of the I and the J. So it is printing the star. And in case you don't recall why 5 rows and 3 columns, I would recommend going back and checking out the videos for nested loops. There are some exercises there that I analyze the code one by one in the rows and columns to see why what is printed is printed. So it's going to, by default, set the row equals to 5 and set the columns equal to 3 when no argument is passed for this function. And both of the arguments are optional because they have the equal sign. However, when we want to have a customized function, we can say, for example, customize it. This is just a message to print. A customized rectangle with 7 and 4 would be something like this. We call the draw rectangle, and instead we are going to put 7 and 4. So let's see. So 7 rows and 4 columns. So simply it's going to take the 7 and put it as the row and 4 as the column. And then the range for I would be from 0 to 7 and from 0 to 3 for the J. But since this is the optional parameters, both of them are optional parameters, we can also call it with only one
for example, value here. So let's call it like this. Okay, so if we call it like this, it's going to print 7 rows, however, 3 columns. Why? Because this 7 is going to replace with is going to set to row, so I from 0 to 7. But because we don't have the second argument here, we are going to the function is going to use the default value 3. So this is why it is having the 3 columns and not 4, because the default value is taken there. So it's very important to practice all of these details to make sure that you're understanding everything and you're getting used to the syntaxes. Thank you for watching. Hello everyone, welcome back. Today we are going to talk about call by value. So there are 2 ways to call a function. One of them is call by value and the other one is call by reference. In today's lecture, we're going to talk about call by value. Later on in this course, we're going also to talk about call by reference. So what is a call by value? So in a call by value, a copy of the actual parameter, the value passed to the function, is made and used inside the function. So any modification to the parameter inside the function do not affect the original value in the calling function. So when a function is called, the values of the arguments are copied into the function's parameter. So changes made to the parameter inside the function are local to the function and do not affect the original argument. And why is call by value is so important? Why is it so important? So the original values remain unchanged, which is useful when we don't want a function to modify our data. So basically, what it means is that when we are calling a function using a call by value method, if we are passing like 2 numbers to the function, these 2 numbers are copied here. There are certain tasks done here and the function result is obvious. Then whatever the modification inside this function is done is going to stay inside this function. So if num1 equals 10 and there are some modification here, still the num1 is going to stay equals to 10 in the main function. So whatever the modification is there is there. It's not going to affect the int main function. So here we are going to write a program where a function calculates the sum of 2 numbers. So the values passed to the function should not change in the main function. So when it says should not change in the main function, in the main program, we realize it's asking us to do a call by value. To do that, we have one main program here and one function here. So here in the main function, I am initializing 2 numbers like int num1 equals 10 and num2 equals 20. Then I call the function. When I call the function, I pass these 2 arguments, and these 2 arguments are integer and they're not optional variables because they are not having the equal sign like the default parameters, like the optional parameters. So when we are calling this function, we must have both arguments, and we must have these 2 arguments being passed to this function. And the name of the function and the function is a void type. So in the function, it's very straightforward. We're going to say int sum is initialized and then the value a plus b is set to sum. Here we just mention whatever the integer we want to pass, but the name in the function is different. It's a and b. It could be anything. It's not important. So when num1 and num2 are passed here, num1 and num2 are going to replace int a and int b. Then it is going to do the addition, assign it to sum, and then see out the sum inside the function is, and print the value of sum. Then we are going to modify value a and b. So in this way, we are modifying the values passed to the function, but they are going to stay there locally. In these a equal to b and b equals to b does not affect num1 and num2 because it's a call by value. In order to make sure after this function is finished and the sum is printed here, and two modifications are done here, the sum is finished, then we go to the next line. So see out the value in the main function are still, we print num1 and we print num2 here, and we return it. So let's run and see how it works. Okay, great. So we see that these two numbers are initialized and assigned values. Then we call the function, we go to the function, the addition is done, and the sum is printed. So it says the sum inside the function is 30. So the sum inside the function is 30. Here it means that 10 plus 20 is 30, so 30 is printed, and we are changing the value of a and b here. We are setting them to 0. However, when this function is finished, this line is finished, and then the program goes to this line. And when the program goes to this line, we will see that it says the value in the main are still 10 and 20. So these are the initial values set here. So these modifications are only for the local function and does not affect the main function. So this is the main purpose of calling by value. I would like to propose doing some exercises like this. So just solve and code this exercise yourself several times. In the next videos, we're going to solve some further exercises of call by value so we can see its importance. Hey everyone, welcome back. So we're going to do one coding exercises using call by value and show that using a call by value, when we call a function by value, it's not going to change the value of the original parameter, and it's going to change it only locally. So here we would like to write a program where a function attempts to swap two numbers using call by value. And we need to show the original values remained unchanged. So there are two things that we are going to learn. First, how to do the swap of two numbers using call by value, and also how to show that how to write these codes in the function and show that the original values remained unchanged. To do that, we have one main function and a swap function here. So we start from here. Every time you want to read your code, start from the main function, because whatever that is here is going to be executed. So here we are saying num1 equals 5, num2 equals 10. So we are initializing these two numbers, and we are saying that cout before function called num1 equals the value of num1 and num2 equals num2. So we expect that 5 and 10 is going to be printed here. Then we are calling the swap function and passing these two inputs or arguments. Then these two arguments are copied. Their original value is not going to go there. So a copy of them is going to go there because we are using a call by value. This is why the original number remains unchanged, in fact. So this function is called swap numbers. It's the name. There are two arguments. Both of them are integer, and the output, there is no output. It's a void function. To swap two numbers, one easy way and nice way is to define a new parameter. So here we are defining a new parameter. Just remember, like temp a and b. So we are firstly initializing a new parameter called temp, which is temporary. So we are putting a to temporary. So initially temporary temp is empty and the value of a is then set to temp. So the value of a is 5. So now temp equals 5. Then the value of b is assigned to a. So the value of b is 10. So it is assigned to a. So a is 10. And finally, the value of temp is assigned to b. So now temp is 5 and b will be 5. Okay, so one more time. So initially temp is empty. So the value of a is assigned to temp. So temp will be 5 because a is 5. Why a is 5? Because it's the first argument, and in the first argument we are passing num1 and num1 is 5. Okay, and num2 is 10. So the second argument is 10, therefore b is 10. So initially we are assigning a to temp, meaning that 5 equal, so temp equals 5. 5 is set to temp. Then we are putting whatever that is in b in a. So b is 10 and 10 is assigned to a. And in the last line, we are going to assign temp into b. So temp was 5 and 5 equals 10 then. 5 is assigned to b. Sorry. And then we are going to mention that inside the function, now a equals, we expect to have 10, a equals 10, and b equals, we are expecting to have it to be 5. So after doing all these modifications in this function, all of these are local. So we expect by swapping the values of the a and b, the values of num1 and num2 should not be affected because it's a call by value. So after this function is finished, then we are again here after function call, we are again printing num1 and num2 to make sure that everything is correct and these two remain unchanged. Let's run. Okay. So here, this line before function call, num1 equals 5, num2 equals 10. Okay. Then we are calling the function swap number. So here, as we went through the procedure twice, the procedure is done, so the numbers are swapped, and then we say, okay, inside the function, a is 1, a is 10, and b is 5. Therefore, the numbers are swapped. Okay. However, when this function is finished and the code is here, and then it wants to execute this line, it says after function call num1, you see num1 remains 5, and num2 remains 10. So the swap procedure in the local function, locally in this function, did not impact the main function. So this is the main purpose of the call by value. Firstly, we learned how to swap two numbers. We need to there may be many ways to do it, but the easiest way is to define a new integer called here like temp, and then using that we can swap the numbers. And then we learned that even though we swap the numbers in the function, it's not going to impact the original value in the int main function because it was done here locally. However, if we were doing all of these tasks in the int main function, of course, the swap would have worked and num1 in the end would have been 10 and num2 would have been 5. Thank you for watching. Hello everyone, welcome back. Today we are doing another coding exercises using call by value. So we're going to write a program where a function doubles the value of a number using call by value and show that the original value in main is unaffected. So even if it was not mentioning call by value, when it says that show the original value in the main function is unaffected, it means that we need to use the call by value. To do so, we have a function here to do the doubling the number and the main function. We always start from the main function. So we initialize one number as to be 15, Then we print the value saying that before we call the function, the value is this. So we expect that it would print before function called number equals 15. Then we call the function with this number. So the number is passed to this argument is passed to this function. So the name of the function, it's a void function and it has only one argument and it's a must argument. It's not optional because it does not have equal sign, etc. So it's a must argument. It's not optional like the functions with default values. So I try to remind all of these things while I'm talking to let you hear them again and again, so somehow you learn it by heart. So here, what this function is going to do is that it's going to take the n and double the number and print the number. So it's going to take the number 15 and then this number is doubled and the value is printed. So 15 times 2, it will be 30. 30 is going to be printed as the new value of n because we assigned 15 times 2 is assigned to n again. So the new value of n is 30. However, when this function is finished, the code finishes this line of execution and it goes to the next line. After function called number equals 2, we expect to show the number 15 here again. Why? Because we are using call by value. Let's run the code and see how it goes. Okay, so let's analyze the code one more time. Here we are initializing the number, it's equal to 15. We say before function call number equals 15 because it is initialized here and we're just printing it here, so it is 15. We call the function, we go to the function, we double the number and we print the value. So when we double the number using this line, it's going to print 30 for us. So here n equals 30. We modify the value of n. And when this function is finished, we are in this line, and the program goes to execute line number 14. So after function call number equals, we are going to print this, it still prints 15. So whatever the modification is done, it's done in this function locally, and it does not impact the original value of the number. Why? Because we are calling by value. So when we are calling by value, this original number is not passed to this function, but a copy of this number is passed to do further mathematical operations here. And that's it. So the original number remains the same. This is how call by value will work. However, in call by reference, things are different. So in the next video, we're going to talk about how to call a function by reference. Thanks for watching. And if you haven't had the chance yet to rate the course, we appreciate it if you could give it the stars. And also if you have some constructive feedback and comments, we appreciate to have them because it would help us to improve the course for future students. Thank you very much. Hello everyone, welcome back. Today we're going to talk about call by references. So far we learned how to call a function by value, and we learned about the details. We did some coding exercises with respect to that. Today we're going to move on and focus on call by reference. So there are two main way to call a function. So the first one was call by value. Now we're going to focus on call by reference. So what a call by reference is. So in a call by reference, instead of passing a copy of the value, a function receives the reference or the memory address, let's say, of the variable. So this means that any changes made to the parameter inside the function directly affect the original value. Why? Because it's not receiving a copy of it, but its reference, which is the memory address. So it is going to directly manipulate and modify the original value. So when a function called, instead of creating a copy of the argument, the function works directly with the original value in call by reference. So let's learn it with an example. So here we're going to write a program that swaps two numbers using call by reference. So it wants us to define a function that swaps the value of two variables and call the function from the main function and show the values are swapped. Previously, we solved this program already with the call by value. There, only the numbers that were swapped in the function, they were locally changed, but in the main function, they didn't change. However, they are going to be changed here because we're calling them by reference. So basically, to do so, we know that we need to have two numbers and a function to do the swap for us. So here is our int main function, and here is another function that we have, the swap function. It's a void function, and the arguments of this function are two parameters. There are two arguments, let's say, and both of them are having integer data type. And so previously we were just writing down int a or int b. Now we are having this reference sign here, the and sign. So this and sign is for the call by reference. So this and sign means that go and check the address of where this argument is stored. Again, here this and sign means that go and check where the address of this B is and where it is stored. Let's dive in. So we initialize and declare two integers here, num1 and num2. The first one is 5 and the second one is 10. And we print the value of these two numbers, saying that before swapping, num1 equals 5 and num2 equals 10. Then we are going to call this swap numbers function, which is this one, and we are passing these two arguments, these two input values. So by passing these two arguments, the program, while being executed, will go and starts from here, which is the function, okay? So when it goes here, because the function is defined in a way to go and check the reference, it's going to uh, check where the variable is initially and originally stored in the memory. Therefore, it is going to directly work with that. So this is why we call it call by reference, because it's going to check the reference than original place where the variable is storing. However, just note that when we are calling by reference, here nothing changes. It is exactly similar to the call by value. The change is only these two ands, okay? Then to do the swap, we define a new integer. We put the value of a into temp. So let me go through the analyzing of code like before. It would be easier for you to understand. So here we are having this, something like this. So temp is empty in the beginning. So the value of a is assigned to temp. So a is 5 because a is the first argument, and here the first argument is num1 and the num1 equals 5. So a is assigned to temp, so 5 is assigned to temp. Then b is assigned to a, so a equals 10. Why 10? Because b is the second argument, and here the second argument is num2, and num2 equals 10. So 10 is assigned to a. And finally, temp is assigned to b. So temp was 5, and now 10 was assigned to b. So we did the swap using these three lines. Initially, a was 5, b was 10, but now after swapping, a is 10, b is 5. So done. We swapped the numbers. So when the function is finished here, this line of code is executed. So the program goes to this line where it is printing after swapping. So num1 equals, we print the value of num1 again, and we print the value of num2 again. So let's run and see how it works, and we're going to analyze the code once more. Okay, so here we see that the code is initializing these two variables, then it is printing before swapping num1 equals 5, num2 equals 10. So num1 equals 5, which is true, and num2 equals 10, which is again true because they were initialized just like 2 lines above. Then it is going to call this function. This function is going to swap these two values. However, because it's a call by reference using these two and signs, we know that if there is a change, it is going to impact these two numbers because it's a call by reference. So the swap procedure is done here. So this line is executed, then the program is going to line 19. So, and it is printing after swapping num1 equals 10 and num2 equals 5. So we see that using call by reference, whatever we do, even locally in this function, since it's a call by reference, it's going to impact the original value of the numbers even in the int main function. So something to keep that in mind. So if I remove these two and, it will become like a call by value. So the the values are not going to change. So let's try them here. So you can see. Okay, as you see here, I removed the and sign here and the and sign here. So this is not a call by reference anymore. This is a call by value. So in this case, when a call by value is done, the program is executed like this. So it is printing 5 and 10 using this line, which is the original value. Then it is going to call this function. This function is doing the swap, and then when the function is finished, it is going to print again the values of num1 and num2. However, the values of num1 and num2 are exactly the same initial values because it's not a call by reference and it's a call by value. So in a call by value, we learned that we are not going to modify the original value, but a copy of the value. So this is why we call it call by value. However, in a call by reference, we are giving the address where these two variables are stored. Therefore, the function is going to directly go there, find them, find the reference, and directly work with the original values. So I made it like to be call by reference again by adding these two ands. And we see here the first number is 5 and 10. It is printed. Then the function is called. And then when we are printing again the num1 and num2, the values have swapped. So this is important to know the differences between the call by value and call by reference, but because in different there are two different and separated things, and in programming, as per our need, we need to choose from either of them depending on what the goal of our program is. So keep that in mind, keep practicing, and try to play with call by reference and call by value by solving the exercises that I provided in different videos so you can master it. Thanks for watching. Hello everyone, welcome back. Today we are going to do another coding exercises using call by reference. So we would like to write a program where a function doubles the value of a number using call by reference. So we need to define a function. We are asked to define a function that modifies the value of the past variables. So call the function from the main function and show that the original variable is updated. So even if the program was not mentioning using call by reference, when they are saying that show that the original variable is updated, we need to get it. Okay, it's talking about call by reference and not call by value. So in order to do that, we define a function that is going to modify the value of the past variable, and we need to write a function that doubles the value of a number. So here we have the main function, and here we have the function that does the work for us. So it's a void function, and it is having only one argument, and it's an integer. And because it's a call by reference, we know that we need to put the and before the name of the integer. So the compiler would understand we're talking about call by reference. Okay, to do that, in the int main, we initialize the number to 15, then we print the value. We print the value, okay, we say before doubling number equals, and we print the value of it, which is expected to be 15 because we just initialize it. Then we are calling the double value function using one argument, and the argument is this number 15. And just note that in call by reference and in call by value, there is no difference for calling the function in this part. The only difference is this and added to the argument in the function declaration. Then this function gets the number address, so it is going to directly work with the original value and not a copy of it like call by value. And here it says, okay, whatever n is, make it multiplied by 2 and store it in n. So this way, the multiplied number, the multiplied of the number is stored in n, and the function is done. So when the function is done, the program is going to execute the next line, and we are saying after doubling number equals, we expect to see 30. So let's check. Okay, great. So here it is 15. It's going to print 15, and it's going to do the doubling using this double value, and it is simply just performing this equation times 2. So whatever the number is past this n is here times 2, and then put it to the value of n. So modify it, update it. So if it's 15, it's going to be 15 times 2. If it's 10, 10 times 2, whatever the n is, that is passed here using the number that is initialized here. So it is going to be multiplied by 2. If I put 10 here instead of 15 and then pass the number, it is going to be 10 times 2. So then when it's done, it is going now to print the after doubling. So the value is updated because it's a call by reference. And if I want to make it like a call by value, I simply remove this and sign, I save, and I compile again. Okay, you see? So here, when it's a call by value, now it's not a call by reference anymore. It's a call by value, and you see that whatever modification in this function was, it doesn't matter, and the before and the after, like before doubling and after doubling, the value of the number remains the same. Why? It's a call by value now. It does not have the and sign, so it is going to work with a copy of the original number. When we put the sign, it is going to work with the original number directly, and it's going to update the original number and modifies it. So keep that in mind. It's very straightforward, but we need to do the practice to master it. Hello everyone, welcome back. Let's do another coding exercise using call by reference. So we would like to write a program where a function updates two numbers by reference. Add 10 to the first number, multiply the second number by 2, and then call the function and show both numbers are updated. When it says both numbers are updated, we know that we need to use call by reference, even if it was not being mentioned here. Okay, to do that, we have one int function and one function that does the work for us. The update value function, update value is the name of the function. It's a void function. It is having two arguments. The first one is integer. The second one is also integer. The first one is x. The second one is named y. Because it's a call by reference, we have this and sign before the name of our integers. So we initialize two numbers, 20 and 15. They mentioned that add 10 to the first one and multiply the second one by 2. We say okay. So let's first print the numbers before doing any modification. So before doing any modification, we say before update num1 equals, we print number num1 like here, and we show this message, and then we print num2, which is 15. So we expect to see 20 and 15 in by executing this line of the code. Then we are calling by reference this function. So here the first argument is x and the second argument is y. So the first argument and the second argument. And for the first one, we need to add it by 10. For the second one, we need to multiply it by 2. So x, we are adding whatever the value of x is, we are adding 10 values to it using plus equal. And then whatever the value of y is, we are multiplying it by 2 by star equal. We know from before, instead of writing, for example, instead of writing x equals x plus 10, we can write x plus equal 10. Okay, and we also know for efficiency, instead of writing y equals y star 2, we can simply say y star equal to. They does the same job, they do the same job, however it's more concise, so we are using this way. So it is simply just adding 10 values to whatever the value of x is, and it is multiplying y by 2, whatever the value of y is. So this function is very simple and it's done. When the execution of this line, this function is finished, it is going to next line where we are printing after update num1 equals, and then we are printing num1, and then we are printing num2. Here we are expecting to see different numbers. So the first number was 20. We added 10 values to it. So here we are expecting to see 30 now. And the initial num2 was 15, and we multiplied this by 2, and we are expecting to see 30 here. Let's compile. Okay, great. So we are seeing what we want to see. So 20 and 15 is passed to this function. Before passing, it says num1 equals 20, just like here, num2 equals 15, just like here. Then this function is called, we are going to this function. This function is adding 10 to the first num, so num1, instead of 20, it is now 30, which is shown here. And then the second argument, num2, which is y here, so it is multiplied by 2, and it is now 30. And this is what we wanted to do, and it did the job. So call by reference, modifying the original value. So please start doing the coding of these exercises that I do, and make errors, because when you make errors, you're going to learn from those errors and see how the syntaxes are working all together. It is very important to do that. Thank you for watching.
Hello everyone, and welcome back. Today we are going to do one coding exercises using template functions. So we would like to write a program that swaps two values, the first value and two value of a function. So whatever we pass as an argument to a function, we would like this function to swap their place. So when we are, for example, passing two values like x and y, we would like to see in the output y and x. Okay, we would like to swap their values. To do that, we have a function, and it happens to be a template function, because we discussed that instead of having multiple functions doing the same thing for different outputs, like for integer, float, etc., we can have one unique function that does everything, and it has to be a type of template. So to do that, we know that we need to include this header. So the function that does the swap is the swap value. It's a void function. It's not returning anything. And as an argument, as the argument, it is taking two arguments. So their type is t. So it's a t. And then
here we will see that it has the A and B argument, and they are called by reference because we have the and sign behind the name of the arguments. So when we have the and sign there, it means that it's a call by reference. And just please note that it's a void function and not a t function. So if it was supposed to have some output, we could write t here. Okay, so if it was going to return something in the end, so it could be t, so the output would be like t, a template, so the compiler would decide about that. However, we don't have any output. You see, we don't have any return. We are just doing some tasks here, and we are doing it by call by reference because we would like to actually modify the original values. Okay, let's try and see how this function works with different arguments. Initially, we define two integers. They are named x and y. Their values are 10 and 20. Then we have two float. Their names are p and q. One of them is 1.5 and the other one is 2.5. And lastly, we have two strings, str1 and str2. One of them is hello and the other one is word. So we would like to use these set of arguments to call this function to swap their values. So when we are going to call this function, in the end, the value of x should be equal to 20 and the value of y should be equal to 10. The same here and the same here. Let's see. So we are first printing before swapping x equals, so it will be 10 because we haven't done anything, and y equals, it will be 20 because we haven't done anything yet. Okay. Then we are calling the swap function with x and y. So with x and y, we are calling by reference the function. Why the reference? Because we see that we have the and sign, and when we are calling by reference using the and sign, it means that we are going to modify the original value. So the x and y will be modified here in the int main function. And we know how to swap the values. We define a new data type. The data type is template here because one time it's going to take int, one time it's going to be float, one time it's going to be a string. So it can be t. So therefore the compiler will decide what to choose as the type of this data. So we declare and initialize t. So whatever that is in a, we put it in t, in temp. Then whatever that is in b, we put it in a, and whatever that is in temp, we put it in b. This way we're going to swap the values. Then when this function has finished, so here we called the function with x and y, so we did the swap and this function is finished. So the program is going to execute this line. It is saying that after swapping x equals and y equals. So we expect that now that we are printing after swapping line, x will equal 20 and y will equal 10. The same here. So here we are saying that before swapping p equals, it's 1.5 and e equals 2.5. Then again, we are calling the function with these two arguments, p and q. Then it is going to treat the arguments the same as before. It's a call by reference still, so because we didn't change anything. And now t will be float. Previously it was integer, but now that we have the float arguments, it's going to be float. Then it is going to do the swapping, and after swapping we are printing the value of p and q. So p should be 2.5 in the end because it is changed, and q should be 1.5. Finally, we are printing before swapping the value of str1 and str2, which will be hello and word here. Then we call the function one more time with these two arguments that are strings, so it's going to be there, and then the t value will be chosen by the t data type will be chosen by the compiler, but in this case it's going to choose string because we have two string arguments. So it is going to swap their values, and after swapping, str1 should be equal to word and str2 should be equal to hello. Let's compile and see. Okay, great. So here we see, let's start from here. Okay, so we see before swapping x equals 10, y equals 20, exactly like this. Then after swapping x equals 20, y equals 10. So there are two lessons here. First, call by reference, it's going to modify the original value in not even if it's in another function. Second, we use the template data type. So the function, the compiler decided about the data type of the arguments and of the temp. And in our case, it was integer, so it's integer. Then we are having here, okay, before it's p equals 1.5 and q equals 2.5. This is exactly the same. So the assigned numbers unprinted. Then we call the swap value function. It does the swapping. And then we see that the value of p is 2.5 and q is 1.5. So it is changed. And finally, let me just get it above here so it would be also easy. Oops, sorry. So to also trace the program from here. Okay. So here we are printing the str1 and str2. So str1 is hello, str2 is word. So it is before swapping, it says str1 is hello and str2 is word. Then we call the function, we do the swapping here, and then after swapping, when we print str1 equals word and str2 equals hello. We see that using template function, we can do the swapping tasks. Not important, and it's not important the data type of the arguments. So whatever that is here, it is going to be adapted to that. So that's very nice. And then because we use the call by reference using this and these two and signs, it's going to modify the original value. Thank you very much for watching, and please do the exercises yourself, try them to see where you make mistakes. Those are the places you can learn from and improve your coding from there. Thank you very much for watching. If you haven't had the chance to rate this course, we would very much appreciate it to go and rate it. And also, please provide us with your constructive comments. It would help us to improve our teaching and our methods and our courses for future students. Thank you very much. Hello everyone, welcome back. So far we learned about call by value and call by reference. To make a summary, a call by value copy is a copy of the value, so it's not going to modify the original data and does not impact the original data. So when we don't want to modify the original data, we are going to use call by value. And when we would like to modify the original data, we are going to use call by reference. So a reference to the actual variable is used, therefore the original value is changed. However, today we're going to talk about template function. So a template function in C++ is a way to write a single function that works with different data types without rewriting the same function for each type. So instead of specifying the data type like int, float, or string, we can use a placeholder that the compiler replaces with the actual type during the compilation. So just write one function that works for multiple data types instead of creating separate functions for int, float, and other types. Let me explain it using an example. So previously, when we were talking about a function, we had the name of the function, we had the type of the output here, like if it was void, there was no output, otherwise int, a float, double, etc. So from this data type before the name of the function, we could understand the output of the function, the data type of the output of the function. And also in the parentheses, when we were having the arguments, we were having like int a, int b. So we were knowing that the input must be integer and not a double. So when we were talking about having int a, we knew that when we are going to call this function, we must pass the argument that is integer. And if it was defined to be an integer and we were passing like a double number, it was returning error. So in order to avoid writing different functions that works and do the same for us, do the same thing for us, but having different input and output, like we could write one function for the float, another function for double, another function for integers, another function for a string, etc. Instead of doing that, we can write a more generalized function and let the compiler decide about the type of the input and the output. To do that, we need to include this in the top on the top of our code, like template. Within the angle bracket we have the type name t. So this is something that we need to include, like using namespace std, etc. After including this, we can simply define the output of the function to be t and the input of and the types of the arguments or inputs to be also t, like here. Okay, when we did that, we can easily just use this function for integers, for doubles, for whatever we want. So let's see what we would like to write. We would like to write a template function that takes two inputs and returns the larger of the two. So the function should work for any data type, int, float, double, etc. So even if it was not directly mentioning to write a template function, by saying that the function should work for any data type, we could guess that it is asking for a template function, because only a template function can do that for us. So let's dive into the code. So int main is having 3 lines only. So the first line says that max of 3 and 7, and then call the find max function with two numbers 3 and 7. Okay, when it is calling the function, it is going to start running the function. So using ternary operator, there is a condition here saying that in the condition, if you remember the ternary conditions, ternary operators, we were having like the first and the second. It is saying that A is greater than B. Okay, so this is the condition. The condition is separated from the possible outcome with a question mark. So these are two possible outcomes, and two possible outcomes are being separated with a colon. Okay, so it is saying if A is greater than B, return A. Okay, but if this condition is true, just return the first number, just return the first possible output. However, if this condition is not true, just return the second defined number. Okay, second defined uh, integer or variable here, second defined possible outcome here. Okay, so we are passing 3 and 7, and so 3 and 7 is here. So because 3 and 7 are integer, the compiler will realize that the arguments are integers. It is done automatically by the compiler. So it says 3, is it larger than 7? No, therefore, because it is not passing this condition, so it is not going to return A, but it is going to return B. So B is returned. Okay. Then it goes to the next line, says that max of 4.5 and 2.3, and then calling the function, putting 4.5 and 2.3. So instead of you know, just defining another function, we can simply just use double or float number here, as you can see. So it is calling the function again. So the function automatically realized that, okay, we're talking about float numbers. So the arguments are floats, so the output should be float. And it is saying that, okay, it is checking the condition A and B. So A would be the first argument because it is A, and the second argument would be B, which is 2.3. It is mentioning, it is checking the condition that if 4.5 is bigger than 2.3, if this condition is true, which is true, the first condition, the first possible outcome, which is A, is returned. Okay, so 4.5 is returned. Then the program is executed and it goes to the last line. It is saying max of A and Z. So basically, we can compare characters. Each of these characters are having an associate number. So it is going to say that, okay, find max with A and Z. It works for characters, okay? So we don't need to define a separate function. So the compiler will automatically realize, okay, we're comparing characters. It is going to check if A is greater than B. If this is true, A is going to be returned. If this condition is not true, B is going to be returned. So after analyzing the code, let's compile and see the results, and then we are going to do the checking one more time. Okay, so it is starting from here, it is saying that max of 3 and 7 is 7. It is integer value, both of them are integers. Integers are passed as arguments, and it is found that 7 is bigger, which is true. Then two float numbers are passed, like 4.5 and 2.3, and it is okay again because it's a t template function and we're putting t here, so the compiler automatically realizes that we are talking about float. And then it is finding the maximum between A and Z, and then it is comparing, and Z has the larger, let's say, behind the scene value, because each of the characters are associated with a number. So it starts with A, and as we move forward to B, C, etc., their associated value is going to increase. Therefore, Z having that, it is comparing those numbers with each other. So therefore Z is larger, and it is going to show Z in the output. So this is template function. It's very easy and it works very well when we don't know which data type that we are going to work with when we're calling this function. Therefore, the function will choose automatically the data type for us itself.
Hello everyone, welcome to this lecture. In today's video, we would like to write a program in C++ to calculate the sum of the series here, okay, this series. In parentheses, 1 multiplied by 1 plus 2 multiplied by 2 plus 3 multiplied by 3 plus 4 multiplied by 4, etc. until the end, n multiplied by n. So let me first run the code once, and then we're going to dive deep into the details. So enter the value of n. So we saw that it can go until n multiplied by n. So if I want to have only the calculation of the sum of this series for the first part, I would say number 1. So only 1 multiplied by 1 is calculated and the output is 1. Okay. So when I run the code one more time, when I type down 2, and we are having 1 multiplied by 1 plus 2 multiplied by 2. So this one is 4, and this one, the outcome is 1. 4 plus 1, the output is 5. Okay. And for example, if I have number 5 as the input, we are going to start from 1 multiplied by 1 plus 2 multiplied by 2 plus, and it is going to continue until 5 multiplied by 5. So the output is 55. So this is the series that we would like to calculate its sum, and we would like to have its sum in C++, and we would like C++ to help us to calculate the sum of this series. To do that, first of all, we are having two variables. The first variable is n. It's of integer type, so this is the number of terms in the series that we want to have. And then we are having one integer called sum. It is initialized to be 0, and it is the variable that we are going to use to store the sum of the series. After that, we are going to ask the user to enter the value of n. For example, the user is going to enter 2. It means that they want to have this series. So 1 multiplied by 1 plus 2 multiplied by 2. So when the user is going to choose n to be equal to 2, it means that they want the sum of this part of the series. If they're going to choose 5, it means that they're going to have it like this, okay? So they're going to have it from 1 multiplied by 1, sorry, until 5 multiplied by 5. So we are going to ask the user to enter the value of n, and we are going to store it in the n using the cin. Then we are going to have a for loop to do the calculation of the sum. We are going to have a for loop starting from 1. It is going to continue as long as I is lower than or equal to n, and I is going to increase by 1 unit in each iteration. After that, in the next line, we are having sum plus equal I multiplied by I. So for example, this line means that we can have sum equals sum plus I multiplied by I, okay? So this equation here is exactly equal to this one, okay? So it depends on us. Which one you want to write down, it's okay. It's your choice. But they're going to do the same thing in terms of mathematics. So if, for example, the user is going to enter n equals 3, we are going to have 3 iterations. For I equals 1, because we start from 1 in the for loop, I equals 2, and I equals 3. I equals 3 because I can increase as long as it is lower than or equal to n, and n is 3, so I is going to take 3 as well. So in the first iteration, when I equals 1, sum equals sum plus 1 multiplied by 1, okay? So the output of this will be sum equals 1. Why? In the first iteration, I equals 1. Sum equals sum plus 1 multiplied by 1. Why 1 multiplied by 1? Because this is the formula. Sum equals sum plus I multiplied by I. So in the first iteration, I equals 1. Therefore, we are having I multiplied by I. So 1 multiplied by 1 is the result of this. And then we are having the sum in the formulation, and sum was initialized to be 0. Therefore, 0 plus 1 equals 1. So sum is 1 for the first iteration. Then I equals 2. So sum equals sum plus 2, sorry, multiplied by 2. Okay. So sum plus 2 multiplied by 2. And already sum equals 1 from the first iteration. We know that sum equals 1. Plus 2 multiplied by 2 is 4. So 1 plus 4, it means that sum equals 5. In the third iteration, which is the last iteration, because we assume that n equals 3, for example, we are going to have sum equal sum plus 3 multiplied by 3. This means that 5 plus 9. We are having 5 plus 9. 5 comes from the last iteration of sum, so sum equals 5 already. And then 3 multiplied by 3 is 9. Therefore, we are going to have the sum equal 14. this is how we're going to use it. So in the last iteration, sum equals 14. And now if we want to increment the value of I equals 4. 4 is lower than 3. No, this statement is not true. Therefore, the for loop is finished. And now we are going to see out this message to the user saying that, for example, the sum of the series 1 multiplied by 1 plus 2 multiplied by 2, etc. equals sum. And the sum is getting this value for n equals 3. So when I run the code one more time, I enter the value of n, I enter 3, and we see that the calculation that we did was correct. So because the output is 14 here, and we also had this 14 in the calculation ourselves. So when we enter number 3, it means that we want the series to be 1 multiplied by 1 plus 2 multiplied by 2 plus 3 multiplied by 3. Therefore, the output is 14. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that displays the sum of n odd natural numbers. Here is what we mean. For example, if n equals 2, it means that I would like to have the sum of 1 plus 3. So the first two natural numbers. Then if n equals 3, for example, or let's say 5, it means that I would like to have the sum of 1 plus 3 plus 5 plus 7 plus 9. So these 5 numbers, the first 5 odd numbers. This is what we mean. So if the user is going to enter n equals 5, I would like to have the calculation of the sum of the first 5 odd numbers. To do that, we are having an integer called n, and then we are having a sum that we are going to use to store the variable sum in this variable called sum. It's of integer type, and first of all, we're initializing it to 0. Then we are going to ask the user to enter the value of n, and whatever the user is going to enter, we're going to store it in n. For example, the user is going to enter 2, and then we are going to calculate the first two odd numbers summation, 1 plus 3. And if the user is going to enter 5, for example, we are going to have the sum of the first 5 odd numbers. Then we are going to have a for loop starting from 1, and as long as I is lower than or equal to n, we are going to continue this for loop. And then in order to find the odd numbers, we can have this formula. So sum plus equals 2 multiplied by 1 minus 1. And this equals sum plus 2 times I minus 1. This one is also I, it's not 1. So this formula is exactly this formula. They're doing the same thing. So it means that in the first iteration, for example, when I equals 1, let me test to see if the formula that we provided is working or not. So if I equals 1, it means that sum equals 0 plus 2 multiplied by 1 minus 1. Okay, it means that sum equals, why we are having 0 plus this number? Because sum plus this formula, and I equals 1, so 2 multiplied by 1 minus 1, and sum equals 0 because we initialize it to be 0. Therefore, sum equals 2 multiplied by 1, the output is 2 minus 1, it will be 1. Okay. Then we are having I equals 2, sum equals 1 plus 2 multiplied by 2 minus 1. Okay. This means that we are having 1 plus 2 multiplied by 2 is 4 minus 1, it will be 3. Okay. And then we are having 3 plus 1, therefore sum equals 4. and I equals 3, sum equals 4 plus 2 multiplied by 3 minus 1, and the output will be 4 plus 2 multiplied by 3 is 6 minus 1, it's 5, therefore sum equals 9. So for example, if the user is going to enter n equals 3, it means that we need to calculate the sum of 1 plus 3 plus 5, and this sum will be 9. Okay, here we did the test for 3 iterations, so when I equals 3, the sum will be equal to 9. And how we did the computation, we used this formula to get only the odd numbers. If you see here, when we are using this formula, when we are implementing for the first iteration, 2 multiplied by 1 is 2 minus 1, it will be equal to 1. So 1 is an odd number, so we are having it to assigned to sum. Then we are having in the next round, we are calculating 2 multiplied by 2 will be 4, minus 1, it will be 3. And 3 plus the previously calculated sum, which is 1, it will be 4. So the summation of 1 and 3 is 4. Okay, the first two odd numbers. Then in the third iteration, we are having 2 multiplied by 3, it will be 6, minus 1, it will be 5, and 5 is added to 4, and 4 was the calculation of 1 and 3. 1 and 3 is 4, and then we are adding 5 to this 4, so the sum equals 9. This is how, in fact, we are going to calculate the sum of, for example, first 3 odd numbers. When I enter the value n equals 3, it says the sum of the first 3 odd natural numbers is 9. So this is how we can have their summation. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to find the number and sum of all integers between 100 and 200 which are divisible by 9. It means that we would like to have a for loop starting from 100 to 200 if the numbers are divisible by 9. We would like to know and display them. We would like to know them and display them, and also calculate their sum. Okay, here is how we can do it in C++. I'm having two variables called count and sum, both initialized to be 0. Then we show this message: numbers divisible by 9 between 100 and 200 are. After that, we're going to loop through the numbers from 100 to 200. We are having our iterating variable called I. It is going to start from 100 and it is going to continue as long as I equals 200. After that, in the for loop, we are going to first check this condition. If I divided by 9 and the remainder of this division using the modulo operator equals to 0, it means that I is divisible by 9. Therefore, see out that I, then increment the value of count, which was set to 0, and then add that I to the sum. So what happens is the following. So first of all, it is going to show that I, okay? Then increase the value of count variable by 1. So we know that, okay, now we are having between 100 and 200, we are having 10 numbers that are divisible by 9. Using the count plus, we are going to understand how many numbers. I'm going to explain how. And then we are having sum plus I. Sum equals sum plus I. sum was initially 0, then we are having in the first iteration, we are adding that number that is divisible by 9. Then if we are having another number, we are going to also add that as well, etc. until the end. And how basically this count works is the following. For example, when we are having count equals to be 0, we check to see if I is divisible by 9. If so, it means that the remainder of their division equals to 0. If this statement is true, we are going to implement this part. First of all, we are going to display I. Then we are going to increase the value of count by 1. So exactly like this, okay? We were increasing the value of I in our loop after each iteration. So every time that we find an I that is divisible by 9, we increase the value of count by 1 value. So if, for example, 10 times we enter this if condition and we find 10 numbers that are divisible by 9, we are going to have the count equal to, for example, 10. So let me run the code. When I run the code, it says numbers divisible by 9 between 100 and 200 are 108, 117, 128, 135, 144, etc. until 198. So total numbers divisible by 9, 11. So this is the output of count because we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we entered this if condition. We entered this if condition 11 times and we printed out the I as you see here. So in the first time that I is divisible by 9, it is I equals to 108. So count was 0. Now it is incremented by 1 value. Now it is 1. Then we are having this next I that is divisible by 9 is 117. When we are having I equals 117, the remainder of the division that 117 is divided by 9 equals to 0. We are going to print 117 here. Then we are going to increment the value of count one more time. So initially it was 0. Then after the iteration of 108, we increased its value to 1. And now that we are having 117, we are increasing its value to 2, for example. And then we are having the sum of numbers divisible by 9. It is 1683. So if we calculate the sum of these 11 numbers, we get to this number. And this is the output of sum. In each iteration that we found an I that is divisible by 9, we print out it and we are going to add that number to the sum variable. Okay, so 108 is found, it is added to the sum that was initially 0. Then we found 117, 117 is added to the sum that was already 108 from the previous iteration. Then 126 is found, it is again added to the sum variable until the end, and we are having the sum 1683. Here is how we are showing the output. As you see here, the total number divisible by 9, and then we are printing out the value of count, and then sum of numbers divided by 9 equals to sum that we are printing in the output. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to enter any number and print all factors of the number. Here is what we're going to do. We're going to ask the user to enter a number and we're going to store it in a variable called number that is declared to be an integer type. Then we are showing this message. Factors of number are, and then we are having a for loop starting from 1 until that number. So this iteration is starting from 1 and it is going to continue as long as I is lower than or equal to that number. Assuming that, for example, the user enters number to be equal to 20, we are having iteration from 1 until I equals 20. And in each iteration, we are increasing the value of I by 1 unit. Then we need to check if that number, which is 20, is divisible by I, and it means that the remainder of their division equals 0, we are going to print it in the output. So let me give you an example. So number equals 20. So 20 divided by 1, the remainder, if we want the remainder, we need to use the modulo sign. 20 divided by 1, then 20 divided by 2, the remainder, then 20 divided by 3, the remainder, until 20 divided by 20 and their remainder. So whenever the remainder of 20 divided by any of these i's equals 0, it means that that I is a factor of 20. Okay, and we're going to print that I. So let me run the code. First, it says enter a number, and I'm going to enter a number, for example, 20. It says factors of 20 are 1, 2, 4, 5, 10, and 20. It means that if 20 is divided by either of these numbers, the remainder of this division, of the divisions, is going to be equal to 0. For example, 20 divided by 1, the remainder equals 0. Okay. 20 divided by 2, the remainder equals 0. By 3, it's not 0. And then, for example, if we have 20, let me type it here. So we have 20 divided by 4, the remainder equals 0. 20 divided by 5, the remainder equals 0. And 20 divided by 10, for example, the remainder is 0. And 20 divided by 20, their remainder equals 0. So when I run the code one more time, it says enter a number, I say 20. So these are the factors of number 20. If I type down another number, for example, 36, we see that 36 has these many factors. It means that if 36 is divided by 1, the remainder equals 0. If 36 is divided by 2, the remainder of this division will be 0. If 36 is divided by 12, the remainder of this division will be equal to 0. This is how, in fact, we can find the factors of any number in C++. So let me review it one more time. We're going to ask the user to enter a number. We're going to store it. Then we are going to have a for loop starting at 1, and we're going to continue as long as I equals that number, that entered number. And we are going to say in each iteration, we check one if condition. If the number that is entered by the user in each iteration divided by I and the remainder of this division equals 0, it means that that I is a factor of our number. Therefore, we are going to print that I. Okay, so 20 is divided by 1, the remainder equals 0, we are going to print 1. 20 is divided by 2, the remainder of this division equals 0, we are going to print 2. 20 is divided by 3, the remainder of this division is not equal to 0. Therefore, this condition is not true, and we are not going to do anything. We are not going to print it because we are not even entering this if condition, because 20, when it is divided by 3, the remainder of this division does not equal 0. This is why we are going up again, and we are going to increase the value of I. This time I equals 4, and 20 divided by 4, the remainder equals 0. Yes, so we are going to print 4 here. Then 20 is divided by 5, the remainder of this division equals 0. Yes, we are going to, this condition is true, we are going to print 5. Okay, so the next iteration, I equals 6. 20 divided by 6, the remainder of this division equals 0. No, this statement is not true. Therefore, we are not going to enter this part and we are not going to print the 6 in the output. This is why when we type down 20, we see 1, 2, 4, 5, 10, and 20. So this is how we can find a factor to any number in C++. Thank you for watching. Hello everyone, and welcome to this lecture. In today's lecture, we are going to write a program that calculates the compound interest. In order to calculate the compound interest, we need to have three values. The first one is the principal amount. The second one is the rate in percentage. And also the third one is the number of years in which we are going to return the money. We are going to read this information from the user. So to do that, we initialize principal, rate, and time as doubles. And then we are going to ask the user using cout syntax to enter principal amount. And we are going to, whatever the user is entering, we are going to store it in principal. Then we are going to tell the user, okay, enter annual interest rate. And we're going to use the cin syntax in order to store the user input in the rate. And then we're going to get simply the number of years from the user and store it in time. After doing this, we're going to have the compound interest formula. So it's a common formula that we're going to write down here. We are having the principal times 1 plus rate divided by 100 to the power of years, to the power of time, which is the number of years that we are going to repay this amount. So in order to have one number added to another and then being to the power of another number, we are going to use po keyword in C++. In order to be able to use this keyword in C++, we need to include this library. So CMath library is already included in the header. Make sure that you're going to include it. And then when we are writing down po, there are two arguments in the parentheses and they are separated by a comma. The left-hand side is going to be increased to the power of the right-hand side argument. For example, if you type down po 3 to the power of 2, it is going to do the calculation like this. Okay, 3 times 3. Or if you type down po 5 times 3, it is going to calculate it to be like this. Sorry, like this. Okay, so this is the compound interest formula, and the only point that we need to be careful about is the use of the po keyword, which needs the inclusion of the CMath library in C++. So basically we have this formula to the power of the number of years, that is time here, and the rate is first divided by 100 because it is entered as a percentage, and then it is added by one value. Then it is the result is going to be calculated to the power of time. And then when we have the calculation, the result is stored in the double called amount. We're going to show the output using cout. We are just mentioning the compound interest after, for example, 30 years is, and the amount minus the principal. So because this formula is going to give you the amount that you're going to pay throughout, for example, 30 years. And when this amount is reduced, the principal amount that you got is reduced from this amount, you're going to have only the compound interest. And the total amount is the amount. So let me just run the code first and then we continue analyzing the code together. So when I compile it is asking enter principal amount. I would say, for example, 1000. Then enter annual interest rate. I would say, for example, 4.5%. And then enter the number of years. So I'm going to get a mortgage, for example, from the bank, and I'm going to get $1,000 from the bank, and the interest rate for this amount of money is 4.5, and I'm going to return this money after, for example, 30 years. So when I enter, it says that the compound interest after 30 years is 2,745 approximately dollars, and then the total amount is this number. So let me analyze the code one more time. So here it is asking enter the principal amount. We enter that, it stores. Enter the annual interest rate. We are entering the annual interest rate, and then it is saying that enter the time. I say, okay, I'm going to give this money back in 30 years with this interest rate. Okay, it does the calculation here, and it shows the compound interest after 30 years. So this is the time that is being printed there. So it is printing 30 because we actually entered 30 ourselves in the first place. So this number. So if you're getting 1,000 from the bank and you're going to repay in 30 years using this interest rate 4.5, you are going to pay $2,745 after 30 years more. So the total amount is 3,745. So you're getting 1,000 and you're returning 3,745, and the 2,745 of which is the interest that you're paying after 30 years with this interest rate. So it is a very interesting and practical example of how you can use basic knowledge in C++ and have a very useful program that calculates the compound interest for you. Thank you for watching. Hello and welcome to another lecture. Now we are going to write a program that calculates the distance between 2 points. In order to do that, we're going to initialize 4 doubles called x1, y1, and x2 and y2. x1 and y1 are corresponding to the coordinates of the first point, and x2 and y2 are corresponding to the coordinates of the second point. So we are going to show the user this text saying that enter coordinates of the first point, x1 and y1. And then using cin, we are going to store x and y accordingly, x1 and y1. Then we are going to again show the user enter the coordinates of the second point, and the user is going to enter two numbers, and x2 and y2 is then stored using cin syntax and keyword in C++. In order to write down the formula for computing distance between 2 points, we need to include the CMAF library function in C++ in the header. So please make sure that you're including this header in your code. And then we're going to simply type down the formula. So it is a well-known formula that is going to compute the square root of the x2 minus x1 to the power of 2. This is the first part of the formula, plus the y2 minus y1 to the power of 2. So after doing these two parts calculation, the output is going to be added to each other, and then we are going to calculate the square root. So for example, if x1 equals 5 and x2 and y1 equals 2, for example, and x2 equals 10, y2 equals 5, for example, we are going to have this formula to be something like this: x2 minus x1, meaning that 10 minus 5 to the power of 2 plus y2 5 minus 2 to the power of 2, and all of it we're going to have a square root. So when we do the calculation, we are going to have 10 minus 5 will be 5, 5 to the power of 2 will be 25, plus then we are going to have 5 minus 2 is 3, and 3 to the power of 2 will be 9, and then we are going to have the sqrt of 34, and then the library function is going to calculate the square root of 34 for us. So this is how basically the steps is going through, but the important thing is to include the CMAF library function and to know how the PO function is working. So the PO function is going to have two arguments, the left-hand side and the right-hand side, and they are separated by a comma. So the left-hand side, you put the main number, and on the right-hand side, you're going to put the power. For example, if I type down PO 5 and 3, it is going to calculate number 5 to the power of 3. It means that number 5 is going to be calculated like this. So this is how the PO function is working, and also the square root is simply just doing the square root using this library function. So let me just compile and see the code. And I'm going to enter the same numbers here. So x1, so it says enter coordinates of the first point, enter coordinates of the first point, x and y, x1 and y1. So x1, I'm going to, because we are first storing the first number in x1 and the second number in y1. So the x1 equals 5, and then I would say y1 equals 2. Then it shows the message saying that enter coordinates of the second point, and the second point, the x2 is 10 and y2 is 5, and it is mentioning that the distance between the 2 points is 5.83. So this is basically how this code is working. You see that we can write very useful and practical codes even with very basic knowledge of C++. And please go ahead and do the exercise yourself, because it may look easy, but there are many parts that you need to be careful about, and you need to do the errors and improve from there. Thank you for watching. Hello everyone, welcome to another lecture. In today's lecture, we are going to write a program that generates a number between 1 and 100 and let the user guess the number. In order to do that, we need to include two library functions. First, a ctime, and the other one is cstdlib. So make sure that you include these two. These are basically needed for generating a random number in C++. First, we need to know how to generate a random number. So in order to do that, we initialize the random number, generating, using the current time as a seed using this line. And then we are generating an integer between 1 and 100 and assigning it to the integer target. And the formula for this right-hand side is like this. So if you would like to have something between 1 and 100, you're going to have the max minus min plus 1, which in our case is 100 minus 1 plus 1, which will be 100, which is written here, plus the minimum, which is 1. But if you're going to have, for example, a random number between 20 and 30, you're going to have 30 minus 20 plus 1, then plus 20. Okay, and 30 minus 20 will be 10 plus 1 will be 11. So the formula for having a random number being generated between 20 and 30 will be like this. Okay, so depending on what you want, the range, you can simply choose it using this formula. Then we are going to initialize an integer number called guess, and the user's input is going to be stored in this integer. And then we are asking the user guess a number between 1 and 100. After that, we are going to define an infinite loop, so a while loop that is infinite because the condition for this while loop is true. So it is going to repetitively continue this loop until we break. Okay? Then when we are entering the loop, we are storing whatever the user is entering, and we are simply having an if-else condition here. So if the number that the user entered is lower than the generated number, simply sign that it's too low, try again. And if the number that the user entered is larger than target, it says it is too high, try again. And otherwise, if they are equal, means the else condition, because if guess is neither lower than target nor larger than target, it is going to be equal to target. So in this condition, say that congratulations, you guessed the number. So let me run the code once to see how it works. So guess a number between 1 and 100. So I'm going to write down 50. It says too high. I would go with 25. Too high. I would go with 13. Too low. I would say 20. Too high. 18. I would say then 15. It's too low. 16. It's too low. 17. So it says, congratulations, you guessed the number. You see, it was an infinite loop. So as long as I was not guessing the correct number, it was asking me again and again to enter a number. And when everything equals, when my number is equal to the generated number, it is going to break. And when it is breaking, it is getting out of this infinite loop here. So this time the number was 17, the generated number. So when I recompile, it's a new number. So I would say 50, it says too high, 25, too low. I would say 40, too high, 35, too low, 37, too high, probably 36. Okay, and it generated a new number that is 36. Okay, and it says, congratulations, you guessed the number. However, if you don't consider this line of code, which initializes the random number generator using the current time as a seed, we will see that the number is not going to be generated in every run, and it is going to be one fixed number. So when I type 50, it says too high. If I type 36, it's too low. I would say 40, too low, 45, too high, 41, 42. So now the number is 42. If I compile again and I type down 42, it says you guessed the correct number. So I recompile again, I type 42, congratulations, you guessed the correct number. So it is important to include this line of code. So every time that you run, it, it provides a new generated number. So if I run now, it should be different. You see, it is too high. So I go with 20, it is still too high, 10, 15, too low, 70, 17. Okay, now it says, congratulations, you guessed the number correctly. So, and you see it is not 17 anymore. it is saying that it is too low when I type 17. So 50 too low, 75 too high, I would say 60 too low, 65 too low, 66, 67, 68, 69, and 70, 71, 72, 73. Okay, 73 is the number. So you guessed the number. So this is how we can generate a number between any given range and start um, letting the user to guess the the output, the generated number. And also you can go even further and let the user to choose only 3 times. So to guess only for 3 times. If they guess in the first 3 rounds, you give them a prize. Otherwise, you would say no, you lost, etc. So this is basically how it works with many machines that are for entertainment out there. Thank you for watching. Hello everyone, welcome back. In this lecture, we are going to write a program to calculate the factorial of a given number using a for loop. In order to do that, we do all the calculation in another function that is called factorial. And in the main function, we are just going to call the factorial function to do the calculation for us. But before that, we initialize and declare one integer called number. We'll let the user to choose the value for this number as the input, and whatever the user is going to enter, we're going to store it using cin keyword and or syntax in C++. And then we're going to show this message in the terminal saying that the factorial of number that is entered, for example, if the user says the factorial of number 5, it is going to show that the factorial of 5 is, and then it is going to basically call the function. So a function is having 3 parts. The main part is this part that is having the name of the function. So the name of this function is factorial. And before that, we are having the type of function. So it says that the output type of this function is going to be an integer. Therefore, when there is an integer here, we expect that this function is going to return an integer value in the output. So it is returning the result, and result is an integer declared initially here. And there are some calculation done about the result here that we're going to discuss. And then the third part of a function is the argument, which is in the parentheses. So one input or argument is allowed for this function, which is of type integer. So when we are willing to call a function, we are typing down the name of the function, and in the parentheses, we are going to pass the argument because it requires an argument to be passed. We are going to pass the argument, and we are going to pass the argument here that is number. So if the user wants to do calculation for the factorial of number 5, this 5 is going to be passed here. Then, when we're calling this function, and this part of the code is going to be executed. So it is going to initialize one integer called result to be set to 1. And then we are going to have a for loop. The loop is going to start from 1, and it is going to be repeated as long as I is lower than or equal to n. And then we are going to have the calculation over the result. So basically this line means this equals result times I. So another form to write this equation is to write this equation. It means that whatever the value of the result is already there, make it multiplied by I and then store it in result. So let me run the code first and show you how things are working here. So let me give you an example first, and then we are going to run the code. So if the user is going to enter the number to be, for example, 5, okay? Imagine that the user is going to enter the number 5. So the user wants the program to calculate the factorial 5 for it. So basically, we are going to call the function with the number 5. It is going to initialize the result to be 1. And then in the first round, when I equals 1, because I starts from 1, and it is going to be continue until I is lower than or equal 5. So, and here, when I equals 1, it is going to have this function, this line of code, meaning that result equals 1 times 1. Why? So the first one is this one because we initialized the result to be 1. So this result is 1. Then it is going to be multiplied by 1. Why? Because it's a multiplication to I and I equals 1. So basically result is going to get the value 1 again. Then I is increased to value 2. We have the result equals to 1 times 2. It means that result will be 2. Why here it is also 1 again? Because previously we calculated result to be equal to 1 and I equals 2 now. So we are having the multiplication by 2. So result equals 2. Then we are having I equals 3, for example, result equals 2 times 3. Why 2? Because the formula is result multiplied by I. So the result from previous step was 2 times 3, which is the value of the I. So it is going to calculate it to be, for example, result to be 6. Then I equals 4, then I equals 5. So let me run. If I say 5, it is going to say the factorial of 5 is 120. So when I equals 4, we are having 6 times 4, meaning that result will be 24, and 6 comes from the previously calculated result multiplied by 4, which is the value of I. So it is 25. And finally, when I equals 5, result will be equal to 25 times 5. This is going to be 120, which is the number that we saw here. So basically, using a function can help us to calculate the factorial of a given number. So if we would like to have the factorial of 3, it is going to say the factorial of 3 is 6. If I recompile again and say that the factorial of 10, it is going to do the calculation for the factorial of 10. So it is going to be 3,628,800. So this is the factorial of 10, for example. And please go ahead and do this exercise because we are reviewing in this simple exercise, we are reviewing how to get and store an input from the user, how to call a function, and everything about a function almost is being reviewed because the output, the argument of a function, the name of the function, and it is going to return an integer value. So it is basically returning an integer value. So here we are calling the function and in return it is giving us the result value here, the result integer. And then we are also reviewing how a for loop works in C++. Thank you for watching. Hello everyone, welcome to another lecture. In this video, we would like to write a program to check if a number is prime using a Boolean flag. So let us define the prime number first. So a prime number is a number that is greater than 1 and has exactly two distinct divisors. So it can be 1 and itself. For example, number 20 has many divisors, and the divisors are
1, 2, 4, 5, 10, and 20. It means that when 20 is divided by either of these numbers, like it is divided by 20 or it is divided by 10, it can be divided by, for example, 5, etc. When number 20 is divided by any of these divisors, the remainder would be 0. So it is not a prime number because a prime number is only divisible by 1 and itself. However, when we are going to discuss the divisors of 11 and of number 11, we see that it is only divisible by 1 and itself, which is 11. This means that 11 is a prime number. So now we would like to write a program to check if a number is a prime or not using a Boolean flag. To do that, we wrote a code here, but before doing anything, let me run the code first and see how it works. Then we are going to analyze the code step by step. So when I run, it asks me to enter a number. I say 15. It says that 15 is not a prime number. Let me run again. I say 20. It says 20 is not a prime number. I say 11. 11 is a prime number. So basically, we have a program that is asking the user to enter a number, and the number is stored somewhere in the memory. Then it checks to see if the entered number is actually a prime number or not. So to do that, we have one main function here and another function to check the number to see if it's prime or not. So in the int main function, we're basically having, for example, an integer called number that is declared here. And then we are asking the user to enter a number using cout. And then using cin, we are storing whatever the user is entering in the number. Okay? Then we are having one condition here. So the if else condition here is checking to see if the number is prime, go and do this action, and otherwise, meaning that if it's not a prime, go and do this action. Okay? But how is it checking to see if the number is prime or not? To see that, it is calling a function called isPrime and passing number as the argument. So when we go up, we see that we have a function here called isPrime. It is of Boolean type. It means that it returns a Boolean, either true or false. It is going to return. And the argument is integer type. So basically, when we are having this condition in the parentheses, it means that either the result of this function is true or false, because it is going to return either true or false because it's of Boolean type. If it says that it's true, it means that this condition is true and this action is going to be performed, saying that the entered number is a prime number. And if it returns false here, this condition is not going to pass and it is going to enter the else part, and it is going to print that the entered number is not a prime. But let's check and see how we are checking to find out if a number is prime or not. To do that, we are initializing one Boolean called prime flag, and by default it is set to true. And in order to check and see if the entered number is divisible by other numbers or not, we are going to write a for loop starting from 2, because for sure any number is divisible by 1. So we are going to start from 2 and we are going to continue as long as I is lower than the entered number by the user, which is num here. And when we are going to iterate over all the numbers from 2 until we reach the entered number, until we are lower than the entered number, we are going to check if that number that the user entered, is divided by I, which is our initialized number here starting from 2, and its remainder equals 0, it means that it is divisible by a number. Okay, and if this happened, just put the false to the prime flag here, which was by default true, and break, meaning that get out of this loop and return the value of prime flag. So let me just make an example here. So we entered the number 11. So the user entered number 11. So number equals 11 here. Okay. And we are checking here in this if condition, we are checking if is prime 11 because we are passing this number as the argument of the is prime function. And when we are calling the function like this, using this line, we're calling the function like this to check if this function with this argument is going to return a true value for us or a false value. By default, it is true, and it checks to see if in certain conditions it becomes false or not. But let's go up and see. So the user entered 11. So here num equals 11, and I is going to start from 2, and it is going to be 3, 4, 5, etc. until 10. Why not 11? Because 11 is not lower than 11. So the maximum number that the I can get is 10 because 10 is lower than 11. Okay, so we are going to iterate from 2 to 10 for different values of I and check if 11 is going to be divided by 2 and its remainder equals 0 or not. So in the first iteration, for example, when I equals 1 equals 2 and num equals 11, we are basically in this if condition here, in this part, we are basically saying that 11, if 11 is divided by 2 and its remainder equals 0, then if this is true and if this happen, just put the prime flag set to be false and then break. Okay, and then break. But we know that if 11 is divided by 2, its remainder is not going to be equal to 0. Therefore, it is not going to enter this condition, this part. So it is going to it is not going to enter this part, so it is going to go up again and increase the value of I by 1 value. So I now equals 3. I equals 3, and it says num is, it is a fixed number, so it is 11. So we are checking to see if 11 divided by 3 equals 0. It means that prime flag has to be set to false and then break. Okay, then break. But we know that if 11 is divided by 3, its remainder is not going to be equal to 0. Therefore, this condition is not passed. Therefore, it is not going to enter this if condition, and it is going to go up again and increase the value of I. So in the next iteration, I equals 4, and it is going to continue until I equals 10. And in neither of these situations, 11 is not divisible by any of these numbers because 11 is a prime number. So this is why it is not going to enter this if condition in any case. So we make sure that 11 is a prime number, and when we found out that it's a prime number, it is going to, in the end of the function, when I equals 10, the last check will be if 11 divided by 10, its remainder equals 0. And this is the last time that it enters this for loop, and it is going to check this if condition here. So in this part, it is going to not enter this if condition again because this part is not true, so it is not going to enter this part. And this for loop is also finished, and by default the prime flag was set to be true, so it is going to return prime flag, which is true. And therefore when that part is going to return true, this part will become true, and this if condition is true now, and we are going to enter this part of the code, which means that we are going to enter that 11 is a prime number. However, if we, for example, number 20 here, the user enters 20, so imagine that it is 20, and I is going to start from 0 and goes up until 20, 19. And when we are having different, like when I equals 2, it means that, okay, I equals 2, we have the number 20. So 20, if it is divided by 2 and its remainder equals 0, which is true because 20 divided by 2, the result is 10 and the remainder is 0. So set the prime flag in this line to be false and then break. It means that we found one divisor for the number 20 that is neither itself nor the number 1. So break because it is not a prime number. So it is going to set false here. It is going to get out of this and out of this part. Okay, out of this part, sorry, out of this part. And then it goes to check again, and when it is set to false, it is going to return the false value here. And when it is going to return the false value here, this part is not going to pass because it is going to pass only if it's true. And when it's not true, it is going to enter this part, and it is going to mention that, okay, this number is not a prime number. So let me explain it one more time. So if the number is like, let me enter another number. So if the user enters number, for example, 10, number equals 10. If the user enters 10 and it is 10 here, and number is 10, for example, now, so I is going to start from 2 and it is going to go up until 9. And when 10 is divided by 2 in the first round of this for loop iteration, its remainder is going to be equal to 0. So it means that this condition is passed, so it is going to enter this part. And when it enters this part, it is going to set false to the prime flag. When it is setting false to the prime flag, it is going to break and it is going to return the false value for us. Why? Because we found a divisor for our entered number, and the divisor is neither 1 nor the number itself, meaning that it's not a prime number. So this is basically how we're going to understand it through this block of code. Thank you for watching. Hello everyone, welcome to another lecture. In today's lecture, we would like to write a program that converts a temperature from Celsius to Fahrenheit or vice versa. So let me first run the code and see how it works, and then we're going to dive deep into the details. So when I compile, it shows me this message saying that temperature converter. First, Celsius to Fahrenheit, to Fahrenheit to Celsius. Enter your choice. So if I enter 1, it means that I'm going to give a Celsius number, a Celsius degree, and get in the end, in the result, its equivalent in Fahrenheit. And if I'm going to enter number 2, it means that I'm going to give a number that is in Fahrenheit, and then I'm going to get in the end from the program the Celsius value. So I'm going to first click 1. So it says enter temperature in Celsius. I would say 180, and when I enter, it says that temperature in Fahrenheit, so its equivalent in Fahrenheit is 356. And when I compile again, now I'm going to choose number 2, and it says enter temperature in Fahrenheit, and I'm going to enter, for example, 300. It is going to give me its equivalent in Celsius, which is approximately 148. So we would like to write a program that converts Celsius to Fahrenheit and vice versa. To do that, we have two functions here to do this conversion for us. Here, these are basically the formulas that you can find on internet. And one main function that I have here I'm going to declare one integer and one double that are called choice and temperature respectively. So the choice will be integer because it's the number that the user is going to enter, either 1 or 2. But the temperature is a double because you may want to enter, for example, the equivalent of Fahrenheit of 185.42 in Celsius is what number? So because it may have some decimals, we're considering a double number here. And then we are asking the user temperature converter. This is the title. Then we are mentioning that with \n we are going to next line, and the first option is Celsius to Fahrenheit, then \n next line again, and then Fahrenheit to Celsius, and then again it goes to the next line and it says enter your choice. And whatever the user is going to enter is going to be stored in the integer choice using cin keyword. And then we are going to check the user entered what. So if the user entered 1, do this part. If the user entered 2, do this part, and we need to write else if because it's another if condition. And otherwise, if the user entered any other number than 1 and 2, just do this part. So if the user enters any number other than 1 and 2, we are going to show this to the user that it's an invalid choice because we asked either 1 or 2. So if the user is going to choose number 1, we are mentioning that again, enter temperature in Celsius. And whatever the user is going to enter is going to be stored in the temperature double. And then we are going to just print out in the terminal saying that temperature in Fahrenheit, so or the equivalent in Fahrenheit, is, and then we are going to call the function that is called Celsius to Fahrenheit, and we are going to pass the temperature argument to this function here. So this function name is Celsius to Fahrenheit. It's of double, so it is going to return a double value for us, and its argument is also a double. So what it does, that is, it is going to do some mathematical operations here, and it is going to return the output. Basically, this is the formula of converting a Celsius number or a Celsius degree to a Fahrenheit number or a Fahrenheit degree. Basically, we have the Celsius degree here multiplied by 9 divided by 5 in parentheses, and the result of this parenthesis is going to be added to number 32. And then when this calculation is done, it is going to return the resulting value here, and it is going to show it in the output. Okay, so and if the user choice was equal to 2, we are going to again show this part to the user saying that enter temperature in Fahrenheit, and we are going to, whatever the user is going to enter is going to be entered to be stored in the temperature here. And then we are saying that, okay, you wanted to convert from Fahrenheit to Celsius. We are saying that your temperature in Celsius, or its equivalent in Celsius, is, and then we are going to call this function with the temperature argument, and this function is Fahrenheit to Celsius. This is the other function. It's of the type double, so it is also going to return a double value for us, and it is going to accept one argument that is doubled here. Basically, it is going to return this part. So after doing the mathematical operations over this part, it is going to return the resulting value. And the formula is like the Fahrenheit degree minus 32. It is going to be multiplied by 5 divided by 9. And when it is doing the calculation, it is going to return the value basically here, and that's it. So let me recompile again. So it says we are here now, enter a temperature converter, we have \n, it goes to next line, Celsius to Fahrenheit, Fahrenheit to Celsius. I'm going to choose 1, and when I choose 1, it is going to enter only this part of the condition. So this part, it is going to show the message saying that enter temperature in Celsius. When I enter, for example, 180, it is going to store my number into the temperature double here. And then it is going to, when I enter, it says temperature in Fahrenheit, which is here. And then it is going to call the function Celsius to Fahrenheit, and pass the temperature number here. So what I entered as a temperature is going to be now double Celsius here. So the Celsius, the entered number, times this number, and then the whole parentheses output is going to be added to 32, and the result will be 356, which is going to be returned by this function and shown exactly here. So if I choose number 2, it is going to enter this part of the loop as we tried once. And if I, for example, enter number 5, it is going to say invalid choice, because we only had the condition if it was equal to 1 or it was equal to 2. Thank you for watching.
Hello everyone, welcome to another lecture. In today's lecture, we would like to write a program to generate the first n numbers in the Fibonacci series. So let me just run the code first to see how the code works and talk about what the Fibonacci series is, and then we're going to dive into the details. So when I run, it asks to enter the number of terms. I'm just going to type down, for example, 7, and it is going to print out the 7 terms of the Fibonacci series. So the first 2 terms in the Fibonacci series is always 0 and 1. And then the third term is computed based on the summation of the first 2 ones. So 0 plus 1 is 1. Then 2 is calculated to be 1 plus 1. Then 3 is calculated to be 1 plus 2. Then 5 is calculated to be 2 plus 3. And 8 is calculated to be 3 plus 5. So any term in Fibonacci series is going to be calculated based on the summation of the 2 previous terms before that number, except for the first 2 ones that are constant. And so basically the program was asking the number of terms. So we mentioned 7, and then it prints the 7
term of this series for us. But how do we do it? So we would like to write a program to generate the first n numbers in the Fibonacci series. To do that, we have one main function and another function that does the mathematical operations part of the work for us. Initially, we're going to declare one integer called n. We're asking the user to enter the number of terms, and we're storing the number that the user is telling us. We are then printing out, okay, if the number that you entered is lower than 1, it's an invalid input. Number must be greater than 0. And then we are saying that, okay, if the number was larger than 1, so it was larger or equal to 1, it is going to call the print Fibonacci function, and it is going to pass the argument, which is the entered number by the user, which is n, to the function. So the name of the function is print Fibonacci. It's a void type, so it is not returning anything. It is just doing some mathematical formulation for us, and it may be printing some stuff for us. And then the argument is of integer type. Here we are initializing int a and b. So a equals 0 and b equals 1, and they are the first two terms in the Fibonacci series. As I showed you before, the first two terms are 0 and 1, so we are declaring the first two terms, and based on them we are going to create the following terms, and we are declaring one integer called next that is going to compute the next term for us. Then we are going to print out Fibonacci series, and a and b are printed here, 0 and 1 are printed directly here. After that, we're going to start a for loop. So the loop is going to start from I equals 3, and this loop is going to continue as long as I is lower than or equal n, and n is the input number of the user. So for example, if the user enters 8, I starts from 3 and is going to continue until I equals 8. For every iteration, we are going to implement this part, and we are starting from 3 because the first two terms that are 0 and 1 are already printed here. So this is why we're starting from 3. So the first two terms, let me just explain with an example here. So if I have the n equal 8, I initially equals 0, and also b equals 1. Okay, and in the first iteration I equals 3. So let me have them all in one line. It would be, I think, easier. So then I equals 3. Okay, so in the first iteration we calculate next. The next was declared here, but it was not initialized. So a plus b will be assigned to next. So next is a plus b. It means that 0 plus 1. It means that next equals 1. And then we are printing out the next value and then 1 space. So it means that initially we printed out this part. So we printed out this part. We had this part. So A and B were already printed, meaning that 0 and 1 as the Fibonacci series terms, they were already printed here. Okay, and then we calculated the next to be a plus b, which is 0 plus 1, and we printed out next using this line with, and then one space afterwards. So therefore, next is printed here. After that, after next is printed here, we are assigning B to A. So now B equals 1. When we are assigning B to A, means that it means that A now equals to 1, and then next is assigned to B. Next was also 1, so B is now 1. We did this line of code because if we want to calculate the fourth term here, we have the first term, second term, the first term, second term, and the third term here. And when we want to calculate the fourth term, we need to know the amount of A plus B. And A plus B is now 1 and 1. Previously, A was 0 and B was 1. Now A is 0 and B is 1. Why? Because B was 1 and assigned to B to A, and the value of next, which was already 1, we calculated here, is assigned to B. So now, instead of having A equals 0 and B equals 1, we are having A equals 1 and B equals 1. Okay? After that, we are going up again, and I is increased to be 4. Now that I equals 4, we are calculating the next again. So next equals A plus B in this line. It means that A is 1 and B is 1. So now next equals 2. We calculate the next here, and then we are going to print out this line, which is going to be the next term. And now next is 2. So 2 is now printed here. And then we are again assigning B to A. So B is 1 and we are assigning it to A. So A still equals 1. And then we are assigning next to B. So B is 2 and next is 2 and B was 1. So when next is assigned to B, B equals 2. So we did that. Why? Because in the next iteration, we need to calculate the next term, and the next term is calculated as the summation of A and B. So now A is 1 and B is 2, so we can calculate the next term of the Fibonacci series. So then I equals 5, because we go up again and we increase the I. So I equals 5, we enter this for loop one more time. So next equals A plus B. It means that 1 plus 2, because A is 1 and B is 2. So A is 1 and B is 2. We are going to calculate the next term. So it means that next equals 3. And when we understand that next is, we calculate the next, we are going to print out the next here. So this term will be 3 now. And then we are going to reassign A and B. So the value of B is assigned to A. The value of B was 2 is assigned to A. So A is moving one place forward. So now A is 2. And then next is assigned to B. So next was 3 and now B is 3. Again, we are doing this because we would like to keep track of the summation of the last 2 terms in order to calculate the next term in the Fibonacci series. So when we do that, this loop is finished. This iteration of the loop is finished. We go up again and I equals 6 now. So we have next equals A plus B it means that we are having 2 plus 3 because we have 2 here and 3 here, and we are having next equals 5. When we are calculating the next, we are going to print the next in this line. So the next one is 5, which makes sense because 2 plus 3 is 5. Then we are going to reassign A to be B. So B was 3 and now it is assigned to A. So A is 3 now and B equals 5. So equals next. So next is 5. 5 is assigned to B. And then we go for the next iteration. I equals 7. We are having next equals A plus B equals 3 plus 5. It means that next equals 8. It means that here the next one is 8. Then we are printing out the next here, which is 8 here, and then we are reassigning A and B. So A is the previous B here is B, and then B equals 8. So after doing that, I equals 8 because we mentioned that if the user enter to print out the first, for example, 8 terms of the Fibonacci series. So next equals A plus B, meaning that 5 plus 8, we know it from the previous line. Then next equals 8 plus 5, it means it is 13 now, for example. And then we are reassigning A and B. Before that, we are printing 13 here. And then we are reassigning A and B. So B is assigned to A. So whatever the value of B was is now is assigned to A. So A equals 8 and B equals 13 because next is assigned to B and next is 13 and it is assigned to B. So B is 13 now. And then this loop is finished. It was the last iteration because I was equal to 8 and it was supposed to repeat this for loop as long as I is lower than or equal to n, and n was 8. We assume that the user entered number 8. So I equals 8. This is the last time we entered this for loop, and then in the next iteration, because I is increased by one value, so I equals 9, and 9 is not lower than or equal to n, which is 8. Therefore, this condition is not passed, and then this loop is not executed. After that, we are simply just having the handle keyword here, which gives the function, the syntax, the command to go to the next line, and that's it. So this is how we are printing out the terms in the Fibonacci. So here, if I run the code one more time, you see that it says enter the number of terms. I would say 8. And when we say 8, is it lower than 1? No. So it is going to go to the else part. It is going to call the print Fibonacci function and pass the n argument. And n is the 8 number that we entered here. Because whatever we enter, it is going to be stored in n. When we do that, first A and B is printed. So 0 and 1 is first printed out. Then it enters the loop, it does the calculation, and one by one it prints all the terms of the Fibonacci series until we reach the 8th term, and then it stops there. So as you see here, we're having the same Fibonacci series here and there because we did the correct calculation. Thank you for watching.
Hello everyone, welcome to another lecture. In this lecture, we are going to write a program that calculates the average grade of a student from 3 test scores and determines the final grade. In order to do that, we are going to declare 4 variables of float type. The first 3 variables are the ones that we are going to store the score from the user, and the fourth one, which is average, we are going to calculate the average among the first three. So we show the message to the user saying that enter the grades for 3 tests, and we are storing the data that the user is entering as to be test 1, test 2, and test 3 scores. When we have the 3 scores from the user, we're going to calculate the average using this formula. So we are having the summation of test 1, test 2, and test 3 divided by 3. Based on this, we can calculate the average. And we are simply just showing the average in the output. And based on the output of the average, we can have different output as well. For example, if the average is larger than 90, larger than or equal to 90, we can have the grade A. If average is between 80 and 90, we are going to have grade B. If it is between 70 and 80, it is grade C. If it is between 60 and 70, it is grade D. And if it's any other number, it is going to show grade F. So let me run the code once. So it says enter grades for 3 tests. So I would say 95, 80. Oops, sorry, I made a mistake. So let me run again. 95, 80, 75. So it says the average grade is 83. So, and the final grade is B. So here, when I run the code, the first line is this line. So it says enter the grade for 3 tests. So this is the line. So then I started entering 95, 80, and 75. And these 3 numbers basically are stored in test 1, test 2, and test 3 respectively. Then with this code, we are calculating the average of these 3 numbers. And after that, we are having the message average grade. So cout average grade. And this is the average grade. And it is printed out here, the calculated average, which is 83. So depending on the number of the average, we can have different output, further output as well. So using this if-else condition, we show that the average, if it's between 80 and 90, the final grade is B. So in our case, it is approximately 83. So the final grade is B because 83 falls in this condition because it is between 80 and 90. So let me run the code one more time. So if we have, for example, 90, 92, and 95, now it says the average is 92 and the final grade is A. And the reason why is that because the average is 92, so it is larger than 90, so we're going to have the final grade A. So using this exercise, we reviewed the if-else conditions here, so how the output would be different if the conditions are different. And also we reviewed how to do one mathematical operations here and how to read and store data entered by the user from the terminal. Thank you for watching.
Hello everyone, welcome back. In today's video, we would like to write a program to create a simple calculator that performs addition, subtraction, multiplication, and division using a switch statement. To do that, we have a function that does these per mathematical operations and performs these operations for us. And then we are having one main function that we are calling the other function that does the work for us. Initially, we declare 2 double numbers, num1 and num2, and we are also declaring one character called OP. So we ask the user to enter the first number, and we store the first number. We ask the user to enter the second number, then we store the second number. Then we are asking the user to enter an operator, meaning that they can have the addition, the subtraction, multiplication, or the division here, and we are storing it whatever the user is mentioning. But please note that the first two, because they were numbers, we stored them in double. But the last one we are storing them in OP, which is a character, because it's a character and it's not a number. Okay. So, and then we are declaring and initializing a result double that is going to call the calculate function and pass 3 arguments. So the first number, the second number, and the character that the user entered. By these 3 arguments, we're calling the function, and then the function is going to do the calculation for us, set the result into result. So calculate and obtain the output and put it to result, and then we are going to print out the result. So let me run the code, and then we are going to analyze the code one by one. So enter the first number, I would say 2. Enter the second number, I would say 5. And enter an operator, I would say plus or addition. So it says result 7. So if I have like 20, the second number is 10. And if I choose division, it is going to give me the result of 2. So when we call the function, you see, let me rerun one more time. So enter the first number, we are here, I would say 20. Then enter the second number, then this part of the code is executed, I would say like 2. And then enter an operator, I would say like subtraction. And then when I enter the subtraction, it is storing it in OP. And then it is calling the calculate function. It does everything, and it is going to print out result. And then this is printed out, which is 18 here. Okay, so when we call this function name is calculate, and it's of double type, so it is going to return a double for us. So as you see, we see the return here. And then it has 3 arguments, each is separated by a comma. So the first 2 are double, and the last one is a character. Then the program asked us to do all of these mathematical operations using a switch statement. We could do it with if-else condition, but they explicitly mentioned to use switch statement. To do that, we have the switch keyword, and then we are going to perform the condition over the character that the user is going to enter. So addition, subtraction, multiplication, or division. Then when the variable is there in the parentheses, in the brackets, we're going to type down in this part the conditions. So the first case, if the user enters addition, return a plus b. So a plus b, the first argument plus the second argument. If the user enters subtraction, return a minus b. If in case the user enters star, return a multiplied by b. And then if the user entered division, first we need to check to see if b is not equal to 0. This part is the condition part, is not equal to 0. This question mark is going to separate the condition from the potential output. Okay, so on the left hand side we have the condition, and on the right hand side we are having the potential answers, potential output, and outputs are separated with colon. So this is first potential output, this is the second potential output. So it says that return something, but before we know that what that something is, we need to check this condition. So if b does not equal 0, return a divided by b, otherwise return 0, because if b equals 0, we cannot do the division. This is why we need to check this condition. So if b does not equal 0, we are going to return the a plus b, the first potential output, which is separated by a colon here. Otherwise, if b equals 0, we are going to return 0. It means that, for example, if the first number is 20 and the second number is 10, 10 is b, and b now b is 10, so 10 is not equal 0, so a divided by b is going to be returned in the output. However, if we are going to enter like the first number is 20 and the second number is 0, it is going to return 0 because it does not pass this condition, because it says b does not equal 0, but we entered the second number to be 0, so it is going to return 0 because it's not possible to divide the number by 0. So this is basically how this works. So when I recompile, I enter the first number 20, I enter the second number 10, and then when I choose the divide, it passes everything to this function and checks the OP, the third argument, which is here. And the OP in our case was a division, so it came here, it checked the condition. So the B, or the second number, was 10, so 10 is not equal to 0, is not equal to 0. So yes, this is true, 10 is not equal to 0, then it is going to do the A divided by B and returning 2 for us. So 20 is divided by 10, it is going to return 2 for us. So this is basically how we can write a function that that works like a simple calculator using a switch statement. Thank you for watching. Hello everyone, welcome back. In this lecture, we would like to write a program to generate and display the multiplication table for a given number. So in order to write a program like that, we need to have a function that does the work for us and have a main function as always. So we are declaring one integer number called number. Then we are printing out to the user saying that enter a number. Then we are reading the number and storing the number from the user. Then we are simply calling the function and we are passing the argument number that was entered by the user to this function. So this function name is print multiplication table. It's of void type, so it's not going to return any value for us. It may do some calculation or doing some prints for us, but it is not going to return any value. And the argument of this function is integer. So basically this function is going to have a for loop starting from I equals to 1, and it is going to continue as long as I is lower than or equal 10. So it is going to print all the multiplication table of a number for us. Basically, we are saying that, okay, cout and then num, which is the entered number by the user, and this is the argument of this function, is printed. Then a multiplication sign is printed because it's in quote. It's in quote, you see. And then I is printed in the, for example, first round, I equals 1. Then equal, then num multiplied by I is printed. So if I want to explain it better, so num is, for example, if the user enters number 5, okay, 5 times, or x, let's say, 1, because I in the first iteration equals 1, I start from 1, equals, then the result of 5 times 1 is printed here, which is 5. Then we have endl, so it goes to next line. Then we have 5 times 2, because in the next iteration I equals 2, equals 10. And then we have 5 times 3 equals 15. Okay, and it is going to continue until I equals 10. When I equals 10, we are having the last row being printed. 5 times 10 equals 50. So basically, this is how we are going to print a multiplication table. So let me run. When I enter 5, it is going to give me a multiplication table of number 5. So basically, it says enter a number, enter a number. I enter one number and it is going to store that number. Then it is going to call the function. So when it calls the function starts from 1, as you see here, and it goes until 10. Okay? And in each iteration, 5 is multiplied by the number of I, and then the result is written here. So 5 is multiplied by the number of I, and the result is written here. Okay? So 5 times 1, as we mentioned here, 5. 5 times 2, 10. 5 times 3, 15. We have it here, and it continues until the last row is 5 times 10, which is 50. Basically, this is how we can write a program to generate and display the multiplication table for any given number. Thank you for watching.
Hello everyone, welcome to another lecture. In today's lecture, we would like to write a program to track the balance of a bank account by tracking an initial amount and allowing a deposit and withdrawals. In order to do that, first we are declaring three variables. They're called balance, deposit, and then withdrawal. So firstly, we are going to ask the user enter initial balance, and then it is stored in balance. And then when we know the balance, the initial money in the bank account, we're going to ask the user enter the deposit money. So if the user would like to deposit some money, they can do that using this line. So we show the message to the user and we are storing whatever that they are entering, and then we are adding this deposit to the initial balance of the bank account. So this line means balance plus deposit. So this line is the equivalent of this line. It means that whatever the new balance is, whatever that is already in balance plus the deposit. And also then we are showing that if the user, for example, would like to withdraw some amount of money, they can do that. We're having the cin keyword in C++ to store what the user is entering. And then we are having the withdrawal money reduced and subtracted from the original balance. So here this line also means balance equals balance minus withdrawal. And finally, we are showing the final balance of the bank account to the user. So let me run the code first, and we will also analyze the code afterwards. So when I run the code, so we are here, enter initial balance. So I would say the initial balance is 0, for example, and I would like to deposit some money in my bank account. So I would say like $500, for example. And here it was the $500, and then here it says enter a withdrawal amount. So I would say I would like to withdraw $100, and the final balance is 400. So basically with this code we can have the initial balance, we can have the deposit of money, and we can have the withdrawal of money, and we calculate the balance of the bank account accordingly. In order to have another example, I would say, for example, the initial balance is 150. I'm going to deposit 50, and I'm going to withdraw, for example, 200, and it says the balance is 0. Why? Because the initial balance was 150. We deposit some money like $50, and total balance is now 200. And then I'm going to withdraw all the 200. So the final balance is 0. So we can also have like I have 100 initial balance. I'm going to deposit 200, and I'm going to withdraw 0, for example. I'm not going to withdraw any money. So the final balance is 300. We see that even with very um, easy and simple examples, we have a practical code here that can resemble the real situation in the world. So basically the bank accounts are working exactly like this simple part of code. So you can see the practicability of these examples that can happen in the real world. Thank you for watching.
Hello everyone, welcome back. In this lecture, we would like to write a program to calculate the body mass index or BMI for a user. To do that, we have one main function and another side function that does the calculation for us. So in the main function, we are declaring two double numbers that are weight and height. We are telling the user, enter your weight in kilogram, and then we are storing the entered number by the user. And we are asking the user to tell your height in meter, and then we are going to store it. And then we are going to declare another double called BMI, and we are going to call the calculate BMI function, which is this function, and we are going to pass two arguments, the weight and the height that were read from the user. So basically the result of this function is assigned to BMI, and then we are printing out the BMI. So basically this function name is calculate BMI, so it's of double type, so it is going to return a double value for us. And there are two arguments in the parentheses for this function, and they are separated by a comma. The first one is weight and the second one is double. So basically this function is going to return the result of this equation. Weight is divided by height times height. So this is how we can calculate the BMI based on the weight and the height of a user. So when it is calculated, it is going to assign the result in this double, and then we are going to print out this double here. Okay, so let me run. If I run the code, it says that enter your weight. I would say, for example, 90 kilograms. Enter your height. For example, I could say 1.82. It says that, okay, your BMI is 27.1706. We could write another one. For example, I could say enter your weight. I would say 100. And then the height, we could say, for example, 1.6. It means that your BMI is around 39. So it's a pretty much high number. So this is basically how we can calculate the BMI given the weight and the height of a user. Thank you for watching.
Hello everyone, welcome to another lecture. In today's lecture, we would like to write a program to check and see whether a number is odd or even. In order to understand if a number is odd or even, we need to know if the number is divided by 2, its remainder equals 0 or not. So if its remainder equals 0, it means that it's an even number. Otherwise, it's an odd number. For example, if we divide 10 by 2, the remainder will be 0. Okay, so the result of 10 divided by 2 is 5, and 5 times 2 equals 10. It means that the remainder equals 0. Remainder equals 0. However, if we divide, for example, 11 by 2, the result would be 5 point something. And for example, this 5, if it's multiplied by 2, it will be 10. It's not going to be 11. So it is going to have some remainder, some value. Okay. So it means that number 11 is not an even number. So if we do it for all the even numbers, it makes sense, this rule. So 20 divided by 2, the result would be 10. So 10 times 2 will be 20. meaning that it has no remainder, so remainder equals 0. Or if we do another exercise, for example, if we divide number 13 by 2, the output would be, for example, 6. But if the 6 it is multiplied by 2, the result would be 12 and not 13. So remainder is not equal 0, meaning that 13 is an odd number. Okay, we do this checking also in the code. So we are first declaring one number, and then we are asking the user to enter one number, and we are storing the number, and that number is divided by 2, and we are checking to see number modulo 2. It means that when we are using a modulo sign, means that if the number is divided by 2, its remainder equals 0. If we would like to check the division number, we're going to have this sign, but modulo means that if the number is divided by 2 and its remainder equals 0, this condition in the parentheses is discussing exactly this sentence that I mentioned. And then we are printing out if this makes sense, if this condition is passed, because the remainder of the number divided by 2 equals 0, it means that the number is even, so we are going to print out number and then is even. Otherwise, it is odd. So let me run the code. Enter a number. I would say 20. It says 20 is even because we are saying enter a number here exactly in this line and storing 20. Then it is dividing 20 by 2, and when 2 and 20 is divided by 2, the output is 10. So 10 multiplied by 2 will be exactly 20, so the remainder equals 0. Basically, this is why when the remainder equals 0, it enters this parenthesis condition is passed, and it enters this part, and it is going to mention that 20 is even. So if I enter 13, it says 13 is odd. Why? Because when 13 is divided by 2, its remainder does not equal 0. So it does not pass this condition in the parentheses, and it will enter this part. So it says 13 is an odd number. And also, just for your information, let me print out some part here. So let me just comment this part. So for example, if we have this code, for example, we have int a equals 20, we have int b equals 2, for example, and we are going to see out a divided by b and l. So when I run this code, you will see the output is 10. So a divided by b, 20 divided by 2, the output is 10. Okay, but when I have the modulo sign and I run, it says 0. So a divided by b, its remainder is 0. When you're using the modulo sign, it is going to show you the remainder of the division. Okay, so here is the same thing is happening. So it is showing the remainder of this division. Does the remainder equal 0? If yes, this condition is passed and this line of code is executed. Thank you for watching. Hello everyone, and welcome to another lecture. In today's lecture, we would like to write a program to count the number of words in a sentence entered by the user. In order to do that, we ask the user to enter a sentence, and then we are iterating over the sentence components, and then we are printing out the number of words. So let me run the code first, and then we dive into the details. So when I run the code, I would say this is Reza Shaheen, and I enter. It says number of words 4. So 1, 2, 3, 4. So when I run again, this is C++ practice, I would say project lecture. So when I enter, it says 5. So 1, 2, 3, 4, 5. But how does it work? Firstly, we are initializing one string, and then we are initializing one integer called word count equal to 1. Then we are asking the user to enter a sentence. However, we are reading the sentence using this line of code. Previously, we learned that we can read, for example, we can see out, enter your, for example, number, and then we had see in to, for example, store the data int a, okay? Previously, we were using this keyword to store anything. But using getLine means that when we have more than one word, we must use getLine because cin cannot understand more than one word. For example, if I have string a, enter your sentence. So let me just comment this part. I'm going to say enter your sentence, and I'm going to read the sentence and store the sentence using only cin. So when I see out a and l, you will see that the result is not what we would like to have. So let me run. So enter your sentence. I would say this is Reza, and it is only returning the first part. So using cin is not very good for a sentence because it is going to understand the first part, and when you have a space, it simply stops and it does not go further. So this is why in our code here, we are using the getLine keyword to store a sentence. In order to have a sentence being stored, we need to have the getLine syntax, and then within the parentheses we have two arguments separated by a comma. The first part is always the cin, and the second part is the string, for example, that we would like to store whatever the user enters in. So we initialize the sentence here as a string, and then we are storing everything in the sentence here when we are putting it as the second argument. And then we are having one for loop here that the character C is going to iterate over the sentence string, and if C in the meantime equals any space, it is going to increment the value of the word count, which is already initialized to 1, and then it is going to print out the output. So let me run the code one more time. I would say this is Reza Shahin. It says number of words 4. So 1, 2, 3, 4. It is correct. So why we are starting from 1? Because any sentence would have at least one word. So we start from 1. And then while we are iterating over the, when we are iterating over the sentence string, which is this is Reza Shahin, we are going to increment the value of this word count one by one if in the iteration we see any space. Okay, so we start from here, and when we start from here, we are already having the word count equal to 1. Then we are seeing this space, we are saying 2. Then we see this space, then we are saying 3 words, and then we are saying we see that this space exists also, so we are saying we have 4 words. Basically, any space is counted as to be a word here, because between any words we are going to have a space already. So we have one word initialized, like here, and then any space that we see, we increment the value to understand how many words do we have. This is the policy to count the number of words. So I will explain one more time. So we are initializing word count as to be 1, because in any sentence we are going to have at least one word. Okay, so it is equal to 1, and then we are iterating over this string this sentence, and any space in this sentence is making the word count to be incremented by 1. So initially it is 1. It sees the first space, meaning that we are having a space to separate a word from another. Okay, so this is why when we see a space, we are incrementing the word count. So initially it was 1, now it is 2 because it saw this space. Then it saw this space, so it is 3 now, and then it saw this space, so it is 4 now. So any space is counted to be number of words here. And how do we check that? We are having a for loop here. A character C is iterating over the string sentence, and if C equals a space, it is going to increment the value of word count by 1 value. Thank you for watching. Hello everyone. We would like to write a program to calculate the power of a number. For example, if 3 to the power of 2 means that 3 times 3 equals 9. Or 2 to the power of 3 means 2 times 2 times 2, which equals 8, for example. To calculate this in C++, we can use one library function called POW or POW. And in order to use that, we need to include the header called CMath. To do that, we are asking the base number and the exp, which is the power of the number. And then we are having the message showing to the user saying that enter the base and exponent. So the base and exponent is mentioned, and then we're simply printing out the result using this part. So in this function POW, or we have POW, we can have two arguments. The first argument is the base argument, and the second argument is the exponent argument. For example, when we would like to calculate 3 to the power of 2, which is 9, we need to have something like this: POW 3 and 2. Okay, when we are going to have, for example, 5 to the power of, for example, 6, we can have POW 5 and 6. Okay, so the left side is the base number, and the right side is the exponent. Okay, and basically it is going to do all the calculation for us. It is an already predefined function in C++, so it made our life much easier. So let me run the code. So when I run the code, it says enter base and exponent. I would say the base is 5, the exponent is, for example, 2. It is going to give us 25, which is the result of 5 times 5. So if I say, for example, 5 and 3, it is going to return 125. Basically, using the library function POW, we can calculate a number to when a number is going to a power of another number. So for example, to calculate the power of a number. Thank you for watching. Hello everyone, welcome back. In today's lecture, we would like to write a program that calculates the age of a person based on their birth year. To do that, we first declare three integers: birth year, current year, and the age. Then we are asking the user, give us the birth year of yours, then give us the current year, and then calculate the age. So age will be equal to current year minus the birth year, and we're simply showing the result in the output. So let me run. So it says enter your birth year, I would say 1992. Enter the current year, we are in 2024. For example, it says your age is 32. Let me just have one C out and del here, so it will be nicer. So enter your birth year 1992, current year 2024. So your age is 32. So when I added this endl, this part went to the next line, so it is easier to read the output for us, the last line of the output. So your age is 32. Basically, using this code, we can calculate the year of the current age based on the birth year and the current year. Thank you. Hello everyone, welcome to another lecture. We would like to write a program to convert an amount between currencies using a fixed exchange rate. To do that, first I run the code. So it says enter amount in US dollar, I would say 200. And it says amount in euro is 170. So in order to have this part in the next line, I'm going to add one cout endl. So cout endl. Okay, so when I say, for example, 200 USD, it says the amount in euro is 170. To do that, we declare two doubles, that is the amount and the converted amount, and we are having one fixed exchange rate, which is just an assumption here. It may not be the correct number here. It is just an assumption. You can check the current rate, basically in Google. So here I assume it is 0.85. Then we are asking the user to enter amount in US dollar. The user is going to enter it and we are going to store it. Then we are going to calculate the converted amount. So the converted amount is the amount multiplied by the exchange rate. So 200, for example, if I enter 200, 200 is going to be multiplied with 0.85. So the converted amount in euro, the equivalent in euro, is going to be stored here. And we are simply couting the amount in euro is whatever. So if I, for example, say 500 USD, it says it is 425 euros, the converted amount. So this is how basically we can use C++ to convert one currency to another. Thank you for watching. Hello everyone, welcome back. In today's lecture, we would like to write a program to swap two numbers using call by reference. In order to do that, we are going to declare two variables called x and y, and then we are going to ask a user to enter two numbers, and the numbers that the user is entering is stored in x and y. Then in order to perform the swapping operations, we are calling a function called swap, and we are passing as arguments x and y. So here, the name of the function is swap. It's a void type, so it's not going to return anything. And it has two arguments, the first one and the second one. Here, they are separated by a comma. And you see that both of them are of type integers. And we are having the call by reference. How do we know that? Because we are having the and sign. When we are having the and sign in the arguments of a function, it means that this function is going to have access to the reference of these two variables, meaning that it can directly find the address in which these two variables are stored in memory, so it can directly make some changes into the values of these two variables. So we call the swap function and passing x and y, and we would like to simply swap them. In order to swap them, let me first run the code, then we are going to dive into the details. So enter two numbers. I would say 10 and 20. It says x is 10 and y is 20. Let me just enter one endl here. Cout endl. And let me just have this part here, enter x, so it is separated. It would be easier for you to understand. Then cin x, cout, enter
enter y and del, then cin y. So when I separate them, it's easier for you to follow what I'm teaching. So here we're saying enter x, I would say 10, enter y, I would say 20. And after swapping, it says x equals 20, y equals 10. So initially x was 10 and y was 20. Now x is 10 and x is 20 and y is 10. Okay, so we swap the values. To do that, let me just assume that x equals, let me just assume here, x equals 10, y equals 20 in the input. We know that in the input, as the input, the user is going to choose that. So therefore, initially, a equals 10 and b equals 20. Why? Because x is passed as the first argument, and the first argument here is a, therefore a equals 10, which is the value of x. Then y is passed as the second argument, and the second argument is b, so b equals the same value as y. So initially we have a equals 10, b equals 20. Then we are going to have one new variable called temp that we are declaring here, and we are assigning whatever that we have in a to be in temp, sorry. So now temp is 10 because we are assigning a to temp in this line. Then we are assigning b to a, so now a equals 20. So b is 20 and we are assigning b to a, meaning that a equals 20 because b was 20. And then we are having the b equals temp. So we are having the assignment of temp to b. So b equals 10 now. So basically we declared one new variable that is called temp here. We are setting a to temp and we are setting b to a, and then we are having temp to b. You see what I mean? Here we are setting 10 to temp, which is a. Then we are having b to a, which is 20 is set to a. And then the temp is assigned to b. So this way, the swapping is performed very easily. So we have a is going to be in temp, b is going to be in a, and temp is going to be in b. So basically we did the swapping exactly like that. So this is how the swapping is done. So when I run again, enter x, we are having x, enter y, we are having y, and it says after swapping we have x equals 20 and y equals 10. So here enter x, enter y, we are storing x and y, and then we are calling the swap function. So the swap function is called, we are doing the swapping here, and after that we are printing out after swapping exactly this line, x equals 20 and y equals 10. So this is basically how we can swap two variables using a call by reference. Thank you for watching. Hello everyone, welcome to another lecture. In today's lecture, we would like to write a program to calculate the total cost of items in a shopping cart. To do that, first I run the code and then we are analyzing the details. So enter number of items. So I would like to say I bought 2 items. So the price for the first item was $10. The price for the second item was $12. And the program is going to return the total cost. So the total cost is 22. So basically we are asking the user how many items did you buy?
then enter each price of each product one by one, and then it will give us the total cost of our shopping cart. To do that, we have one integer called items, the number of items that we are willing to tell the program that we bought. Then we are having the price double and total double. So the total double is set to be 0 initially. Then we are asking the user enter the number of items that you mentioned that you bought. Then we are having a for loop starting from 1 and until I is equal to item. So the item is the number of items that the user bought. So in case that you bought 2 items, it is going to iterate in this loop 2 times. If you buy 3 items, it is going to iterate 3 times. Why? Because it is going to ask you the price. So when I enter 2 items, it is going to ask the price of item 1 and item 2. So, but if I mention that I bought 3 items, it is going to ask the item 1, item 2, and item 3. Okay? So basically, here this loop is for the case when you're having different items and it is going to ask you different price of each product. So if you buy 5 items, if you mention that you bought 5 items, it is going to show you this message, enter price item 5 times. Okay, so it is going to have a for loop. For example, if you bought 2 items starting from 1 and ends with 2, so it is going to enter price of item, for example, when I equals 1 and then I equals 2, so the item 1 and item 2. So in the first round, when I equals 1, it is saying enter price of item 1. Then you tell the price and total equals total plus price. Then it is asking you enter the price of item 1 in this line. You're going to enter the price, so it is going to store it in the price double. Then this price double is added to the total. So this line of code is equivalent of this line of code. So the new total is the already total plus price. So already total was 0 and price was whatever that we entered here. So in case I mentioned that the price was 10, we're going to have 0 plus 10. So the total equals 10 now. And then when I equals 2, because I had 2 items, enter price of item 2. Then total equals total plus price. So total was already 10 plus the new price of product 2, for example, it is 12. So we are going to have the new total equal to 22. So using this code, we can simply calculate the total amount that we paid for buying like 2 items. For 3 items, it depends on the case and the instance, but this is how it works. Thank you for watching. Hello everyone, welcome to another lecture. We would like to write a program to create a mini quiz game with multiple choice questions. To do that, I would first run the code, then we dive into the details. So the question is, what is 2 plus 2? Option 1, 3, option 2, 4, and option 3, 5. So option 2 is my choice, so I would say 2. Then question 2, what is 3 multiplied by 3? Option 1, 6, option 2, 9, option 3, 12. So I'm going to choose option 2. My choice is option 2. And it says your score is 2 out of 2. So basically, we would like to design this mini quiz that is going to ask certain questions with multiple choices. And then we are going to give the answer and it is going to calculate the score for us. To do that, we initialize 2 integer called answer and a score. And a score is set to be 0. Then we are showing this to the user. Question 1, what is 2 plus 2? And then we are having \n, which helps the compiler to go, which force the compilers to go to next line. Then we are having option 1, 3, then \n, which is going to next line. Then option 2 is 4, \n, next line. Option 3 is 5, and \n, next line. So when I mention next line is like this, when we are having option 1, which is 3, which is this part, and then \n means that the compiler is here now. When we are having \n, it goes to next line and starts writing from this line. So it is having the option 2, which is 4, and then after 4 we are having \n, which forces the user to go to option 3 to be printed in the next line. Okay, so then we are having this, and the user is going to answer. So the answer is stored using cin in the answer variable. And then we are saying if, because we know that the option 2 is the correct answer, if answer equals 2, meaning that if the user entered 2, we're going to increase the score by 1 value. So we're going to increment score. To do that, we simply do it score plus plus. Then we're having the question 2, what is 3 multiplied by 3? Option 1, 6, option 2, 9, option 3, 12. We're going to store the answer again, and if the user is going to choose option 2, which is the correct answer, we are going to increment the value of the score, which was initially set to 0. And finally, we are going to show the score. Your score is, and then score out of 2. So we are having the /2, meaning that we were having 2 questions, for example. So let me run again. So what is 2 plus 2? I would say option 1, which is not the correct answer. Then what is 3 times 3? I would say option 2. So it is going to say your score is 1 out of 2. So this /2 that you see there is exactly this /2 that you see here. And score is calculated based on the correct answer that is shown here. Okay, your score is, and then the score, and then /2. You see that you can have very nice game, very nice and small game in C++ easily, which helps us to proceed and progress in learning in a more convenient and engaging way. Thank you for watching. Hello everyone, welcome back to another video. In today's lecture, we are going to discuss about the continue keyword. In the previous lecture, we learned about the break keyword. So in certain situations, when a condition is met, we just tell the program, stop the execution, break the program, and get out of the, for example, a loop. So here we are going to use continue keyword. In this case, there are some cases that when certain conditions are met within the blocks of code, we tell the program if this condition has met, continue. So just escape this part. Don't execute, don't do anything. If this happened, just escape, okay? So let me illustrate this with an example. We would like to print all the odd numbers between 1 and 10. To do that, we simply write a for loop that starts from 1, and as long as I is lower than or equal 10, and I is going to increase 1 by 1. Then when we have this condition, because when we have this for loop, when we would like to have the odd numbers printed only, we define a condition. So we define a condition saying that if this number is divided by 2 and its remainder, because we are using modulo sign, its remainder equals 0, it means that the number is even. And in this case, just continue. Don't print anything. And if this situation is not the case, then print the I for us. So let me give you an example. So initially, I starts from 1, I equals 1, and 1, when it is divided by 2, its remainder, is it equal to 0 or not? It's not equal to 0. Therefore, it's an odd number. When it's an odd number and it's not equal to
0, it is going to print the I value, which is 1 here, and then print 1 space here. And then it goes up, I equals 2 now. And when I equals 2, it says, okay, 2 divided by 2, its remainder equals 0 or not? Yes, in this case, it is true. Then continue. Just escape this part. Don't do anything. It will go up again. So it will increase the value of I by another one value. So I is now 3. 3 divided by 2, its remainder, is it equal to 0 or not? It is not equal to 0. Then this condition is not passed. So this part is escaped, and it's going to print the I here, which is number 3, and then 1 space. Next one, I equals 4, because this loop is going to continue until I equals 10. So I equals 4 enters the loop. 4 divided by 2, its remainder, is it equal to 0? Yes, it's going to enter this condition then it's going to continue, just escape, like nothing happened. Go back up again and increase the value of I by another one value, and then in the next run, I equals 5. Okay, so let me run the code. Okay, great. So we are printing odd numbers between 1 and 10. It is printing odd numbers between 1 and 10. Then there is a for loop here, and then it is having this condition: if there are even numbers, don't print them, just escape. So just continue like nothing happened. However, when the numbers are odd, because if numbers remainder, when the numbers are divided by 2, their remainder does not equal 0, it means that they are odd numbers. In this case, just print them. So all the odd numbers between 1 and 10 are printed here. So this is basically how we are going to use continue keyword. It's a very useful keyword, and it's a very easy example of how we can use them. There are different ways to execute this program and implement this program. For example, we could write simply, instead of writing this condition here, that to detect the even numbers, we could say if the number is divided by 2 and its remainder is not equal to 0, then here just simply print I. Okay, we could also have that cout I, oops, sorry, cout I and L. Okay, we could do that. This we could also do. So when you would like to implement a program, there are different ways to do that. It's up to you how to do your coding, but usually we try to code in a way that is efficient, and that we program in a way that we increase the program readability. So if the code is passed to the next developer, they can also easily understand what you were doing during your code. So there are different ways to do one task. Here we could simply use continue keyword and do what we wanted to do. Thank you for watching. Try to practice this coding exercise. We're going to use continue and break keywords later on this course. Thank you. Hello everyone. Welcome to this lecture. In today's lecture, we are going to talk about a reserved keyword for C++ that is called break. So basically, when we would like to exit the loop in certain conditions, we're going to use this keyword. Or when a certain condition is met by the program, we just want to tell the program, if this condition is met, okay, stop the execution and just exit the program. So in these cases, we are going to use this break keyword. Here I have an example to illustrate the usage of the break keyword. So we would like to write a program that gets input numbers from the user, and this getting input numbers from the user is going to continue until the user enters -1. When the user enters the number -1, we are going to break the program. It means that the program is going to continuously ask the user enter a number, enter a number, enter a number, and the user is going to continuously enter different numbers. However, when the user enters -1, it is a sign for us based on this program. It is a sign for us that, okay, the condition is met. Let's exit the program. Let's stop the execution. Therefore, we use the break keyword. Let me illustrate it with an example. So here we are initializing an integer. We are declaring it. And then we are telling the user enter numbers and type -1 in case you would like to stop. And then we are writing an infinite loop here, which is using while loop and the condition is true. So as long as the condition is true, it is going to repeat this while loop. And in the while loop, we are going to store the number that is given by the user. And if the entered number by the user equals -1, break the program. We use the break. So exit the loop if -1 is entered. And if not, if any other number is entered, just print out the number that entered by the user. And when we are out of the while loop, please just print loop ended. Let me run the code and we see the details. Okay, enter numbers. So I ran the program. We are now here. It is executing enter numbers, type -1 to stop. Exactly this line. Okay, I would say 20. It says you entered 20. And again, it is waiting for me to write another number. I would say again 20. It says you entered 20. I would say 12. It says you entered 12. 15, 17, 18, 22. Whatever you put here, it is going to continuously ask from you that give me a number unless I type -1. So when I type -1, it says loop ended. Why? Because when I type number 1 is stored using this line and it checks to see if the entered number equals -1 or not. In this case, it is equal, then it's going to break. When it breaks, we get out of this loop and it is going to print loop ended. So this is how we use the break keyword in C++, and generally it is very useful in different programs that we are going to practice in the future. Whenever a certain condition is met, okay, get out of the loop, get out of this if else condition. It is very useful for us. So it is good to start using it whenever it is possible, so you get used to its usage and you get comfortable with the syntax and the way to use the break function and to see if you're doing everything correctly or not. Therefore, please practice this exercise yourself as well and try to write this program several times so you can exactly remember when and how you need to use the break keyword. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to review the usage of the continue keyword and we are going to learn about the goto keyword. So we would like to write a program that asks a user for a positive number. If the user enters -1, we would like to terminate the program, and if the user enters any negative number, we would like to let the user know that negative numbers are not allowed and let the user continue entering the number. So this program is going to continue until the user enters -1. To do that, we declare an integer variable. Then we show the user saying that enter a positive number and -1 to terminate the program. So we are going to define a while loop, which is an infinite one in this case here, because the condition is true. And then as long as the user is not entering -1, this while loop is going to repeat because it is an infinite while loop. Why? Because within the parentheses, the condition is true. So we read the number from the user. We check if the number equals -1 or not. If the number equals -1, it is going to use the go-to keyword and it is going to jump to end. Where is end? End is here. Okay, so it is going to escape all these parts and it's going to jump here and print program terminated. So this is how the go-to keyword will work. And in case the num is lower than 0, it is going to print out numbers, negative numbers are not allowed, and then continue. When it continues, it means that do nothing, escape, and since there is an infinite while loop, it is going back up again, and let the user choose another number and then check if it's -1 or not, etc. So let me just run the code. I would say 20. It says you enter 20, 15, 17, 18, whatever, 20, -20. When I say -20, it says numbers are not allowed, exactly like here. And then I am allowed to write another number like 21. Okay, this is going to continue until the end of the word unless I enter -1. When I enter -1, program terminated. So when I enter -1, it is going to jump to the end and then write it here. We could also use the break function here. We could simply mention if this happened, break the program. Usually, when we are having different situations, we are going to use different keywords. In this case, we wanted to practice goto, but as we mentioned earlier, there are different ways to execute one program. It depends on your taste, what you would like to do with your code, how efficient and readable your code you think you might be by using one keyword or another. So it depends on you, but this was a review of the continue keyword and also the usage of the go-to keyword. So please go ahead and practice. And while you are doing different coding practices throughout this course, think about the places that you may be able to use break keyword, continue keyword, or go-to keyword. They are very useful. Try to practice them. So basically, when you practice, you will get used to using them where necessary. Thank you for watching. Hello everyone, welcome to this lecture. In today's lecture, we're going to introduce arrays. So arrays are basically fundamental data structures in C++ and any programming languages. And they are important because they allow us to store multiple elements of the same time in a single block of memory. So let me give you an example. So we would like to write a program to store 5 numbers in an array and then print them. In order to do that, previously we know from the integer data type we could simply just declare and initialize one number, two numbers, three numbers, four numbers, but they were initialized and declared separately. Here, using arrays, we can do them, we can do it and like declare all of these numbers in a single block of memory. How we are going to do it? Okay, so this is how we declare and initialize an array. So this is the name of the array, which is numbers. This is the size of the array, meaning that this array is having 5 elements, and then this is the data type of the array, which is integer. And when we want to declare and initialize an array, we're going to say that, for example, the data type, in this case int, numbers, the name, and within the bracket we put the number of element of the array, and then equals, and then we write down the element itself. So previously we used to write it something like int a equals 10, for example, int b equals 20, for example, etc. And when we wanted to print them, we were printing them separately. We were just typing it like the value of A is, for example, A and L. So this way we were printing A, and the same way we were printing B, for example. Here we write down B, here we write down B. So this was the old method that we use to print elements and declare and initialize them. However, using an array, we can just declare and initialize all of them in a single block of memory, just like this line. Okay, so we would like to write a program to store 5 numbers in an array. That we did, and print them. In order to print an array, because there are multiple elements in the array, we need to use the for loops. So in order to use the for loops, we are going to iterate over each element of the array and print them one by one. Let me explain you in the code. So we say the numbers in the array are, and then we go to the next line. Then we have our for loops here. So int I equals 0, it starts from 0 and it goes to 5 because we have 5 numbers, 5 elements in this array. And then we increment the value of I one by one. Then we see out numbers, which is the name of the array. Within the bracket we mentioned the I because it's going to print the first time. Let me just type it down here. In the first iteration, I equals 0 and it enters the loop. Then we have the numbers 0, so it will be printing the first element of the array number. When it is printed, it goes back up and I is incremented by 1 value. Then I now equals 1. Then it comes back and enter the loops and it will print the numbers 1. And the second element, because in here we are starting from 0, now 1 equals the second element of the array. It is going to print the second element of the array, and then it goes back up again and I is incremented by 1 value. Now I equals 2. When I equals 2, we are having the numbers and the third element of the number. So the first element of the array number equals 10. So in the first iteration, we are printing 10. In the second iteration, we are printing 20. In the third iteration, we are printing 30. And it continues until we have numbers 3, it equals 40. And finally, numbers 4 equals 50. So please note that we started from 0. So this is why we are ending at 4. But all in all, you will see that 5 elements are being printed here. Therefore, all of the elements of the array is expected to be printed. Let me run the code and see how it works. Okay, great. So as we can see here, the numbers in the array are, so this line is printed, then it is printing 10, 20, 30, 40, and why there is a space between them. The reason that there is a space between them is that because when we are printing the element, the ith element of array number, we are having one space here. So this is why we are seeing that 10 and then space 20 space 30 space 40 space 50. So this is why we are having this space. So to summarize, we learned that we can have we can have an array to store multiple elements of the same type in a single block of memory like this. And when we are going to print elements of an array, we need to use for loops to do that. And why we need the for loops? Because there are many elements. There might be several elements, a few elements in an array, so it's not a single element. There are a few elements that if we want to have an efficient code, we can just iterate over each one of the elements and then print them instead of just manually printing them one by one. Thank you for watching. In next videos, we're going to do some coding exercises regarding the arrays. Hello everyone, welcome back. In today's video, we are going to do some coding exercises for the arrays. So we would like to write a program to find the largest number in an array of 5 integers. First, we learn that how to declare and initialize an array. Here we need to declare and initialize an array with 5 elements. So, and the elements should be integers. So we know that in the declaration we write down int, then the name, and then 5 elements, and we just randomly put some numbers, 5 elements for the array. And then we need to know how to find the largest number in this array. To do that, initially we initialize one integer as to be the first element, as to be equal to the first element of an array. This is just an assumption. We are going to first assign the first element of an array to this max integer initially, and then we are going to perform some tasks on and some iteration over the different elements of the array, and then we are comparing each element of the array with this max integer. So if a number in an array, if an element in an array is larger than this max value, we are going to assign that number to max. To do that, we need a for loop. So here we declare and initialize the array. Then we are initializing the max to be the first element of the array. This is just an assumption. We can put it to be like the second element, the last element. This is just an assumption to start from somewhere. Then, in order to find the maximum element in the array, we are going to have a for loop. So we are going to have a for loop that is int I equals 1, I lower than 5, I plus plus. And because already the first element is assigned to the max, we are not going to iterate over that. We could do it, but it's redundant because already we know that the first element equals max, so we're not going to iterate over that. So this is why we suggest to assume that max equals the first element. However, you can iterate over all of the elements and assume that max equals any of the elements. It's okay. So we are iterating from the second element till the end, and we are defining an if condition here. We are saying that if the element I of the array number is larger than the value stored in integer max, if this is true, enter this condition and assign that value to our max integer. So for example, let me just explain how it works. So initially max equals 45, and then for the first time when we enter this loop, we have the numbers 1, okay, which equals 12. And in this situation, when I equals 1, we have numbers 1. So numbers 1 means that the second element of the array numbers. And why, when we are writing down 1 here, why we are saying the second element? Because in C++ we start from 0. The first element is it's written like this: 0 element of number means the first element. Therefore, the first element, when we're writing the 1 value here, it means the second element. Okay, so it starts from 0. When it's 1, it means the second element. So it is entering the loop with I equals 1. I equals 1 when it is talking about the 1 element, the second element of the array number. it equals 12. So it is saying that 12 is 12 larger than max? No. So it's not going to enter the loop because max is already 45, so it's not going to enter this if condition. Then I value is incremented by 1 and I equals 2. When I equals 2, let me just write it down in the next line. So max still equals 45. We are discussing the third element of the array number, which is 78. So I equals 2 meaning that it is the third element of the array number equals 78. So it says that 78 is larger than 45. Yes, it enters the condition and then assigns number 78 or the third element of array numbers to the max. So now max is updated. After implementing this part, max equals 78. Okay. Then this condition is finished. We go up and we increase the value of I to be 3. So now max equals 78 numbers. So this is going to give us the fourth element of the array, which is 34. So it is basically in this condition saying that is the fourth element of array number, which equals 34, larger than the integer max, which is 78? No, it's not. Then it's not going to enter this if condition. And then max remains the same. Max remains the same, and numbers, we increment the value of I by 1, which is its max value now, because for I must be lower than 5, not lower than or equal than 5. So now I is 4. It's going to discuss the fifth element of array number, which is 56. So it is basically asking, is 56 larger than 78? No, it's not. Therefore, it's not going to enter the if-else condition again. And when everything is done, so that in the next round, we are not going to enter the for loop because now I is incremented by another one value. It will become 5. 5 is not lower than 5. Then it's not passing this condition and it's not going to enter this for loop anymore. In the end, it is printing the largest number in the array is max, and max equals 78 as we analyze the code. So let's run the code and see how it works. Okay, great. So here we see the largest number in the array is 78. So this is the procedure how we can find the largest value in an array. If we want to find the smallest number in an array, we simply just reverse the code and we're just putting is number lower than max, and if this condition passes, we are assigning that number if into the max. Thank you for watching. Hello everyone, welcome back. In today's lecture, we are going to do another coding exercises for arrays. We are going to write a program that takes 5 numbers as input and store them in an array. And then it calculates their average. To do that, first we initialize an array with the size 5. It is named numbers and its type is double. And in order to have an average, we first need to know their sum. So we are initializing a double sum equals to 0. It is initialized to 0. In order to get a lot of data from the user, not just one input, but as large as the elements of our array, we need to use a for loop. In order to do that, we mention, okay, enter 5 numbers, and then we enter the loop. I equals 0, and I, as long as I is lower than 5, we are going to iterate in this for loop again and again. And in each iteration, we are mentioning that, okay, now enter the ith element of the array. So for the first time, it's going to mention, okay, numbers 0, numbers 1, numbers 2, numbers 3, and finally numbers 4. So it is going to ask you enter 5 numbers, and then you're going to enter 5 numbers continuously, and you're separating them with the enter button. So the first number you are entering, it is going to be stored in the first element of the array number using this line. And the second number you are entering, it is going to be stored in the second element of the array number again here, because I is incremented one by one. So the first time I is 0, I enters, and then you're writing down the number 0 like this. And then I is incremented and it's now 1. Then what you're entering is stored to the second element of the array number. Then I is incremented one more time and it is 2. Now what you're entering is going to store in the third element, in the fourth element, and in the fifth element of the array number. So this is how the procedure would be when we are going to store some elements in the array. And finally, after each iteration, it is going to store the sum of these numbers. So this sum was initialized to be 0, but whatever you're entering, it is going to be added to sum. So the first time, let me just run the code once. It says enter 5 numbers. I would say 1, 2, 5, 7, 9. Okay, so we are not going to talk about this line yet. Let me just talk about the above line. Okay, now it's good. So it says enter 5 numbers. So I entered 1. 1 is now the element, the first element of the array. Now sum was originally equal to 0. We initialized it. Now 1 is added to sum. Okay, now sum is 1. Then it is asking me, so they are going to be done after another. Okay, one after another. So this line is going to store, and then this line right after that is going to assign the number to sum. So then I'm entering the second element, which is 2, and it's going to be stored using this line. Like we are saying that, okay, now I equals 1. I equals 1 means that it's going to store the second element, and for the second element I'm entering 2. So for the second element I'm entering 2, and sum was already 1, and now 2 is added to that one, so the sum equals 3 now. And then I increased by another value for the next round that it enters the loop. Now I equals 2, and it is what I'm entering here, like number 5 is going to be assigned to the third element of array numbers. Okay, and 5 is going to be added to the already value of the sum, which is 3, because the first time was 1, the second time was 3. So sum initially it is 0, then it is 1, then it is 3, and then let me give you the details. I will write down the next steps, but when I equals 0, we are going to write down the first element of the number, and we mentioned that we have the first element equals 1. So 1 is stored as the first element of the array numbers, and 1, so initially sum equals 0, and 1 is added to sum. So now sum equals 1. okay? Then I is incremented. Now I equals 1. When I equals 1, we are going to enter the second element, which is 2. So we enter 2, the second element of the array is stored, and then 2 is added to this 1, because sum equals sum plus numbers I here. So having this equation is equal to have sum plus equal numbers I, okay? So they are the same equation, this equation and this equation. Okay, so sum was already 1. Sum was already 1. And we added the number 2 here. So sum in the next round, sum equals 3. Okay. Then I equals 2, because in the next iteration I equals 2. When I equals 2, I entered number 5, which will be the third element of the array. So the third element of the array is stored as to be numbers 2. Okay. Then sum was already 3. Now I'm adding sum equals 3 plus 5. So then sum becomes 8. So the next value of the sum will be 8. And then we are increasing the value of the I another time and another time until the end. So we are entering all elements, and each element is being accumulated in the sum one by one when they are added. And when everything is finished here, we are just printing the value of the average. How? We are initializing a double called average, and the sum is divided by the number of the elements of the array. In this case, it is 5. And then we are printing out the output. So based on our input here, like 1, 2, 5, 7, 9, let me just print also the value of sum here. Cout the value of sum equals, then we are printing sum here and del. So 1, 2, 5, 7, 9. Okay, let me just 1, 2, 5, 7, oops, 9. Okay. So here we are seeing that the total value of sum is 24 and the average is 4.8. And if you would like to see the increment value of sum in each iteration, I can simply print it here. So we can see how sum is incremented. 1, 2, 5, 7, 9. 1, 2, 5, 7, 9. Okay. So now we are printing the incremental value. So initially, sum was 0. Then I added 1. So sum became 1, exactly as we wrote here. Sum became 1. Then we added 2 as the second element. So the sum became 3. Then we added 5. So the sum became 8, exactly like we calculated here. So basically, we are saying sum was 0 first. We added 1 value, it became 1. We added another 2 value, it became 3. We added another 5 value, it became 8. Another 7 value, it became 15. And another 9 value, it became 24. And then this number is divided by 5, the total number of elements in the array, and the average is calculated this way. So this exercise was very easy and straightforward. However, in order for you to get used to how arrays work and how we enter, we can read the elements of an array as the input values, and then how to work with them, how to print them, how to calculate the sum and average. It would be nice for you to do some coding exercises and start implementing these coding exercises that I have solved so far, so you can first master the basics of an array before we move to further exercises. Thank you for watching.
Everyone, welcome to another lesson. In today's video, we are going to learn how to integrate arrays in and functions. So we know that in order to reduce the amount of repeated information in the code, we need to write functions. So simply in the int main function, we call another function or many other functions that do certain things for us instead of just repeating those operations in the main body of the code. To do that, we use functions. So for example, if we would like to know the sum of a few numbers, we can define a function that does the sum of two numbers, for example, for us. And every time we call the function, it is going to give us the sum of those two numbers. So this would help us to write down the operations to do the summation only once. However, we can call it several times instead of writing the summation operations several times in the main code. So this is why we actually need to write the functions. For example, here is a void function that we have here, and simply we are just calling the function and everything done, everything else is taken care of. So in this section, we are going to pass an array as an argument to a function, and the function is going to do some operations with this. So what is the operation? We are asked to write a program that prints all the elements of an array using a function. So the statement itself says that, okay, print all the elements using a function. So don't do it in the int main function, but define a separate function. In order for you to review the basics of functions, there are three things that we need to take care of when we are looking at a function. So the first one is the name. Behind the name, it's the type of the function. So it's a void function. It can be int function, float function, double function. But when it's a void function, it is not going to return anything. If it's a function of any other kind, for example, here we have an int, we're going to return some value. If it's a float or whatever, there is a return value to be passed. But for a void function, we have no output. It's just going to do certain tasks for us or maybe print something for us, and that's it. So first thing is the name, then the type of the function, and in the parentheses, we have the arguments of the function that are separated with a comma. So we would like to write a function that takes one array and it's going to print the array. To do that, we declare and initialize the array like this. We learned it before. So we are saying that the name of the array is numbers and the type of the array is int. However, the size of the array is not indicated, but it's okay. I could tell 5, it's okay. But even if I don't tell it that the size of the array is 5, it can determine it itself because there are 5 elements in this array. So it's up to you. You can write it down, or it's okay if you want to escape it. Then we need to know the size of the array. So there is a predefined expression in C++ that gives us the size of the array or of one element, one integer, etc. And it's the size of. So using this, we calculate the size of this array. How to do it? This is a formula. So we initialize one integer called size, and we divide the size of the array by the size of the first element. Why do we do that? So by doing this, for example, we are having an array of 5 elements. And when we are calculating the size of the full array, and each element is going to, for example, take 4 bytes of the memory. When we have 5 elements, it's going to
take 20 bytes, and then when we divide it by one of the elements, we are going to understand how many elements it's having. For example, assume that each element is consuming 4 bytes of memory. So when we have 5 elements, it's going to have 5 times 4, it's going to have 20, it is going to consume 20 bytes of memory. So uh, on top we have the number 20, and it is divided by the size of element 1, which is 4. Then 20 divided by 4, the result would be 5, which is the number of elements in the array. So this is how we are calculating the number of elements in one array. The total size, the total bytes that are using the memory divided by the first one, or any of them, like the second one, the third one, because they are going to take the same amount of memory, each of the elements. So this way we are calculating the number of elements, okay? And we assign it to size. Then we are calling a function, and we are passing 2 arguments. Why 2 arguments? Because this function is defined and initialized with 2 arguments. The first element is the array, the second argument is the first argument is the array, and the second argument is the size of the array. So here we are passing as the first argument, we are passing the array itself and then its size. Okay, we are calling the function. We go up here and we enter the function. It is getting the array and its size. So it is counting, printing array elements are. Then in order to print all the elements of an array, we need to iterate over all the elements. To do that, it's easy to use for loops. So we're going to use a for loop, but why do we need the size? Because we would like to automate things. Because of that, we can mention, okay, it's going to start from 0 as the first element of the array, and it is going to go up to the size of the array. Okay, so this is why we need the size. And then we are going to increase the value of I one by one. To do that, let me run the code once so we see the result, and then we continue with analyzing the code. Okay, great. So here it is saying that array elements are 10, 20, 30, 40, and 50. It's printing everything. So this is what we wanted. And there is one space between each of the elements. That space comes from here. So let's start by analyzing the code again. So the first time that we entered the array, we entered the for loops, sorry, I equals 0. When I equals 0, it is going to print the first element of the array using this line, ARR, ith element of the array. In this case, because I equals 0 and C++ starts from 0 basically, and we are here starting from 0, therefore it is going to print the first element of the array, and the first element of the array is 10. Okay, then it's going to go up again. We increase the value of I by 1, so I is now equal to 1, and then we are going to print the second element of the array, which is 20, and then again it goes up again and increase the value of I by 1 value. So now this time we enter the loop I equals 2, and we are going to print the third element of the array, which is 30, etc. until the end. So this is exactly what we got as the output here. So basically, instead of doing all of these tasks in the main function, we are just simply calling a function that does this for us. So our int main function remains very clean. So this is the first thing. And the second thing I would like to highlight is the size. So we learned how to calculate the size of an array. So now we know if we have an array of 10 elements, we know how to calculate the number of elements in that array. This is one thing. And the second thing is that we passed the size instead of, okay, calculating, okay, this array is having 5 elements. So instead of writing size, I'm going to write 5. Instead of doing this, we automated things. So the size is simply replaced here. Why? Because every time that you're dealing with an array and you're calling the function, you don't have to change this number anymore. So because you may have another array with the size of 3, 10, 15, etc. So you're automating things, whatever the size is, the function is going to work instead of just manually changing the size here. Thank you for watching. In the next video, we are going to do another coding exercise using functions and arrays. Hello everyone, welcome back. In today's video, we are going to we are going to code another exercise. And in today's lesson, we would like to write a function that count the number of even and odd numbers in an array. So we need to write a function that in the end iterates over all the elements of a function and tell us how many odd numbers and how many even numbers are included in that array. To do that, we need a function to make the code very clean. So we start with the int main function. We initialize one array. By now we know how to declare and initialize an array. Then we calculate the size. In order to calculate the size of an array, we calculate the size of the array divided by the size of the first element. So this way we know how many elements are included uh, in this array. And then in order to count the number of even and odd numbers, we just declare two new integers like even count and odd count. So then we call our function and we are passing 4 arguments. The first one is the array, the second one is the size of the array, and the third and the fourth one are the integers that we declared here that they are going to do the counting for us to count the number of even numbers and odd numbers in this array. So let's go up here. When we call the function, we are coming up here. The name of the function is here. It's the void type. In the parentheses, we see the arguments. We see 4 arguments here separated by comma. So the first one is the array of type int. The second one is the size of the array by type int. The third one and fourth one also they are type int. However, they are passed by reference. So let me review the concept of passed by value and passed by reference one time here. So you see these two values are passed by value because there is no and sign behind them, before them. It's a passed by value. So basically in passed by value, we are making a copy of the original numbers or arrays, and we send the copy of them to the function and let the function to work with the copy. So any modification that is made to the array or the size integer is going to be locally implemented here, and it's not going to have any impact in the array and the size in the main function, because this function is working with a copy of the original value because it's a call by value. Okay. However, when we are doing the call by reference and the sign is having this and behind before the name of the integers, we are calling by reference, and calling by reference means that we are giving the address where these two values are stored in the memory, and it is going and directly working with the original values. Therefore, it is making modifications to these values. So any changes that are done here is going to impact on these two. So this is the basic concept of call by reference and call by value, and why we are passing these two why we are passing these two arguments using call by reference, because this function is actually going to count the number of even and odd numbers for us. Therefore, it's important to know the output value in this main function as well. This is why we need a call by reference. But for the first two values, we don't need any output from this function for these two arguments. Therefore, we are just calling by value. Okay, now that we know the difference between call by reference and call by value, we are initializing these two past numbers to 0 because they were only declared and they were not initialized. We are initializing them here. In order to iterate over all the elements of an array, we need to use for loops. So we start from 0 and we go up to the size. This we know from before, and we are increasing the value of I one by one. So we are going through all the elements one by one. And then in order to see if a number is odd or even, we need to define if-else conditions. To do that, we say if the ith element of array is divided by 2 and its remainder, using modulo sign here, and its remainder equals 0, it means the number is even. Therefore, increase the value of even count by 1 because we found one even number. And if this condition is not going to pass, go to the else, because if the number is not even, it is for sure an odd number, and increase the odd. Okay, let me make some further analyze of the code here, so it would be easier to follow. So we are starting to we start to go through all the elements of the array here, and the first one is 10. So I equals 0, we enter the loop. Here I equals 0, we enter the loop, and it is investigating to see if the first element, the ith element of the array, which is the first one in this case, because I equals 0, if this number is divided by 2, its remainder equals 0 or not. The first element of the array is 10. So 10 divided by 2, the remainder will be 0. Yes? So the remainder equals 0. Therefore, it's an even number. So we say even count equals 1 now. Then, when this condition is passed, we are going up again, and now I equals 1. Therefore, we are investigating the second element of the array. So we are saying that basically we are entering with I equals 1. We are basically discussing array in the bracket 1, which is the second element of the array, which is 15. And we are basically saying that if 15 is divided by 2, its remainder equals to 0 or not in this line. Okay? We are saying that 15 divided by 2, the remainder equals 0? No. When the answer is no, it's not going to enter to this part. It's going to escape because it's not passing the condition. Therefore, it is going to enter the else part, and it is increasing the value of odd count equals 1 now. And now that it's done, we go up again, we increase the value of I one more time, because it is going to iterate until I is lower than the size of the array. And the size of the array is 1, 2, 3, 4, 5, 6, 7. So I is going to take from 0 to 6. So I equals 2, and then we are discussing the third element of the array. So the third element is 20. We are basically in this condition discussing if 20 is divided by 2, the remainder will be equal to 0. Yes? Yes, this is true, because 20, if it's divided by 2, the output will be 10 and the remainder is 0. Therefore, we are going to increase the value of the even count another time. So this time it is equal to, because previously it was 1, and then we are increasing another time in this line, so it equals to. Okay, now I equals 3. We are basically discussing the fourth element of the array. So the fourth element is 25. I equals 3, it enters, it says that ARR in the bracket number 3, which is the fourth element of the array. If it's divided by 2, its remainder equals to 0 or not. So here basically 25, if it's divided by 2, the remainder is not going to be equal to 0. Therefore, it's not going to enter this condition, and it's going to enter else. And when it enters else, it's going to increase the odd count integer by another 1 value. So odd count, previously we had it here, it was equal to 1. And now we are going to add another 1 number to it, so it is going to equal to 2. So basically this is the logic of the code. Now if I run, you will see how many odd and even numbers we have in this array. So basically 1, 2, 3, and 4 even numbers are included in this array, and we have 3 odd numbers in this array. So let's run. Okay, great. We see exactly like the number of even numbers and number of odd numbers. Okay, so here we do all of the calculation, that we call the function here, and we do all of the calculation here. After everything is finished, we are coming back to the main function, of course, and we are going to print number of even numbers, or we are printing the even count, and number of odd numbers, we are going to print odd count. Okay, and we see that the number of even numbers is 4 equals to 4, and odd numbers equals to 3. This is what we expected actually. And the important thing, just to summarize and highlight, is to do this by calling by reference, because these two numbers are going to change here. We are actually calculating their value one by one. Here we are incrementing their value, and then we are printing the final value that we got here in the main function. So if it's a call by value, it's not going to have the output the correct number, because it's not going to change. When the function is finished, it's finished, and everything else is deleted. Thank you for watching. Please make sure that you do these coding exercises yourself, because it's very important. They may seem and they may look easy and understandable, but you will never make errors until you do it yourself. So please do go ahead and do it yourself. Please make errors, because it's important to know where the errors come from, and then you can improve from there. And you can always come back to these videos and review the logic and analyzing the code, so you will find exactly how you need to improve your coding. Thank you for watching. Hello everyone, welcome back to another coding exercise session. In today's video, we are going to do coding exercises with respect to the arrays and functions. So we would like to write a program that checks whether a given number exists in an array using a function. So basically what we understand from this statement is that we need to write a function that checks if a given number exists as one element of the array or not. So To do that, we have the int main function here. We are initializing and declaring one array. We know from before how to do it. Then we are calculating its size to see how many elements this array is carrying. In this case, it's going to be 5. And then we are initializing the target, we are declaring the target integer, which is the given number that is going to either be decided that its number is it included in this array or not. So this target is going to be read from the user. Like I'm going to enter like one number as for example 7, and we need a function to see if this number 7 is included in this array or not. Is it one of the elements of this array or not? So this function is basically going to do that. So we initialize the target integer, and we are sending a message to the user saying that enter a number to search, and then we are storing it using a scene syntax. And basically we are checking here if search element, the search element is the function that we define to do the checking for us, and we are passing three values, three arguments. First the array, second the size, and third the target number. So we are simply here, we are saying that if something is true here, just print that we found that number, that target number in the array. Otherwise, print that it's not in the array. From this if condition, we understand that this function is having is of a Boolean type. Why? Because we are saying that if this statement is returning true, go ahead and print the target number and mention that it is found in the array. Otherwise, say that this target number is not included in the array. So let's go and see how we are doing this calculation using search element function. When we call the function here, we go up with three arguments: array, its size, and the input target number by the user. We go up here and we see that the type of the function, as we discussed, it's a Boolean. So it's going to return something for us. It's going to return either true or false. Basically, we can guess. So if the target integer is one of the elements of the array, it's going to return true. If the element is found in the array, it is going to return true, and otherwise it's going to return false. So when it is going to return true, it's going to print that the target number is found in the array, and when it's going to return false, it's going to mention the target number is not in the array. So basically this function, this is the name, this is the type, which is Boolean, and these are the arguments of the function that are separated using commas. So the first one is the array, the second one is the size of the array, and the third one is the target number. And all of them are passed by value because we are not going to make any modification to them. We're just going to work with their values. This is why we're not calling them by reference. So in order to see if one one integer is actually equal to one of the elements of the array, we need to iterate over all the elements of the array to see if one of them matches this target number. To do that, we use a for loop to iterate over all the elements of the array. So we start from 0 and we go up to the size of the array, which is 5 in this case. And one by one, when we are passing through, we are saying that, okay, is this element equal, is this target number equals to element ith of that array. So let me just analyze the code further. It's more clear for you to understand. So let me just mention that, for example, I choose the target number to be like 18. Okay, so I would say target equals 18. So when target equals 18, initially I equals 0 at in, and it's going to enter the for loop. So when I equals 0, it is going to investigate whether the first element of the array equals target or not. And this means that we are checking to see if 5 equals 18. How? So I chose 18 to be the integer target, I equals 0, and when I equals 0, when we are investigating this condition, we are basically investigating this. So the first element of the array, is it equal to the target number? And basically it means that the first element of the array is 5 and the target equals 18. Therefore, we are mentioning if 5 equals 18. So if this is the case, it is going to return true. So it is existing, it exists, and it's going to return true here. And then we are getting out of the loop and we are simply printing that, okay, the target number is found in the array. But in this case, this is not the case for us, okay? So as this is not the case, target is still 18 because we are not going to change it. It's a one-time chosen value. Then it is going to investigate I equals 1, which happens to be something like this. So when I equals 1, we are simply saying that, okay, the second element of the array equals to target or not. In this condition, we are investigating this. And since the second element of the array is 10, we are basically investigating if 10 equals 18 or not. This is not true, okay? So when it is not true, again, it is going up and increasing the value of I by another and of I by another one value. So now I equals 2, which means that we are going to investigate the third element of the array. So when we are investigating the third element of the array, we are basically mentioning, is 15 equal 18? No, it's not true again. So it's going to go to another round of the loop. This time again, target is 18, I equals 3, I equals 3, and it means that we are investigating uh, the fourth element of the array, meaning that we are saying, does 20 equal 18? No. And then for the last time, we are going to increase the value of I another time. So I equals 4 now. And then we are discussing the fifth element of the array. And we are basically saying, is 25 and 18, are these two numbers are equal? No, we didn't find any answer to return true because neither of these equations are correct. So it's not going to enter this if condition. When it's not going to enter this if condition, it's not going to return true. And then when it is exiting this condition and this for loop is finished because we reached its upper limit, which is 4. Why? Because when I is 4, it is lower than the size of the array, which is 5. So 4 lower than 5. When we are increasing the value of I another time, I becomes 5, then 5 is not lower than 5. Therefore, it's not going to do another for loop. So we exit here and we are simply saying that, okay, return false because we didn't find it. So basically, let me run the code and enter the target 18. We are expecting to see 18 is not in the array. So let me run. So enter to search. I'm saying 18. Okay, it is saying 18 is not in the array. Okay. So, and how it is deciding whether it's in the array or not, using these analyzes, we are understanding it. But what if we are mentioning number like 10 as the target value? If we mention the number 10 as the target value, so let me just revise these numbers. Okay. So if the target value is 10, I starts from 0. It is comparing the first element of the array, which is 5, with the target number, which is 10 now. And we are saying, okay, does these two numbers are equal or not? These two numbers are equal or not? So it's no. The answer is no. Therefore, we are going up again in the for loop statement, and we are increasing the value of I by another one value. So I equals 1 now because it starts from 0. Okay, I equals 1. So we are basically, when we are investigating this condition, we are basically saying that we would like to see if the second element of the array equals to the target value, which is 10. Basically, we are saying, does 10 equal 10? Yes, the answer is yes. When this makes sense, when this condition makes sense, it actually enters this condition to return true. When it returns true, the work of the function is done, it's finished. And here it is simply mentioning that, okay, target value is found in the array. So because when it returns true, this if statement becomes true, and then it enters this part. And when it enters this part, it's going to print it. So let me just choose the input target value to be 10. Okay, it says that 10 is found in the array. So basically, this is how we did the coding exercise, and we analyze the code. It would be nice for you also to start doing these analyses for yourself to make sure you understand all the steps one by one. This helps you to remember how the program works, and it will be beneficial for you in the future. When you are writing your code, you can imagine, okay, if I write it this way, it's going to work this way. So this is what we want, or this is not what we want. So I'm going to change or modify the path, etc. So please go ahead and do this exercise yourself, because as we progress, there are many coding exercises that we are going to do. So try to start the coding exercises and do the coding exercises yourself as you proceed throughout this journey. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to do another coding exercises using static array. Okay, so far we learned how important it is to consider static array in certain situations. In this video, we are going to write a program that uses a static array to store user input values across multiple function calls. So to do that, we have the main function and then another function that we are going to call repeatedly during in our main function. So the name of the function is store user input. It's of the void type, and its argument is an integer called value. So in order to call it for the first time, we call the function with the value 5. Here we are initializing and declaring a static array with the size of 3, and all of the elements are 0. And then we are initializing and declaring an index to be static and integers set to be 0 initially. So this is index is used to track where to store the next input. So in the first call, index equals 0. So when we are encountering this if condition, we say, okay, 0 lower than 3. If this is the case, set the value, which is the argument of this function, which is 5 in the first run, in the first call of the function. Set the value 5 as the first index of the user input array. After doing that, then increase the index by 1. So in the initial run, it's like this equals to 5. It means that set the value 5 to be the first element of the user input array, and then the final index will become 1. Initial index equals to 0. Why initial index equals to 0? Because we initialize it. And why the final index equals to 1? Because after we set the 5 to be the first element of the user input array in this line, we are having plus plus sign here. So when we are having the plus plus sign, it's going to increase the value of index by 1. So the final index after this line will be equal to 1. Then we are simply printing the value. Value is number 5 because this is the argument of the function, which is defined here, and then it is being simply printed here. So whatever the number is being assigned to the first element of the array is being printed here. So we know what has been passed and what has been inserted to the array, just for the sake of checking. Okay. Then we have this else part as well. If this index is not lower than 3, it's going to enter this else part. There it is printing array is full, so stored values are, it is going to print all the elements of the array using a for loop, and the for loop is going to start from 0 to 3, which is the size of the array, and it's going to print all the elements of the user input array. So when I equals 0, it's going to print the first element. When I equals 1, it's going to print the second element. When I equals, for example, to 2, it's going to print the last or the third value. So one time the first call of the function is now finished. The program is executed, so the program goes to the next line and it's going to call the function again with the argument of 10. So now value equals 10, but because we are using a static array and index, now the program remembers that one time we already called the function one time, and it remembers that we did some modification to the first element of this array and also to this index number. So now that it enters this function, it goes to this if condition here, but it is not considering index to be 0, but it is considering index to be 1 because it remembers that we did some modification in the previous call for this function. So this is why actually the static variables are useful. So initial index in this case equals 1, and basically it is saying user inputs 1 equals 10, and final index equals 2. So it basically says that, okay, the index now is 1. 1 is lower than 3. That is true. So it is going to enter this part. When entering this part, it's going to assign the argument, which was 10 in our case, to be the second element of the user input array. Why second element? Because the index now is 1 and C++ starts from 0. So 0 When index is 0, we are talking about the first element. When index is 1, we are talking about the second element, okay? So it is going to assign 10 as to be the second element of the user input array. When this has been done, we are going to increase the value of index by 1, so the final index will be 2 again, okay? And we are going to call the function for the third time. Now the initial index equals 2 because it is an static int index. It is declared to be a static int. So the program remembers the modification. And also because the array is a static, it remembers we modified its elements. So it's not going to start from 0 again. And now user inputs 2 equals 15 and final index will be 3. How come? Okay, let's see. So the initial index value is 2. 2 is lower than 3. It's going to enter. So the argument that is passed to this function is 15. Therefore, the value is 15. The int value is 15. So 15 is going to be assigned to the third element or the last element of the user input array, after which we are going to increase the value of index, which was 2 and now it's 3. Okay, and in the meantime we were always printing the values that were passed to this function. So now index equals 2, and when we finish the execution of this line, final index is 3. So when we call the function one more time with the argument 20, it is going to say 3, which is the final value of index. Is it lower than 3? No, it's not. When it's not going to execute this part of the code, and it goes directly to the else part, which is this part. So when it comes here, it is going to say array is full. Why it is full? Because the size of the array was 3 and we already had stored 3 values in it. Therefore, and 3 is not lower than 3. Therefore, it is not executing this part. And now we see that 3 values are stored in the array, as you see here, 5, 10, and 15. And the size is 3. So it says array is full and it is printing all the elements of the array here for us. So let me just run and see the result. Okay, great. So in the first call, the value stored is 5. So as we discussed, the first element of the user input was set to be 5 and the value stored was 5, and the second value was 10 and then 15. And when we are passing the 20, it is not printing the 20. Instead, it says array is full because it is entering this else part. And then we are printing all the elements of the array, which are 5, 10, and 15. So the only reason that with every call, the program remembers what we have done and knows that, okay, the elements are different values and the index is updated progressively, and also the array is updated progressively, is because we are using the static keyword here. So if we don't use the static keyword here, you will see the difference. So you will see that it is printing 5, 10, 15, and 20. Why? Previously, when we reached 20, we saw that it was mentioning that the array is full, but it is not saying that. Why? Because index is 0 when the first call is done. 0 lower than 3, okay, and 5 is assigned to the first element of the user input array. We are increasing the value of index, and so index equals 1, and it is printing the value just like here, okay? And when we are calling the function the second time using this number, it is forgetting everything about the index value and the user input array. Because we are not using static, variables, it is not going to remember. So when the first call is done, everything executed, it is going